Python is a general-purpose interpreted programming language created by Guido van Rossum and was released in the year 1991. Python encourages code reusability and write fewer lines to express the concepts. Python supports both procedural as well as object-oriented programming. Many of the language features support functional programming and aspect-oriented programming too. The language was named after the popular TV show Monty Python's Flying Circus, which was telecast in BBC between 1969 and 74, and has nothing to do with the snake Python. Here are some of the salient features of Python. It's free, it's open source, it's a high-level programming language. Python programs are interpreted and hence are often referred as Python scripts. It offers portability, it is extensible, and has a vast library of packages which are reusable Python modules. Python, being a very simple and easy to learn language, can be used for teaching programming to kids and non-programmers. However, the language offers so many powerful features, it can be used for a variety of applications such as web applications, scientific and numeric applications, creating software prototypes, in data analytics, and in artificial intelligence applications too. In this lecture, let's have a look at how to install Python on Microsoft Windows. First, let's open a browser and visit python.org. As you can see here in the downloads, there is a big button here for Python 3.7.3. For older versions of Python, you may go to this particular link, but for this training, we're going to use Python 3.7.3. Click on this button. Now that the download is done, let's go and open the same. And that brings up a wizard which says here install now or customize the installation. We can go ahead with the default installation setup. This includes a simple editor and a runtime environment called idle. There's a package installer for Python, and documentation creates shortcuts on your desktop as well as associates the files such as .py files with the idle. Let's go ahead with this. A confirmation. So the setup was successful. Let's click on close and close the browser. Open a command prompt and check for Python version by typing python-version. In some cases like mine, so it says that Python is not recognized as an internal or external command. This is mainly because the Python was not added to your system path. So if I type the path, you can see that there is a bunch of folders here, but Python is not one of them. First, we have to find out where is Python. So let's go to our Windows Explorer. Let's go to C drive, users, Vinod Kumar. You may have to actually type in manually app data, local, programs, and Python. So this is the location where Python 3.7 has been installed. And as you can see that there is an executable here called Python. So we have to add this to our computer path. So let's copy this and then go to this PC, right click, properties, advanced system settings, environment variables. We can add either to the user variables for Vinod Kumar or we can add to system variables. As you can see that we already have one path entry over here. If it is not there, you can actually add a new one and name it as path. But since it is already there, I have to select this and click on edit. Add a new entry and I'm going to paste the path that I copied. Press enter. If you want, you can move this up in the order so that Python is found first. Say OK, OK, another time, and then close this system properties. Now if I open a new command prompt by typing cmd And now if I type Python dash dash version, we should see that it says 3.7.3. In this lecture, let's have a look at how to install Python on our computer. First, let's open a browser and visit python.org. And under the downloads menu, you can see that there is a button here called Python 3.7.3. For older versions, you can visit this one. But in this case, I want to download the latest one. Click on this button, select my desktop, click on save. Once the download has been completed, let's close Chrome. And we'll see that there is this Python 3.7.3 Mac OS X 10.9 package. So I just double click that. This brings up a wizard and it's a straightforward step-by-step installation procedure. So click on continue, read the license agreement, click on continue. A brief note about what versions of Python and what is shipped along with the Python is explained over here. Click on continue. There's the license agreement. Click on continue again. Agree the license. In case if you would like to change the Python's default location, you can click on this to change. I would like to keep it to the same. And then click install. Ask for the administrator privileges. And it has finished installation, and this is the location where I have a Python 3.7 and it says congratulations, Python 3.7.3 for Mac OS 10.9 or later was successfully installed. So let's click on close. I don't need this package file anymore. I can delete this. And now to check if Python has been successfully installed or not, let's open a terminal and check Python dash dash version. On Mac, you can see that it shows 2.7.10, and that's primarily because Mac OS comes with the Python by itself. The new version of Python has been installed with an alias of Python 3, and if I select that and check Python 3 dash dash version, now it says Python 3.7.3. So on Mac OS, you have to be extra careful that every time you want to execute a Python script, you type the command Python3 and the script file name. In this lecture, let's have a look at what's called REPL. REPL stands for Read, Evaluate, Print, and Loop. To understand this better, let's open a terminal and type Python3. And now you see you have been greeted with the version of Python. And then there is a bunch of message that it says type help, copyrights, credits, all licensed to find more information. And we see a new prompt over here. So this prompt is not your operating system prompt. For example, in my case, it's not a Mac OS prompt. In your case, it may not be the Windows command prompt, but it is a Python command prompt. Here you can type in any Python command. For example, we can start by typing print hello world. And when I press enter, this command is read, evaluated, the result is printed, and then it will wait for the next command, hence looping. So we call it as read, eval, print, and loop. You can type in any expressions like, for example, 100 into 12, or for that matter 2 to the power of 4, and so on and so forth. Throughout this course, we will be using this REPL so that we can learn certain commands very quickly, because the commands are going to be executed and instantaneously we will see the result. In this video, let's have a look at some of the most commonly used functions of Python. First, let's open a terminal or command prompt on Windows. Type in Python3 and get into the Python shell. Please remember that if you are using Windows, please use Python instead of Python3. The first command that we would be interested to work with is dir. So dir is a function that gives you some strange output. As you can see that here, a square bracket consisting of some strings here. Mostly they are double underscores. These are called dunders. We will discuss about them in detail as we go forward. But dir is giving you a list of strings which represent something called attributes. So if you don't supply any parameters to the dir brackets here, then it just lists out so-called modules that have been loaded into our Python environment. For example, we can load a module called sys by typing import sys, and now if I type dir, you should see that sys is the new entry over here. Similarly, if I type import datetime, you can see dir will now show you the datetime along with the sys because these are the modules that have been loaded. A module is simply a Python file that contains some useful code that we would be requiring to use in the future. But dir can also be supplied with some arguments. For example, if I type here dir of str, this time you may see a totally different set of entries. Now the entries here in this list are called attributes. Now the attributes you see here are the attributes of the class str here. Now at this time we may not know what is str, but in the future we're going to work on. But when we work with str, these things will be of some use. For example, I can also say here dir of int, where int represents an integer number. Now it shows the list of attributes that correspond to an int type. In both the cases, you can see that there are a lot of attributes that start with double underscore and end with the same. These are called dunder attributes, and for practical purposes, you should not be worrying about this at all. Which means that if you are working with an str or a string, these are the attributes that would be useful to us. And in case of an int, these are the attributes that will be useful for us to work with integers. The next function that we would like to work with here is a help. Help, as it indicates, gives you some help on certain things that you want. For example, if you would like to know what is str, you can simply say help str and press enter, and then it will give you a documentation for what is the meaning of an str, what are the various attributes that are there. So we just now saw some of the attributes over there. So the attributes are given some explanation here, each one of them. How do we use them? Is it a function or is it a variable? All those information would be available. To come out of this help, you can type Q and it will come out to your Python shell. You can also get help for a specific attribute of a class like str. First, let's give a dir str to see what are the attributes of them. For example, there is a isLower attribute. I can now say here help str.isLower, and then it will tell me what actually is that. It says that it is a method descriptor, method meaning function. Press Q to come out of that. Python allows us to create variables which represent some values. For example, I can say here my name equals to Vinod, and then I can say here a num equals to 12. What you see on the right hand side is a value or a literal, and that has been assigned to a storage location in the memory which is called as my underscore name. We refer to this as variables. A variable refers to an object. In this case, it's representing a string or an str. Enum is referring to a number called 12. To find out what is the data type of a variable, you can use the function called type. For example, I can say type my name. It will say that it is an str, and I can say type enum, is nothing but an int. Unlike many programming languages like Java or C++, which are called as strongly typed language, a variable must have a data type in those languages. Unlike them, in Python, a variable need not have any data type. Python variables borrow the data type from the assignment. For example, my name is an str at this point in time, but if I have to change my name equals to 123, which is totally possible, now my name is no longer an str, but it is an integer. And this type of data type association with variables is called dynamic data typing or dynamic typing. This means we never have to declare a variable before its usage. We just have to assign a value and then start using the variables. Talking about the variables, a variable once assigned with a value will have a unique ID. For example, I'll say n1 equals to 123. I can check its ID and I get a unique number displayed over here. If I type n2 equals to 200 and then ID of n2, you'll see that it's a different number. However, if n2 is going to point to the same number as n1, then there is only one instance of 123 where both n1 and n2 refer to. So if I check the ID of n2, which is identical to the ID of n1, and the reason for this is IDs are given to the objects on the right hand side, not onto the variables. If a variable now refers to a different object, its ID changes back. For example, if I say here n1 equals to 200, ID of n1, you can see that earlier we got the same number for n2, now I'm getting it for n1 because the ID of 200 is what we are actually getting. This can be used for checking whether two variables refer to the same object or not. So if n1 and n2 have the same ID, it means to say both n1 and n2 are referencing to the same object. A variable in Python represents a value. A variable by itself doesn't have a data type, but when you assign a value to a variable, the variable borrows its data type. If a variable has not been assigned, it has never been created, and if you try to access that, it's going to give you an error. For example, I just opened a new Python shell, and then if I type n1, which has no value because I never created this, it will give you an error called name error. Name n1 has not been defined. The way you can define them is by assigning a value. For example, I can say n1 equals to, in quotes, I'm giving Vinod. I can as well use a double quotes. They are interchangeable. We'll discuss this in strings later. But now that n1 exists, I can print what is there in n1. I can use that with an expression also. For example, I can say n1 equals to n1 plus Kumar. And now you can see n1 has been changed. Here I use the value of n1, which is Vinod, plus adding a new string, so making it as Vinod Kumar on the right hand side, which is then assigned back to n1. A value in the variable can also be printed using the print function like this. You can also print multiple values using the print function like this. I can say value of n1 is comma n1. Notice the print is given two values here. So the first one is a hard-coded text or an str, and then there is an n1. Press enter. You can see it says value of n1 is Vinod Kumar. I can also accept a value from the user by using the input command. For example, I can say n1 equals to input. I can say enter a name. So here it says enter a name. I can type here Kumar, press enter. You can see that it just came to the command prompt. But if I type n1, now you can see it says Kumar, or I can use the previous command that I said value of n1 is Kumar. At this point in time, N1 refers to an str, so I can type here type N1 to find out the same. I can also type dir N1 to say what are the attributes of N1. Now N1 is not a data type, but N1 is an str, so this is same as dir str. And these are the attributes of str, which means if they are functions, I can use N1 to call them. For example, I can check here N1 dot is lower and then press enter. You can say it says true. I can also say N1 dot upper, and then I should see that it should give me an uppercase version of the same. Depending on what kind of data that N1 refers to, each of these functions will vary. For example, if I type N1 equals to 100, and now if I type N1 dot is lower, you can see it gives me an error called attribute error because int does not have is lower. The moment we assign 100 to N1, N1 has no longer access to these attributes of str because it is no longer an str. Now it has access to different set of attributes. To find out the same, you can type dir N1 and you can see that it has attributes called bit length, conjugate, denominator, from bytes, imag, numerator, real or 2 bytes, etc. Some of these may be functions, some of these may be variables. You may have to find out by going to their documentation or asking for help. In this video, let's have a look at the numerical data types. Let's say I assign N1 equals to 100. We know that N1 is an int, so you can type N1 and it says int. However, int is not the only numerical data type that is available. I can also type here N1 equals to 100 dot. The presence of a dot makes it as a float. If I say type N1, it says float. In the older version of Python, that is Python2.x, there was a data type called long, which represented a bigger integer value. In Python 3, int and long are combined to the same int data type, which means I can assign a huge value and still get away with that. For example, I'm giving a very big number over here, and that's still a valid number, which means I can still work with this in arithmetic operations. For example, I can say N1 into 10, I'll get a bigger number. I can also type N1 square, and that's a bigger number too. And the limit of how big this number can go, you can only test by typing N1 star star, let's say 1, 2, 3, 4. And this is going to be a very huge number. So what I'll do is I'll reduce this to 12. So it is like this whole number raised to the power of 12, which itself happens to be a big number. I can go on and then check for a bigger number, and you can see that it still works. However, if you're working with a float data type, like for example N1 equals to say 12.34, this is automatically considered as float. And you can see dir N1 has a different set of functionalities or attributes compared to that of integers. When you are working with numbers, especially integers, the division operator is little peculiar. For example, if I say N1 equals to 12 and I can say N1 divided by 10, it says 1.2. But if I wanted only the integer part of this, such as for example the quotient of division, not the actual floating point number, you may have to use double slash and then you get this one. For example, 22 by 7 would show you something like this. But if I say 22 by 7 with a double slash, we will get 3 because that's the quotient. You can also get the remainder. So by using the percentage symbol, which happens to be 1. And as we have already seen, the double star represents power operator. For example, this is equivalent to 2 to the power 10. I don't have to give spaces over there. I can as well give like this. That's perfectly all right. And we have the other common operators like plus, minus, star, slash for add, subtract, multiplication, and division. One very important point you may have to keep in mind when you are working with the numericals is that you cannot accept using the input something like enter a number. The user may enter a number like 222 in this case, but if I say type of n1, it is nothing but str. So if you try to say n1 plus, say for example 100, assuming that the result is supposed to be 322, you will be wrong, and you can see that it gives me an error saying that you can only concatenate str, not int. The word concatenate corresponds to adding up of two strings like Vinod plus Kumar, so which becomes Vinod Kumar eventually, right? So in this case, this returns an str. So n1 is an str. Str plus can only be another str. It cannot be an int. But I wanted an int in the first place here. Now this cannot be done with the help of input, but what we can do is we can convert the return value of the input function, which happens to be an str, into an int before storing. And that is done by using the int constructor. So I can say here n1 equals to int, and then I can type here input, enter a number, and close the bracket twice. So first you will see that the input is being executed, which is going to present a message to the user, enter a number. The user will have to enter a number. The user is free to enter whatever he or she wants to enter, but let's assume that the user wants to enter a number, and that number is a string or an str that is passed as an argument to the int constructor, meaning it is going to construct an object of int type. Hence, the result, whatever that we give, is going to be an int. So now n1 plus 100 will have no problem, because by the time we have assigned to n1, it has been converted into an int. So int plus int is absolutely no problem. So we may have to keep this in mind, that every time we accept a numerical value, we better pass it on to the int constructor, and then we assign that to a variable. Alternately, we can also accept first like this, and then we can say n1 equals to int of n1, because we know at this point in time n1 is in str. We convert that into an int, reassign the same thing back to n1. This is all possible because Python has dynamic data types for variables. The class str, which allows us to create string objects, is one of the most commonly or widely used data type in Python. An str is simply a text that you enter with the help of a quotes, which can be a single or double quotes. For example, I can say here name equals to Vinod in single quotes, or I can say name2 equals to double quotes Vinod, which are identical. So you can check here now by typing ID of name and ID of name2. They both are same because both of them are referencing to the same object. The object Vinod got constructed in the first time here and was referenced by this name. But later when I assigned using a double quotes, Python realizes that the object Vinod already exists and just simply gets the reference of that. So there is only one str object called Vinod. Both name1 and name2 are pointing to or referencing to the same thing. Sometimes a string may consist of double or single quotes as part of their text. For example, if I want to say name or name3 equals to Alfred de Souza, and now you can see this is going to be a problem because the beginning quote gets terminated over here, and this is an error because you can't simply type whatever that you want here. So this is going to cause a problem. It says that invalid syntax. Now this can be best addressed by typing name3 equals to, in double quotes you say Alfred, and then single quotes is going to be part of that, like this. So the double quotes which got opened over here gets terminated only at this point in time, and now Python will assume that this is an actual character you wanted inside the string and not a ending of any open quotes, or not a beginning of a quotes that is going to be terminated at the end. So this is not a problem. Now you can see name3 is no problem. I can say print name3 and it simply prints Alfred D'Souza, something like this. However, you may not be able to combine both of them. For example, what if I want to have a variable called height which says, for example, 5 feet 10 inches. So if I type here 5 and then we use a single quote to say it is feet and the 10 inches, right? So in a double quotes. Now obviously my idea is that the quotes which is opened here is terminated at the end, making this 5 feet 10 inch as a value. But this is going to give a problem because it assumes that the quotes that got opened in the beginning got terminated right here, and the last double quotes that we see here is not allowed. So if I press enter, this is going to cause again a syntax error. It says end of line while scanning for a string literal. Now this is where we can use an escape characters. For example, the same thing I can use now with a backslash behind the double quotes. So the combination of the slash and the double quotes is now considered as a single character, and then it is going to be part of the actual text. So which means the opening quote here is terminated at the end by the last one over here. And this is perfectly all right. And you can say print height, and I should get this 5 feet 10 inches, something like that. Python also allows you to use a 3 single quotes or 3 double quotes to represent a string. For example, I can create a variable called my address equals to 3 single quotes followed by whatever the address I want to give. For example, I can say elegant elite, and I can even press enter here so that it comes to the next line. So the purpose of using these 3 double quotes or 3 single quotes is to use a multi-line text. So until I use this somewhere in my text, it's not going to terminate. So I can give it in multiple lines. So I'll say first cross first main, and I can actually press enter. Then I can type some other details. Let's say for example I give Bangalore. Now I want to close that. I can use a 3 single quotes. Now you can only use 3 single quotes when you started with 3 single quotes. If you started with 3 double quotes, you have to terminate that with 3 double quotes. I press enter. Now you can see that we are back in the command prompt. You may also notice that when I pressed enter here after this particular text, I did not get the 3 greater than symbols, but instead I got 3 dots. This is to say that the command is incomplete and it is waiting for me to give this 3 single quotes. As soon as I did that, I pressed an enter, and now it says that okay, the command is complete. Whatever was inside these 3 quotes is now becomes the value of my address. Now if you simply type my address and press enter without using the print function, you can see an internal set of characters also which represented that new line. The entire text is given to me as a string here, as you can see, single quoted text, but wherever I had pressed enter, /n was included. /n corresponds to new line character. On Windows, you may even see /r along with the /n, indicating new line carriage return. Of course, if you want to see them in multiple lines, use the print function and you can type my address, and I should get this as it is. When it is an str, you can make use of a lot of functions provided by str. For example, if you type dir str and look at only those which are not dunder or double underscore attributes. So these are the functions and variables that are available. Mostly these are all functions. So the capitalize is a function which converts first letter of each word into uppercase, converting the rest of them into lowercase. Likewise, there is a function here called center which centers the text. there is a function called ends with, which checks whether the text ends with a particular pattern or not. For example, I can check name is Vinod. I can check name dot ends with, say for example, D or OD for that matter. It says true, but I can check does it end with say AR like Vinod Kumar. It says false. So I can check whether a particular name or a text ends with a particular pattern or not. You can also check is it a numerical value. For example, if I have here x equals to in single quotes say 100, so that is a str. It's not a number, but it contains only numerical value. So I can check here is numeric, and it says here true because it contains only numerical values. But if I say x equals to 100 minus 20 for whatever the reason, and if I say here is it a numerical value, it says false because minus cannot be part of a number. Likewise, we have functions like, for example, there's a lower, there's an upper, which actually returns a new string, converting them into lowercase or uppercase version. For example, I can say name, which is currently Vinod. I can say name dot upper, and you will see that it says uppercase, but the original value in the name still is the lowercase Vinod itself. It's creating a new string and returning the same thing. There are a couple of functions which are more useful than the others. Like for example, there is a split and join. Let's have a look at the same. So consider a variable called cities equals to, I'm giving few cities like Bangalore, Mysore, Mumbai, and let's say Delhi. So now we have a string here, one str, but it has 4 cities. I can convert them into individual strings representing cities by calling cities.split, but then I have to say what is the delimiter, or what is that character that separates multiple cities. You can see the 2 cities are separated using comma, so I can give a comma here saying that hey, comma is the delimiter, so split them. Wherever you find a comma, make them into pieces. So the return value of this now is a list. As you can see here, it's a group of strs. So where I have a one value which is Bangalore, another value is Mysore, another value is Mumbai, another value is Delhi. So this is called as a list, and we have a whole section discussing about lists later. But for the time being, I'm just going to copy this and then assign here data equals to this. And if I say type of data, it says it's a list. It's not an str anymore. But of course, if I say type of data of 0, which happens to be the first element here, which is an str. So data of 0 is an str, and you can see it says an str. Now you can also type printing data of 0, data of 1, 2, and 3. Of course, if I go beyond 3, it's going to give an error. Now that I have this data, can I convert them back to something like this with a different delimiter? Now that's where a join comes into picture. So the join needs a delimiter first and then specify what to join. So I may take here delimiter, some variable equals to, for example, let's say double dash. So I want to use this double dash as a delimiter. So what can I do? I can say delimiter dot join, and then I can say data. Now data happens to be a list of all the individual cities. I'm joining them using this delimiter. So if I press enter, you can see each one of those cities were taken and then pasted or joined using this dash dash as the delimiter. So whatever the delimiter you wanted, you could have given. For example, I can say here, hey, slash, and now I can say delimiter.join. It's going to give you something like that. If you want, you can put a dot and then say join. Apart from numbers and strings, there is another important data type called booleans or bool. For example, I can say type of true. If I say, it says that the class is bool. And I can also type dir bool to see what kind of functions or attributes we have. And you can see that they are more like integers. However, I cannot interchange integers as well as booleans. Booleans are always going to contain true or false. So they are going to be resulting from comparison operators. For example, I can say n1 equals to 100, n2 equals to 200. I can always say here, say tf equals to n1 less than n2, so which happens to be a comparison operator. We also call this as a relational operator. So if I say now what is TF, you can see it says true because 100 is less than 200. But if I interchange the operator and then check the same thing, it says it is false. Booleans are used exhaustively in conditional branching or iterations such as loops, where we may have to check the condition and then do some alternate steps or repetitive tasks. One very important aspect you may have to keep in mind especially if you're coming from other programming languages, is that the values true and false start with capital letter. So this is a valid true. This is considered now a variable which we have not created, and it comes back and says name error. There is no name called true defined. In this lecture, let's have a look at Python operators. Python operators can be divided broadly into arithmetic, string, relational, logical, bitwise, and assignment operators. Arithmetic operators perform arithmetic operations on numerical values. Most commonly used ones are plus, minus, star, slash for addition, subtraction, multiplication, and division. However, there are two types of division. One that gives you a fractional values, which is like 22 by 7, gives you 3.1428, etc. There is another one where you are not interested in the fractional values, you are only interested in the integer part of the division. And this is achieved by using a double slash. For example, 22 double slash 7 will give you 3. We also have an exponent operator, which is equivalent of x raised to the power of y. In this example, 2 star star 3 means 2 raised to the power of 3, which is equivalent of 8. We also have a modulus operator that gives the remainder after division. For example, 25 modulus 7 will give you 4. The operator plus and star can also be used with strings, but they have a different meaning. For example, if you're using plus symbol with two strings, it's called concatenation, which results into joining of two strings. Vinod plus Kumar will become Vinod Kumar as one single string. Star, on the other hand, is used for repeating a string. If you are using Vinod times 3, you're going to get Vinod, Vinod, Vinod as a single string. This can be used for creating a line where I can choose a character of my choice multiplied by 50 or 80 depending on how big the line you want. For example, I can say here print in single quotes a minus times 80 will give you a line that is 80 characters length. Or I can use a different symbol like this, and then I get a different line. Or I can use a combination of two of them and then reduce this by 40, and now I get a line of this style. Relational operators can compare the values of two operands and then give you true or false as the resultant value. Less than symbol is used for comparing whether a value 1 is less than the value 2 or not. In this case, 10 less than 12, which is equivalent to true. Whereas less than or equals to can be used to check whether or not the first value is less than the second value or is it equals to the second value. In this case, 12 less than or equal to 12 gives you true. 12 less than 12 would have given false. Similarly, we have greater than, equals to. We also have a double equals, which is used for comparing two values, whether they are same or not. And also we have not equals to that checks the opposite of the above. These relational operators can also be used with strings, where the Unicode values of characters of the strings will be used for comparison. If I check Vinod less than Vineet, you'll see you get false. The reason for this is this operator now checks the Unicode value of V with V, since they are same, I with I, which is the same, N with N, it is same. Now it's going to check the Unicode value of O with Unicode value of E. Now to find the Unicode value, you can use the ORD function, and that's going to tell you what are the Unicode values of O and E, which is 111 and 101. Since 111 less than 101 is false, you get the result as false. However, if I type Vinod less than Vinuta, now you'll see that you're going to get true, mainly because for the first three letters the Unicode values are same, they are skipped, but when it comes to O and U, the Unicode value of O is less than Unicode value of U. So we can check the same by typing ORD of O and ORD of U. You'll see that you're going to get 111 and 117. Since 111 less than 117 is true, it's going to result that into true here. Logical operators can be used for combining more than one condition. Each logical operator can be used with two conditions simultaneously. For example, 10 less than 12 is one condition, 10 less than 8 is another condition. 10 less than 12 results into true, whereas 10 less than 8 results into false. True and false is going to be false. False and true is also false. False and false is obviously false. So the only way a condition becomes true is when both the condition are true here. Similarly, if you are using OR operator, the moment the first condition is true, the second condition is never checked at all, because any one condition must pass, and if the first condition is true, it will never bother to check the second condition. Whereas if the first condition is failed, then it's going to check the second condition. If the second condition also fails, then the result is false. Otherwise, it is going to be true. In this case, 12 less than or equal to 12 is true, because of which it doesn't even check the second condition at all. The NOT operator can be used for negating the result of a condition. For example, in this case, 12 greater than 12 is false. NOT of false becomes true. Python also supports bitwise operators, though the practicality of these operators are very less. The operator double less than symbol represents what's called left shift. Basically, the bits will be shifted by the number of bits that you mention over here. For example, we have 12 left shift operator and then 2. So we want to shift the bits of this 12 by 2 bits and then calculate the result. Take a look at this example. 12 in binary format is represented with these 8 zeros and ones. And then when you say 12 left shift 2, so we basically want to make room for 2 more bits on the right side, because we're going to shift the bits on the left. As you can see that the bits have been moved towards the left, making room for these 2 cells. Now these 2 cells will always be inserted with zeros, and hence now the overall byte consists of 00110000, bringing that result into 48. Similarly, if you're trying to do a right shift operator, here is what happens. The byte consists of 8 bits with 00001100 representing 12. The moment you say 12 right shift operator 2, you want to shift all the bits by 2. So that means the leading zeros will be omitted. They are pushed out of the byte, making room on the left side. And these will be inserted with zeros again, making the whole bytes as 00000011. Now if you convert that binary number into a decimal, it becomes 3. Ampersand and OR represents the binary and binary OR. For example, 12 and 13 results into 12, 12 or 13 results into 13. To understand the same, let's have a look at this one. Consider two numbers 151 and 137, two arbitrary numbers. and their binary equivalent of the same. Now, if you are trying to do a AND operator between these, the bits in the same index will be combined with the AND operator. So 1 and 1 will become 1, 1 and 0 or 0 and 1, they all become zeros. So effectively you can see now that 1 and 1 is 1, and then all of these are going to be converted into zeros, and here is 1 and 1, so the total result will be 1 followed by 0 0 0 0 0 0 and 1. If you convert that binary into decimal, you're going to get 129. Similarly, if you want to do an OR operation between these, the bitwise OR operator now takes the bits in the same index and then converts that into an OR result. So 1 OR 1 is 1, 1 OR 0 is also 1, 1 OR 0, 0 OR 1, they all are becoming 1s. 0 or 0 and 0 or 0 become 0. So the result will now look like this, where wherever there is a 1, it becomes 1, irrespective of the other 0. But in case if there is 0, it's going to check the next one and then say it is 1, so it's going to result into 1. So the final result would be 1 0 0 1 1 1 1 1. If you convert this binary into decimal, you're going to get 159. Python supports shorthand operators for assignments. As you can see here, each one of these operators are equivalent of its lengthier format. For example, a plus equals to 10 can be written as a equals to a plus 10, but this is a short form notation of this lengthier notation. At this point in time, if you're coming from C, C++, Java or C Sharp, it is important to know that there is no plus plus or minus minus operators. So if you want to increment a value of a variable by 1, we may have to say a plus equals to 1 instead of a plus plus. Similarly, a minus equals to 1 is equivalent of a minus minus in other languages. Now that we have got a fair idea of what is Python and how do we use the Python REPL, let's have a look into how do we write Python scripts, which are nothing but Python programs stored in a file, and execute the same thing. Obviously, we have to type the code in some editors. There are many editors that are available specifically meant for Python, such as PyCharm. We call it as IDE or Integrated Development Environment. But for the sake of simplicity, I'm going to use a very popular text editor called Visual Studio Code. And this is from Microsoft. It is free and open source. You can download it and install the same. In my case, I've already got this. Once again, you can use any other text editors. For example, if you're using Microsoft Windows, you can use Notepad or Notepad++, whichever is convenient for you. We will be using this editor only for typing the code, but for executing, we will still execute that from the command prompt. So let me open Visual Studio Code. And it comes with this welcome dialog box in case if you're opening it for the first time. You also have an option here called Open Folder that's coming from this Files icon or Explorer icon. When you click on that, it will associate a folder with your Visual Studio. So I'm going to go to my desktop and create a folder for this Python demonstrations. So I'm going to create a new folder, call it as Python examples, and then say open. Now I'll be able to create new files from here. Let's say we create a file called ex01.py. The file extension .py is optional, but with this kind of editors, because the extension is .py, we will be getting some kind of IntelliSense over here. So let's write a script that accepts a name from the user and then displays a greeting message. For this, I can say name equals to input, and then I can say enter your name. And then at the end, I can press enter. Now I want to print in a message, something like, hello Vinod, how are you today? So to do that, I can say print, and then I type here hello, and now I need to include the name. I can put a comma here and then say name. and then I can put another string and then say, how are you today? So this file is now ready for execution. I save this. Now I have to go back to a command prompt. So I'll open a new command prompt. Make sure that I have to get into my folder where I have kept this. If you remember, I created that in my desktop. So I'll go to CD desktop, Python examples. You can see that I have this file called ex01.py. Now to run the same, I have to just type Python3 followed by ex01.py. I can press enter and it will ask you enter your name. So the code is being interpreted now. So the line number 1 says input, enter your name. So I'll enter Vinod and press enter. When I press enter, it's going to continue with the second line. And the second line says print hello name, how are you today? And name will now have this Vinod. So it's going to say hello Vinod, how are you today? Let's go back to the code and do some more work over here. As you can see that I've given here hello, a comma, another expression, and another string here. So there are 3 parameters I supplied to this print function. This means that I can supply as many parameters as I want for the print function. Now suppose I don't want this code to be executed. I want to write one more print statement, but I don't want to delete this either because I want to use it as a reference. What we can do is we can start this line with a hash symbol or pound symbol, and the entire line is now called comment or a code comment, which means the interpreter will skip this one. Using this text editor, you can use a control slash on Windows, command slash on Mac to toggle between this comment. Now I press enter. I want to type the print message in a different way. The print can be used with something like this. Hello %s, and then I can say how are you today. So as you can see that I'm using a special character here %s, which is called format specifier, and this print function can replace these percentage symbols or %s format specifiers with whatever that I give here. And the way you can give is you have to give one percentage symbol and then what is the variable that you want to substitute over there. So I can say here name, because name is the one that contains the user input data. So whatever this %s is there, that will now be replaced with this name. So I'm going to save this, go back to the command prompt, type the same command once again, Python3 ex01.py, press enter. It's going to ask me what's the name. And this time you can see it's going to say hello Vinod with a comma and then says how are you today. Let's go back to the code, do some more. Suppose I have to accept enter your city along with the name. So I'm going to come back here and say city equals to input, enter your city. And now I'm accepting 2 values from the user. Obviously, I want to print or make use of both name and city in my message. So I'm going to comment this out. And this time I want to print something like this. Hello %s, which is for name. I can say how is weather in your city, which is another %s. Now you see I have 2 %s symbols here, which means I have to supply 2 values. And if you simply give name comma city like this, you may run into errors. Let's go and check this out. I go back to the command prompt, run the same command once again. It says what's your name? I'll say Vinod. What's your city? Bangalore. And now you can see we got an error. It says not enough arguments for the format string. So it assumes that you have supplied only one because it will take only up to here, and then it will assume that this is totally a different expression that you want to print. All you have to do is to group them together by using a bracket, and now the problem is solved. So now the entire string here will now be substituted with this name and city wherever %s is there. I save this, go back, and then run the code once again. I'll say my name is Vinod and my city is Bangalore. Press enter and you can see it says hello Vinod, how's weather in Bangalore. There is also another way of printing formatted text, and this time with the help of a function in the string class or the str class. And the way we can do that is by going and printing here a string hello and then a pair of curly brackets, and then I say how is weather in another curly bracket, probably a question mark just for the sake of printing question mark. But these two curly brackets have to be substituted with name and city. This being a string object or an str object, this object can be used with a function called format, which takes the values for these format specifiers, which are curly brackets. So I can say here name comma city. So once again, this time we are using a function of the string which is format, which takes the parameters given here and will substitute in this curly brackets and then returns a new string. So for example, I can take this and then I say MSG, where MSG equals to this entire expression. So basically we have a string object over here, and the string object dot format we are calling. The format will take these two variables name and city and substitutes in this and then returns the entire formatted text. And the formatted text is what we are actually trying to print in the line number 8. Let me save this, go back to the command line, clear this here, and then run the command once again. It says enter your name, I say Vinod, enter your city, I say Bangalore. I still get the same effect. Hello Vinod, how's weather in Bangalore? So this is how you create a script file and then execute that. So essentially a script file consists of multiple lines of Python code, and then you execute or interpret one by one. So the interpretation always start from line number 1, line number 2. These are called comments. They are ignored by the interpreter. And then you have the line number 3 and then line number 4. And when there is no more lines to execute, the script has been executed completely or successfully. In this lecture, let's have a look at conditional statements, which allows us to conditionally execute one or more Python statements. So this is achieved by using a keyword called if, and then there are associated keywords called elif and else. Let's have a look at the same by taking an example. So I'm going to create a second script file here called ex02.py. Let's say we want to accept a number from the user in an integer format. So I can say int, but to accept the data from the user, you'll use the input function, give it a message, enter a number. Now, once the user enters anything, that anything is considered to be a string or an str, this int will convert that input by the user into a number. In case if the user has entered something like ASDF or something non-numeric, this will fail and stops the execution of the program then and there itself. But let's assume the user is entering a number and that number is now here in this num. Let's say we want to check if the number is greater than 1000. If the number is greater than 1000, I won't tell the user that, hey, you've entered a very big number, but otherwise it's okay. So I'll say here, if num greater than 1000, then. So we use a colon here to indicate a then. Now, in case if you're coming from C, C++, Java or C#, you're used to give this in a particular round bracket, for example, and then use a curly bracket like this to say, hey, whenever this condition is satisfied, execute everything in this particular block. But in Python, we don't have this concept of curly brackets, and the round bracket here for grouping the condition is totally optional. So let me get rid of that and give a condition itself. Now here we say colon to indicate that, so if this condition is satisfied, then you do these statements. Now notice that as soon as I press enter, Visual Studio Code indented my statements over here. So this is important because Python says all the statements that are supposed to be executed for this particular condition must be indented with at least 1 or 2 spaces. So as a practice, we have 4 spaces here. So I'm going to type here print, hey, you have entered a big number. And then I can say here print, maybe a line. And then I can say here print by. Now you should notice here that these two statements, because they are equidistant from the left margin, they both are considered as a group to be executed if this condition is true. But if the condition is not true, then those two statements are skipped. And I'm coming to line number 6. There's nothing. In line number 7, I have a by statement. So let's give it a try by saving this, going back to the command prompt, typing Python3 and then ex02.py. Now for Windows users, you may have to type Python ex02.py. I press enter, it's going to ask a number, let's say 6789. Press enter, it says, hey, you have entered a big number by, but in case if I enter 678, I press enter, the condition fails and we don't have an alternate to be taken place. But then we do have a by statement that gets printed. You can see that these two are now included only if the condition is true. But in some cases, we may also have to take an alternate step. For example, let's say I want to accept a number from the user and then check if the input number is an even or odd. And accordingly, I have to tell the user that you have entered an even number or an odd number. So let's take another example and then I'll call it as ex03.py. And this time I want to say that accept a number from the user and print if the number is even or odd. That's the ask. So let's say we want to accept a number. So we're going to say int and then I'll say input, enter a number. Again, if the user has entered a non-numeric value, the int constructor will raise an error and stop the execution of the program. Let's assume that the user is entering a valid number. Now to check if the number is even or odd, I can check if num modulus 2 is it equals to 0. If the answer is yes, I say print you have entered an even number. If the condition is not true, that means if the condition fails, I want to take an alternate path. So which means I have to come backwards and then say else, and then I put a colon to indicate there is one or more statements that I want to execute. So again, you see, as soon as I press colon and enter, VS Code automatically indents my code here. And then I say here, print you have entered an odd number. And then of course I can come out and then I can say print by. Now notice that if I use an indentation for this like this, now these two statements are considered as part of the else block, which means that the by statement will not be printed if you have actually entered an even number. So it is important to maintain that indentation properly. Let's save this, give it a try. Python3 ex03.py. I press enter, it's going to say enter a number, let's say 45. It says you have entered an odd number. I'll type here 66. It says you have entered an even number. And you can see in both the cases, the by statement has been printed. In few other cases, you may want to check in case if the first condition fails, you want to check another condition. And if that condition fails, you want to check one more condition and so on and so forth. Now this is where we have a concept of chain of if conditions, where I can have an if, elif, 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 and then else. So I can have as many elifs as I want and an optional else statement. To understand the same, let's take another example. So I'm going to create a new file called ex04.py, and then let's say we want to accept a number representing a month. And if the number is not within the range of valid months, then I want to give an error. But if it's a valid month, then I want to tell how many days are there in the month. So let's define a variable called month equals to int, and then I say input, enter a month. So I can also tell the user that a number between 1 to 12. But the user may enter something outside of that range. So the very first thing that I will check here is that if month is less than 1 or month is greater than 12. If either one of the condition is true, for example, let's say I've entered -5. So -5 less than 1 is true. It doesn't even bother to check the second condition because that's a short circuit there. So the second condition is never executed. The first condition is true, which means it's an invalid month. But suppose if I entered a number as 25, the first condition is not true because 25 less than 1 is false. Then it's going to check is the second condition true, and 25 greater than 12 is true, which is invalid. So hence, if any one of these two conditions are failed, then I want to tell here that hey, you have entered an invalid number for a month. But in case if the user has entered properly, that means the user has entered a number between 1 and 12, which is a valid month. Now all the statements that I'm going to write here will be executed only if this condition fails. So at this time in line number 6, I know that the user has entered a number from 1 to 12. Let's first consider for February. So I can check here if month is equals to 2, that means it's February. I can say print there are either 28 or 29 days in this month because that's February. But if it is not February, let's check by using elif, and then I can check month, is it equals to 4, which is April, or I can check is it equals to June, which is 6, or month equals to 9 for September, or month equals to 11 for November. Then I can say print there are 30 days in this month. Now you can see that I'm checking the same condition for different values here. So month equals to 4, 6, 9, 11. Now we can simplify this and I'll show you that in a minute. But for the time being, let's give it as if month is April or June or September or November, then I say there are 30 days. Now notice that I'm doing all these things only if the number is a valid number for a month, and it is 2, 4, 6, 9, 11. If it is not any of these 5 months, the remaining 7 months have 31 days. Now I don't have to check the remaining 7 months. I can simply say if it is not one of these 5, then I can say print there are 31 days in this month. And of course, now I want to reduce this. In order to reduce this, I'm just going to copy paste and then comment one of the lines so that both the lines I want to execute. This one I can now replace this like month in, and then I can supply a bunch of values like 4, 6, 9 and 11. So the in operator is now checking whether this variable matches any one of them or not. If matches any one of them, then this is true, it's going to execute this. If it doesn't match, then it's going to go to the else section. And now notice that it's only going to check this condition if the first condition has failed. Let's save this and then go and execute the same. I'm going to say here clear, and then I say Python3 ex04.py. It says enter a month. Let's say I give 67, which is an invalid month. And as you can see, 67 less than 1 is false, but then it's going to check this one, 67 greater than 12 is true. It's going to execute this one. Because the condition was satisfied, the else will not even take place. So I'm going to get one single line. It says you have entered an invalid number for a month. The same thing would happen if I type here, say 0, because this time 0 less than 1 is true. It doesn't even bother to check the second condition. And because the first condition is true, this if condition is executed and the else block is skipped. So I'm going to go and enter. You can see the same result. However, if I enter 2, for example, it's going to result into this output. None of these two will take place. So I'm going to run the same thing. Month is 2. It says 28 or 29. Let's try with April or June or September or November. You can see we get 30 days in these months. But anything like January or March, you're going to see that it says 31 days in this month. If you're coming from C, C++, Java or C#, you are familiar with something called ternary operator. In Python, we don't have this ternary operator or something equivalent of switch case also. However, we do have an alternate for a ternary operator. So let's take an example to understand the same. I'm going to create a new file called ex05.py where I want to accept the name and age of a person. And then if the person is less than 18 years old, then I want to say that the person is a minor or person is an adult. So I can say here name equals to input, enter a name, and then I'll type here age equals to int of input, enter the age. Now that we have accepted name and age, let's create a variable to say person type, whether he or she is a minor or an adult. Let's assume that we're going to type minor, and then I say if age is less than 18, else I can say adult. So this is how you use a ternary operator's equivalent, where I'm actually assigning minor only if this condition is true. And if the condition is false, then this is not going to be assigned, but this particular text, which is adult, will be assigned over here. And now I can of course print by typing %s is a %s percentage, and then I can say here name person underscore type. So the first %s will be replaced with name, and second %s will be replaced with person type. Let's save this and go to the command prompt, execute the same by typing Python3 ex05.py, and it's going to ask the name. Let's say for example Ramesh. I'll say 45, and you can see it says Ramesh is a adult. And then of course I'm going to write the same name with, for example, 12. It says Ramesh is a minor. A lot of times you want to execute a statement in a repetitive mode. For example, you want to accept a number and print a multiplication table, where you may want to calculate the product of the input number from the user times 1, times 2, times 3, etc., probably for 10 times or 15 times, 20 times, etc. So let's give it a try as how this can be done. So we're going to create a new file here, ex06.py. And then let's say we want to accept a number and print the multiplication table for the same. To do this, let's first accept a num equals to int input, enter a number. And let's assume that the user enters 7. Now what we want to do is we want to print 7 times 1 equals to 7, 7 times 2 equals to 14, 7 times 3 equals to 21, so on and so forth, until probably 7 times 10 or 7 times 20. It's up to you. So if you want to do some job repeatedly, we do have a couple of options. The first option here is called as a while loop. So the name suggests while a condition is true, keep repeating. So let's say for example, I want to declare a variable which is assigned with 1 as the number. So I equals to 1. Now I can check, is it less than or equals to 10? So I can say here while I is less than or equals to 10. I use a colon to indicate that I'm beginning a block of one or more statements. Now as you can see that the value of I is 1, 1 less than or equals to 10 is definitely true. It now executes this block. So I can type here print, and then I can use any one of those methods to include the values. For example, I can say curly bracket x curly bracket equals to curly bracket. Then I say dot format, and then I'll say num is the first parenthesis to be printed with or substituted with, the second bracket to be substituted with the value of I, the third one is the result, which is nothing but num times I. So we're going to get something like 7x1 equals to 7. Now we have to now change the value of I, so that next time it's going to say 7 times 2 equals to 14. So this can be done by using the shorthand operator I plus equals to 1, which increments the value of I. So this is same as I equals to I plus 1, but much more simplistic way. So I'll say plus equals to 1. Now, after this is done, I don't have anything else to do. So what actually Python interpreter does is it's going to go back and re-evaluate this condition and checks here that I, which is currently 2 is less than or equal to 10. So it means 7 times 2 equals to 14 is printed. And then I becomes 3 less than or equal to 10 is again true. So it's going to print something. Then I becomes 4 less than or equal to 10. This continues up to 9. And then when I becomes 10 less than or equal to 10 is still true. It prints the last one and then it becomes 11. Now when it becomes 11, again it will go and check 11 less than or equal to 10, which is false. Now that condition has been turned into false. So this block is now skipped. And what else it is there? So it's going to come out and then print whatever that we give over here. For example, I can say print a by statement. Save this and then I'm going to go and run the same. So this time I'll say Python3 ex06.py. It says enter a number. I'm going to press 7 and you will see that I get the multiplication table for 7. So if I want to increase the multiplication to up to 20, all I have to do is to change this number to 20. Or you can also ask the user what is the limit up to which the user wants. So I can say limit equals to int input, enter the limit. And now I can change this to limit instead of 10, where the user decides how big the multiplication table he or she wants. So I'm going to save this, go back, execute the same thing. Let's say enter a number, say 45, limit is 15, and you can see 45 multiplication table up to 15 is printed. Of course, I should give some delimiter there, so I can put a colon and space. Run the same thing once more. I'll say 45 and then I'll say here 20. We get the multiplication table for 45 up to 20. Let's take another example. So this time I want to find out the factorial of a given number, which is the product of all numbers between 1 and itself. So I'm going to go create a new file, ex07.py. Let's say num equals to int input, enter a number for which we are going to calculate the factorial. Now, in case if the number happens to be negative, we might want to specify that there is no factorial for the same. Let's declare a variable for our loop which is equals to 1, and we also are going to declare a variable called f, which is going to contain the factorial of the number entered by the user. So let's begin a loop by using while I less than or equals to num, and then I'll say here f equals to f times I. As you know that initial value of f is 1, initial value of I is 1, both of them are multiplied with each other. The resultant 1 is stored in f, and now I'm going to go increment this I by 1. So I'll say I plus equals to 1. When I is incremented, it's going to go back here and checks I less than or equals to num. Let's assume that the user has entered 4. So the I is 2, 2 less than or equal to 4 is true. Now f, which is 1 multiplied by 2. So 1 times 2 is 2, 2 is stored over here. When I becomes 3, again the condition is true. So this time it's already 2, 2 into 3, 6. Now 6 is stored over here. And I becomes 4, 4 less than or equal to 4 is true. So this is 6 and then this is 4, 24. So we store 24 over here. When this becomes 5, 5 less than or equals to 4 is false. We come out of the loop and then I can say here print factorial of percentage d is percentage d, and then we'll say here percentage, the first is basically num and this is the calculated result which is f. So I can say here num and then f. So let's save this and go back to the command prompt, execute this, the 7th one, and then press enter, enter a number, let's say 4, and you can see it says factorial of 4 is 24. Let's enter 5, it's going to be 120, and I can go on and we get a very large number in case if I give a bigger number as well. Python also supports another kind of loop called for loop. but this is a little bit different than what you find in other programming languages. To understand this, let's take an example first. So we'll say ex08.py. Let's say we want to use the for loop to print a bunch of names. So I can say here for, and then I can say name in a bunch of names like Vinod, Shyam, let's say John and Jane. So we now have a loop that actually gives me one single name from this bunch of names over here. So it's going to take Vinod first time and then enters this block where I can say print name, which is actually going to say print Vinod, right? And after this is printed, if you don't have any other statement, it's going to go back and then assigns this variable name with this value of Sham, and then it enters the block, prints this name, and then again it goes forward, takes the third name and then the fourth name, and then when there are no more names to go through further, it's just going to quit. The variable name here is totally your choice. If you don't want name, you can give something else. So I can come out of this and then say print here, say end of the example. Save this, go and execute this eighth one. I'll say Python3 ex08.py, and you will see that we got 1, 2, 3, 4 names and then says end of the example. Let's say we want to now loop through a bunch of numbers. So I can say here for num in, and then I'll say here 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. And now I can say print num. So now num will be taking the first number, which is 1, prints that value, then it takes the second one, prints that value. So it repeats over all these entries, and then of course it just stops. So if I execute this, now you'll see that it's going to say first loop prints the names there, and then the second loop is printing all the numbers. However, if you're wondering, what if I want to print all the values from 1 to 500? Should I be giving 1, 2, up to 500? Now the answer is no. Now this is where Python provides an object called as a range object. So to understand this, let me show you by going to the Python 2 environment. Now for Windows users, you may not have Python 2, but that's okay. So I'll show you here on my system. So when I type Python, you can see that I'm in Python 2 environment, and here is a range object. If I say range of 10 and press enter, you'll see that it shows me a bunch of numbers from 0 to 9. Whereas if I want, I can always say range of 1, 10, and this time it's going to show me from 1. So I'm saying two numbers here, which is like the start and the end, and note that the end is not included over in the list here, right? So the range also can take, for example, 1, 100, and then I can say 2 here to say skip every two numbers. So for example, after 1, it skips the next number and then jumps off and then gives me 3, and then it skips that. Basically it's called step, where it is incremented by that number that is given. For example, 1 plus 2 is 3, 3 plus 2 is 5, 5 plus 2 is 7, and so on and so forth. So for example, I can say range of 1 to 100 with 5 or probably 4. You can see that it's going to say 1, 5, 9, 13. It's skipping every 4 numbers. Now I can also say range of 0, 100 and 5. I get multiples of 5 here. I used Python 2 because if I exit this Python 2 and then get into Python 3, do the same thing as range of 1, 10, you'll see that it simply says range object of 1, 10. So we will not be knowing what actually it is there. But behind the scene, it represents a bunch of numbers from 1 to 9. So now I can use this and loop over this. So for example, the same thing now I can comment all these, and then I can come down and then say for num in range of 1 to 11. If I want to include 10, then I'll say here print num. Save this, go back to the command prompt, Python3 ex08.py, press enter. You can see I get from 1 to 10. So use the for loop when you know exactly how many times the repetition should occur. But if you don't know how many times, you should go with a while loop. Now, in the previous examples, like where I used a while loop over here, because I know exactly how many times I should be doing this, we should go for a for loop. Now, while loop should be used when we don't know how many times the loop should go. We will take better examples of the while loop as we go forward. In this lesson, let's understand when to use while loop and when to use for loop. Let's begin with an example of factorial. If you want to find the factorial of, say for example, 5, we have to multiply all the numbers between 1 and 5. So we have a lower limit, we have an upper limit. Now in this scenario, we have to go with for loop because we know exactly how many times the loop should repeat. So let's accept a number from the user by typing num equals to int of input, enter a number. The user would enter some number, let's assume 5. Then I should start a for loop where I can say for I in a range of 1 comma num plus 1. Now remember, the range object does not include the last value that you have given here. So if I want to go from 1 to num, then I have to say num plus 1 here. Then I begin a colon to indicate that there is a block. So I can now assign the value of I, which start from 1, 2, 3, etc. up to, let's say, 5. And then I have to multiply to a variable that I have not defined yet. So I'm going to say f equals to 1, which is going to be the factorial. I'll say f star equals to I, where I is the loop variable. Once the loop is complete, I can come out of the loop and then I can say print factorial of %d is %d, where the first %d is nothing but the input value num, and the second one is nothing but the factorial that has been calculated, which is f. Let's save this, go to the terminal, execute the command Python3 on Mac or Python on Windows, and then I can say ex09.py. It will ask me enter a number. I'm going to say 5, and then it's going to say factorial of 5 is 120. I can run it again and I can give another number, and then I get the factorial of that particular number. So the preferred loop in this case is a for loop because we know exactly how many times the loop should repeat. Let's take another example of Fibonacci series. First, let's create a file ex10.py. The Fibonacci series is nothing but a series that starts from 0 and 1, and then the third number would be the sum of the previous two numbers, which happens to be 1. The next number is going to be sum of the previous number, which is 2, then 3, 5, 8, 13, 21, and so on and so forth. Suppose if I want to print the Fibonacci series up to an input number, let's say for example the user wants all the Fibonacci numbers up to 1000, we don't know how many times the loop should repeat because we don't have exact number of Fibonacci elements. We have to keep generating the Fibonacci element and then check if we have crossed the limit or not. So let's accept first the limit where the user is going to enter something like 100. So we'll say int input enter a limit. I'm going to assign the first two elements of the Fibonacci series to two variables, which is a comma b equals to 0 comma 1, where a becomes 0, b becomes 1 in the order. And then I want to say here c equals to a plus b, but then I have to check whether c is less than limit, then you print it, then you continue to do the same thing, and in case if it is exceeded the limit, we want to stop it. So what I can do here is I can check while c is less than or equals to limit, and then I'm going to say print c, and then if I want to print the next number in the same line, I can say here end equals to probably a comma. So basically instead of bringing a new line character, it's going to put a comma and a space, and then I can say here a equals to b and then b equals to c. Once again I have to say c equals to a plus b, and this is the new Fibonacci element that we are generating. We go and check that with the limit once again, and if that is less than or equal to the limit, it's going to continue. Now this assignment can be further reduced to a comma b equals to b comma c. Now let's go and check this out. I'll save this, go to the command prompt, and then run the program Python3 ex10.py, press enter. I want up to 100, and you can see that we got all the numbers from 1, 2, 3, 5, 8 up to less than or equal to 100. But notice that the first two numbers were not included because we did not print that. So what we have to do is we also have to print A and B. So I'm going to type here A and then a comma symbol, and then B and another comma symbol, and then I don't want this to print a new line, so I'm going to say end equals to a blank string. Save this, go back to the command prompt, run this once again. Again I type 100, and this time you can see we got 0, 1, 1, 2, 3 up to 89, and that's because the next number would have been more than 100. It's going to be the sum of these two numbers, which is definitely more than 100. Also, you can see that the prompt is also printed in the same line. So what we can do is we can just come out and then just add a dummy print statement. Let's clear the screen, run this command once more, and then I type up to 100, and you can see we got all the numbers, and then the prompt is printed in the next line. So bottom line, when you know how many times the loop should repeat, go with a for loop, and when you don't know and your loop exit criteria is based on some kind of condition, and that is when you go with a while loop. In this video, let's learn about functions, and especially the user-defined functions. A function is a piece of code that can be called when we want to call. Let's take an example by creating a file ex11.py, and a function is created using the keyword def and then followed by a name, which is name of the function. For example, let's say I want to print information about myself. So I can say here print underscore author info, and then I have to open and close brackets, start a block by typing colon, and then the body of the function. I'm going to print some details about myself. For example, I'll say print name equals to Vinod Kumar. In another print statement, I'm going to say email equals to vinod@vinod.co, and then I'm going to go and type print website equals to https://vinod.co. Now notice I have written 3 print statements, but all the print statements are part of this function. Basically, we just have one single function definition and no executable code. For example, we do not have any print statement in the column 1 here. So the first indentation, we don't have any. So basically, we don't have any executable statement at all. We just have one definition. So if I'm going to save this and go back to the command prompt and run this ex11.py, you will see that there is no output because these 3 are going to be executed only when you call this particular function. So I can come to this line number 5 or 6, and then I can say print author info. This is where the actual execution of the function begins. So I save this, go back to the command prompt, run the same program once again, and this time you can see I got the output of the function. Now the good thing about the function is I can call this any number of times. For example, I called this 4 times. I'll save it and go back to the command prompt, run this. You'll see that the same output is printed multiple times. Let me get rid of this. Now that we have a function, let's look at more function features. So a function, when you call, this bracket here can be used for passing some values that can be received with some variables over here. And these are called parameters. For example, let's comment this one. Let's say we want to accept a number from the user which represents an year, and then we want to check if that's a leap year or not. And in case of a leap year, we should return true, else we want to return false. And the way you write the function is def followed by is underscore leap. This is the name of the function, which whatever you want you can give, but in case if it contains multiple words, we use an underscore over here. You can also use what's called camel caps, where the first letter will be small and then the second word would be a capitalized letter here. But this is a practice that has been followed in Python. So we're going to say is leap, and then we have to pass in an year. So I'm going to declare a variable called year and then start a block. and I can check here if year modulus 400 is equals to 0, which means the year is a multiple of 400, like 2000 or 2400, etc. Or, and then I can check year modulus 4 is equals to 0 while year modulus 100 not equals to 0. So there should be an AND operator over here. So either this condition is true or the combination of this condition is true. Then we would like to return true here. Else we simply would like to return false. But if you want to simplify this, you can see that the condition itself evaluates to true or false. And in case if it's true, we are returning true. In case if that is false, we are returning false. So why don't we just return the value of this expression itself? So I'm going to cut this. I'll get rid of this. I'll simply say return and this particular expression, which is going to be eventually true or false. To check if this is okay, we're going to just ask the user enter a num. So I'm going to say num equals to int of input enter an year. And then once the number is entered, I can check if is leap of that num. Then I can say print there are 366 days in the input year. Else I can simply say that there are 365 days in the input year. So some message, I'm going to save this, go to the command prompt, run the same program once again, and this time it will ask me enter the year. Let's say I give 1996, which happens to be a leap year, and it says there are 366 days. And if I type 1997, which is not a leap year for obvious reasons, it should simply say 365. Let's give it a try for 2000, which is a leap year. 2100 is not a leap year. 2400 is again a leap year. So this is how you can write a function and pass on a parameter which is received over here. While receiving, you have to declare variables. While passing, you can even directly pass a number or an actual value itself. A function can be called from another function. For example, let's write a function that accepts two numbers, year and month, and returns the number of days in the given month of the year. So let's comment this out, and then we're going to write another function, def. Let's call it as max days in month. Of course, we also want to accept the month along with the year, and then we want to now check what month is this. If this happens to be February, then you have to check whether it's a leap year or not. If it's a leap year, then 29 days, otherwise 28 days. For other months, either 30 or 31 would be returned. So let's begin by typing here, if month is equals to 2, then we want to return 29 if is leap of year. And then I can say else 28. So this is a one-liner if condition where we're going to return 29 if this condition is true, but if this condition fails, then this is going to be the return value. Likewise, we can say elif month in, let's say April, June, September or November, then I can say return 30, else we're going to simply return 31. Of course, if the month or the year is wrong, we might want to cause a problem. So that's what we can do here. For example, I can say if month is less than 1 or month is greater than 12, then I can say here there is an invalid value. So I cannot return any value over here, but instead I can cause a problem by using a keyword called raise and then an error object. An error object can be simply given like exception with a message. A message, for example, I can say invalid month, and then I can say must be between 1 and 12. Likewise, I can also say if year is less than 0, then I can say raise exception, and then I can give a message saying that invalid year must be more than or equals to 1. To test this, we have to accept the month and the year. Let's assume m equals to int of input, enter month, and then I can say y equals to int of input, enter year, and then I'm going to say days equals to max days in month, m comma y, and then I want to print that by typing print there are %d days in the month slash year as %d slash %d, and then I'm going to give three values here, days, m, y. So days is the calculated value which is going to be printed here. There are 31 days, and these are the m and y which will be printed over here like 1/2019. So I'm going to save this, go to the command prompt and run the same program once again. Enter a month, let's give it a January 2019, and you can see it says there are 31 days in the month year 1/2019. If I type February 2019, which is not a leap year, so it should simply say there are 28 days, but if I'm going to go and type 2 and 2020, which is supposed to be a leap year, you can see that it says there are 29 days. Of course, if I'm going to go with April, any year for that matter, it's going to just say here 30 days. However, if I give an invalid input, for example, I say here 100 for a month, 0 for an year, the first one itself fails. So it's going to give an error, and it says that exception invalid month must be between 1 and 12. So it never assigned a value back to this particular variable because this caused a problem because of this particular statement. And this problem never allowed us to go forward. So this is called exceptions. We will look into exceptions in great detail when we go to another topic called exception handling. If you're coming from C, C++, Java, or C#, you're used to writing the main function, which is the starting point of execution. Unlike those languages, Python is a scripting language, which means the execution begins from line number 1. But in this program here, the line number 1 is just a definition of a function. It is not an executable code. This is just being loaded into the Python virtual machine, and nothing happens over here. So this line you can ignore. This is a comment here, nothing happens over there. So the line number 8 also is a function definition, so nothing happens over there. Line number 11 to 15 are comments. Line number 17 to 30 is another function definition. So literally speaking, all these lines of code are never executed up to this particular point in time. However, the actual first line of execution is line number 31, where I'm accepting a number, then another number, then I'm calling my own function, which is this one, and this is going to make use of this function, and then the return value comes here, what is the number of days, right? And then of course it's going to print the number of days in the given month and year, and that is the end of the script. Now, instead of doing like this, these lines can become part of another function generally named as main, but you can write any name you want. However, coming from other programming languages, it's a good idea to have a function defined as main. So I'm going to write a function here called def main like this, and in order to make these statements as part of the main function, I just have to push this by one tab so that they become part of the definition of main. Now that the function main is created, unless the main function is called, there is no output. For example, if I simply save this, go to the command prompt and then run the same, you will see that there is no output because once again, this is also just a function definition, and unless you call any one of them, there is not going to be any output at all. So this time we would like to call the function main like this. So there is only a single line of execution that actually transfer the control to main, and then this will actually transfer the control to max days in month, and in max days of month we are actually passing the control to eSleep, and then eSleep is going to return a true or false and so on and so forth. So this is a much cleaner way of writing a program. So I'm going to save this, go and run the same thing. Now you can see it's going to ask the month, and then I'm going to enter the year. I'll get the number of days in that particular month and year. So this is how main function is written. In Python, a file with a .py extension consisting of functions like these can also be considered as a module. And the whole idea of writing functions is those are reusable lines of code. For example, imagine in another program, I want to call this particular function. So do I have to copy and paste this whole stuff inside that program? The answer is no, because in that case, then you'll have to also copy paste this one. And in case if that function makes use of another function, you may have to do lots of work. So instead, Python provides a simpler way of importing these functions into another file. So for the sake of demonstration, let's go and create another file called ex12.py. And then in ex12, I would like to call the max days in month function. So to do that, I have to first say from ex11 import, and then I say what is that I want to import. So this time I can say max days in month. Notice that we did not use the file name extension here. It is just the module name, which is ex11, which is nothing but the name of the file without the extension. And also notice we are not using any text here. It is just a module name as if it is a variable. So hence the file name should not contain spaces, because we can't use spaces over here. It's just the file name. And from this module, we want to import one of the member defined in that. And that member happens to be a function, but otherwise it can even be a variable. For example, if I have a variable called, say, x equals to 10, I can even import this x over here. I can say, let's first save this, come back over here, and then I can say x also as part of that. But if I don't have a variable, then I will not be able to do the same thing. So I'm going to get rid of that, and I don't need that x equals to 10 as well. Let's come back here and then save this. Notice when I execute this ex12.py, this is the only line of execution where we have, there is no other statements. But let's do one thing. Let's add two print statements, one before the import and after the import. So I'm going to say print before importing, and then I'm going to copy paste this and then say after importing. Save this, and then I go back to the command prompt. Let's run this by typing Python3 ex12.py. When I press enter, you can see it says before importing, and then it says enter month. Now the reason why this enter month is coming, because the module is being loaded into the VM, and when it is being loaded into the memory, it is actually executing every line in this particular module. Incidentally, this is not an executable, it's just a definition. It is stored in the memory. This is also a definition. These are comments, so they are not going to be affecting the output. There is another function definition, there is another function definition, but there is a function call. And this function call now goes over here and it says enter month. And hence we are getting enter month. So let's say I go and give some number, say 2000, and I press enter. When I press enter, it is going to do this job, get the max days into this variable, prints that particular value, and then there is nothing else over here. There is nothing else after the main function call. So it is back over here. So this statement is now over, and then it's going to come back and say after importing. So if I press enter, it's going to say there are 30 days in the month and year, but then it says after importing. Now at times we don't want the output from the ex11 itself, but we just want to import this function and then use that in this particular module. So we literally speaking, we don't want this particular code. We want to call the main only if this is run directly, like Python3 ex11.py. But if I say ex12.py, which is supposed to import, I want to just import only the functions and variables, but not execute that last line of code. Now the way this can be handled is by using the name of the module. For example, I'm going to just add here another print statement saying value of double underscore name double underscore is, and then I type here double underscore name double underscore. Now if you're wondering what is this, this is one of the Python predefined global variable which is the name of the module. Name of the module, as you can see, is ex12, so we expect ex12 over here. So let's save this, go to the command prompt, run the same thing. You'll see that it's going to ask the dates, so I'm going to just give some random numbers, and then you can see that it says value of the name is not ex12 but it's called main. Now the reason why it's given main is because this is the main module that I'm running, not importing. However, if I go and cut this from here and then go to the ex11 and then paste it somewhere here after the main is over, I'm going to just paste it over here. Once again, I'm going to run this program ex12. So obviously the name in the module ex12 is called main, but when I import it from here, the ex11 is not the main module here. So it is just another module and its name is ex11. So you can see now when I run this code, it says that let's say 1 and 2000, so don't worry about the numbers here, but look at the value of the name, and it says here the value of double underscore name, or you can say dunder name, is ex11. So if you run the ex11 directly instead of ex12, you can see that it's going to ask the same thing, enter month, say give some numbers, but this time you can see it says main, and that's because ex11 is the main module that I'm running. So if you import ex11, then its name is called ex11, but if you run the program ex11, then its name is called main. So we can use this concept and then say, hey, if the name is main, then you call the main function. Otherwise, don't call. So what we do is, let's get rid of this one and then add an if statement. If double underscore name is equals to double underscore main, that's the name given if you run this directly, then we say, hey, call this main function. So which means if you run this ex11 directly, you can see that the main function is being called. So I give some value, you can see we got the output. But if I run the ex12, this time ex12 gets the name main, not ex11. So you can see that there is before importing, after importing. Now that means it has run this particular line of code, it has run this line also, but it did not execute the main because this time the name is ex11, not main. So this whole thing is skipped, but all the modules have been imported over here. But of course I'm only interested in this function, and now I'm going to get rid of these print statements. Let's accept a month and year from the user, or I can probably directly type here if dunder name equals to dunder main, then do this particular job. Let's call the main function. Now the main function we don't have here. Let's define a new main function over here, and then in this main we want to do whatever we want to do. For example, I can simply say days equals to max days in month of, let's say, 4 and 2000, and then I want to just print here that in April 2000 there are, for example, %d days, and then I simply say % and then I'll say days. Save this. Now run this 12th one. You can see that it's going to say in April 2000 there are 30 days, and that's because this time it imported this module without having to execute the main function. However, the same code here is now executed because when you run the ex12, its name is called main. When you import ex11, the name is called ex11. So by comparing this if dunder name equals to dunder main, we will be able to run a main function. Once again, just to remind, the main function itself is optional, but it's just a habit that we are coming from C, C++, Java, or C#. So we generally tend to use the function main as an entry point. And then we say if the name, meaning if the current module is the one that you're running, then call the main function. And this is how you write the main function and call that in Python. In Python, both parameters and the return values are optional. Let's take an example first by creating a new file ex13.py and write a function called greet. So by doing def greet, and then I can say here name and city as two parameters. Let's say the intention here is to accept a name from the user along with a city and then greet him saying that hello so and so, how is weather in your city. So I'm going to print hello %s, how is weather in %s, which is like hello Vinod, how is weather in Bangalore, and I have to supply two values for the two percentages, which is nothing but name and city. Now as you can see that the function needs two parameters here, but it's not returning a value. So let's define a main where I can call these. So let's say I want to accept a name and city from the user. I'm going to say name equals to input, enter your name, and then I can say city input, where are you from, and that's supposed to be the city. So I'll say here greet name comma city. Now I'm calling the function. The function will now receive the value input by the user, the name and city, as the same variables here, but notice that these variables defined here are different than the two variables that are defined here, but coincidentally they have the same names in this case. It prints the value and comes out of that function with some default return value called none. If at all you assign this greet to a variable called, let's say, message equals to, and then say what is that message, so I can say print message is, and then I say message, you will see that the message is none because we didn't return any value from here. One last thing that we have to do is to call the main. If dunder name equals to dunder main, then we would like to call the main function. Notice that this time I didn't have to press enter because there's only one line of execution, so I can do that in the same line as well. I save this, go to the command prompt, run Python3 ex13.py, and then it's going to say enter name. I'll enter my name. Where are you from? I'm from Bangalore. Press enter. It says here hello Vinod, how is weather in Bangalore? Message is none, and that's because there was no return value from there. Now just because we don't have a return value, it doesn't mean that we cannot assign, because conditionally I may return something, and if the condition fails I may not return any value at all. So that's how the assignment can be a none as well. However, in this case it's useless. But let's say we also don't want to pass on the values name and city, so I can directly say here greet of, let's say for example, Vinod, and not pass a value for city. Now what happens is when we call this, Vinod will be assigned to name and city will not get any value. Now this, according to Python, is a syntax error. So if I save this, run the code, let's type my name, Bangalore, press enter. You can see it went up to this part where it said hello Vinod, how is weather in Bangalore, and then message is none. And then because it is being interpreted, when it comes over here it says hey, you're passing less values. For example, if you look at the message, it says greet missing one required positional argument city. But this can be altered by assigning a default value to city. For example, I can assign a message here saying that your city, saying that in case if you don't supply a value for that, then city will be your city. So of course when I run this, it's going to say hello Vinod, how is weather in your city. So save this, go and run the same thing once again. This time I'll enter, let's say Kumar, Bangalore, and press enter. This is the message first time, hello Kumar, how is weather in Bangalore. This is the second one where I didn't supply the city. It says hello Vinod, how is weather in your city. You can also assign default values to all the parameters if you want. For example, I can say here friend. So I can simply say here greet without even supplying any value. So in this case, of course, we are accepting the values, printing the message, which is nothing here. And then I'm not passing city here I'm not passing name as well. So you will see that it's going to say, hello friend, how is weather in your city? So let's give a try. So let's say James, Dallas, and then you can see it says, hello James, how is weather in Dallas? That's the first message. The second time it says, hello Vinod, because Vinod is the name supplied. How is weather in your city? Third time I didn't pass any parameters. It says, hello friend, how is weather in your city? So the default parameters can be given to variables, which allows the user to call the functions without having to pass values for all the parameters. One thing you have to keep in mind is that if you assign a default value to a parameter, then the subsequent parameters also must have a default value. For example, if I remove this and then let's say, for example, do not even call any of them, doesn't matter. If I save this and go back and try running this, you'll see that it says there is an error, syntax error, non-default argument follows the default argument. So this is the non-default argument, whereas this is the default argument. You cannot give it like this, but you could give the other way around. Let me undo this by pressing Command Z on Mac, Control Z on Windows, and bring it back. You can see that I can have a parameter without any default value, but the last one I can have a parameter. That's not a problem. But if you swap that, like I want to have a default for name but not for city, that is not allowed. So let's save this, run it one last time to ensure that everything is okay. So I'm going to type here some name, Vinod, Bangalore, and I get the messages appropriately. You can also have return values to carry a summary of what is the operation done by that particular function to the caller. For example, I'm going to have a function over here, def square, and then that takes a number as a parameter, returns the num times num, which is a simple code, of course. But when I call this function, I'm carrying the summary of that particular operation. So in this case, it's supposed to calculate the square and it is doing the same thing. So I can come down here. Let me comment out all this, accept a number from the user this time. N equals to int input, enter a number. And then I can say here sqr equals to square of n. And then I can print square of %d is %d. And then I'll say percent, the square of n is sqr. That's the calculated value. I save this, run the program. Once again, it's going to ask enter a number. Let's say I type 23 and it says square of 23 is 529. A function can also return more than one value, unlike many other programming languages. For example, if I can come here and I say def square underscore cube and then take num as a parameter, then I can say here return, I can say num star num, that's for the square, comma num star num star num. To call the same, I can say here sqr comma cub equals to square cube of n. Since this is returning two values like this is the value 1 and value 2, we have to assign to two variables simultaneously. And then when I get this, I can print the values. So I can say print sqr equals to %d, cub equals to %d, and then I say put a %, and then it's the sqr cub as two variables. And when I run this now, you should see that it should give me the square as well as cube. So this is something very special and different compared to other languages like C, C++, Java, where a return value can only carry one single value, whereas in Python, I can return as many values as I want. To collect them, you have to assign the equal number of variables that have been returned. In this video, let's discuss about a special programming principle called recursion, where a function calls itself. Let's take an example first, ex14.py. Consider a scenario factorial of n is nothing but n times factorial of n minus 1. Obviously, you can see that the expression consists of the original function itself, but with a modified value. So if you want to now calculate what is this particular expression going to look like, is n into n minus 1 into factorial of n minus 2. And the same thing now continues up to an terminating condition. So you have to have some kind of an exit criteria. The exit criteria in this case would be when n reaches to 1, you don't want to really go further because factorial of 1 is supposed to be 1. So with this concept now, I can write a function called factorial, let's call it as factorial here, of n is nothing but return the same thing n times factorial of n minus 1. But of course, if I just do this, then it's never going to stop because it's continuously going to call this function with a different value and again and again and again and again. So you always start with an exit criteria saying if n is less than or equals to 1, we simply say return 1. So obviously you can see that if you are going to go with this value, so initially if you had started with say 5, this is 5 into 4 into factorial of 3, then factorial of 2, then factorial of 1. When this becomes 1, we are actually meeting this particular criteria, we are going to return 1. So because we are returning 1, the recursion stops, entire expression is evaluated, and the result is going to be received. So I'm going to go check this out by typing def main and then call this particular factorial by asking the value from the user. Let's say num equals to int input enter a number, and once the user enter a number, I'm going to assign to factorial of that num, and then of course I'm going to print say factorial of %d is %d, and I'll supply the value num and then f. Let's call the main as well. If dunder name equals to dunder main, then we're going to call the main function. Save this, go to the command prompt, Python3 ex14.py, enter number 5. It's supposed to be 120 and we got 120 as the output. A collection is an object that can contain multiple other objects. In Python, there are 4 types of collections: list, tuple, set, and dict, short form for dictionary. In this lesson, we're going to look into lists in detail. To understand the same, let's get into a Python shell by getting into a command prompt and then typing Python3. You can create a list object by typing L1 equals to a pair of square brackets. So now I can say type of L1, it says list, or I can say L1 equals to list constructor. And then I say type of L1, it's the same thing. In case of the first one, we can also assign a bunch of values, like for example, names equals to, in square bracket, I can type in few names like this. Whereas if you're using a constructor, you may not be able to send values like that. Of course, you can always say cities equals to list, and inside the list constructor, you can supply some cities like this. Notice that we are supplying a list inside the constructor of the list. Obviously, we could have directly assigned the square bracket to cities. In both the cases, names and cities are list objects. So here are our 2 lists, names and cities. To find the number of elements that is contained within the list variable, you can simply say len of names or len of cities. And to access an individual element of a list, you can always say names of. So we say of here, but we write a square bracket. And then say give a number that indicates the index of that particular element. Now the index starts from 0, so the first one is 0, then you have the index 1, index 2, index 3. So I can say here names of 0, names of 1, names of 2, and names of 3. Of course, if you try to go beyond the maximum index, you're going to get an error. So the 4 index corresponds to the 5th element, which doesn't exist in names, and that will give an error called index error. Similarly, if you think that 0 is the lower limit and you cannot go beyond the lower limit, this is true in many other languages, like for example, -1 is an invalid index in languages like Java, C, C Sharp, or C++. However, in Python, -1 corresponds to the index of the last element as well. So, like names of 3, if I say names of -1, we're going to get the same thing. Similarly, I can also say names of -2, names of -3, and then names of -4, which is corresponding to the first element now. Now, of course, if I say names of -5, this will cause the same error as the earlier one, which is the index error, because you don't have a -5 here. Although the -2, -3, -4 are generally not in use, you can quickly get the element in the last position by just typing names of -1 without having to know the length of the names list. Similarly, if you want to add more values to the end of this, you can simply say here names plus equals to and then supply another list of some values. For example, I can say John, Jane in another list. So if you do this, you will be able to see that two more names are added at the end of this particular list. Now here one noteworthy mentioning is names plus equals to and a string if I give, for example, I say Robert. Now this is going to be a little funny because if you type enter and then check names, you'll see that instead of Robert being the last name, you will see each character of the name that I appended have been added as a separate string over here. The reason for that is a string is considered as a collection of characters. So each character is taken and then appended just like how we appended over here. So in other words, here is a collection is what expected. We didn't supply collection here, we supplied a string, and string is a collection of characters and each character is appended at the end of this. Now, of course, if I want to remove these elements, so you will not be able to use any of the minus operators, we have to depend on some functions. So to know what are the functions in a list, simply type dir and then either type the name of the class, which is list, or name of a variable of list type, which is names. So I press enter and you'll see that there are many functions. As usual, we are only interested in the non-dunder functions, which are these. So here is a function called append that can be used for adding more names to this particular existing names. So I can say here names.append, say for example Jacob. Now you see that Jacob is the last element. Again, you can only add one element at a time using append. If you say names.append of, let's say, two names using a list like this, say for example Rahul and Rohit, and then press enter, this list is now considered as one element that you want to append over here. So while we have a lot of strings over here, after this particular command, you will see that the last element happens to be a new list by itself. Now this is because lists in Python are heterogeneous in nature. You can have a list of elements which are of different types. Similarly, if you want to remove all the values from here, you can simply call the names.clear. So names.clear will now remove all the values, and if you say here names, it's going to be an empty collection. Let's reinitialize this names to a collection of few names. So I'm going to take these names, copy, paste, close the bracket. So now I have these names here. Now I can get a shallow copy of this names into a new variable. For example, I can say another names equals to names.copy. This will give me a shallow copy of this particular list. So which means this is pointing to a new object altogether. So I can say here now names, this is one names, and another names is a new variable which contains a similar set of values. However, if I say names plus equals to and then type here say Rahul to append to names, you'll see that names have a one additional name compared to another names. These two are independent objects and not related with each other. The function extend is similar to that of append, but append takes a single object, extend can take different objects. So I'm going to clear the screen. So names contain these values, and I can say here names.extend and then supply a list of more names here. Let's say here Kishore and say for example Bhuvan. So when we used the same thing with append, you remember that the entire list was added as one element. With this now you will see names have been added with two more names here. Instead of a single list, it has added these things. So the extend is a better choice when you want to add multiple elements to an existing list already. Let's have a look at what are the other functions we have here. So apart from extend, you have a index. Index is a function that gives you the index of a given element. For example, if I want to know what is the index of this particular text in the names, so I can say here names.index and then supply that value, and that's going to give you 3 because its index start from 0 here, 1, 2, and then this is the third one. In case if you want to find the index of a text and the text doesn't exist there, for example, if I just type here Karish and press enter, because the word Karish is not there in this entire list, it's going to give you an error called as value error, like the index error in the earlier case. So insert can be used for inserting an element at a given location. So if you want to get additional help on any of these, you can simply type your help followed by either a list.insert or names.insert, and if you press enter, it's going to give the help on this. So we wanted to know what are the parameters that you can supply to the insert function. So if I press enter here now, you can see that it says insert self. The self here is the list object itself. So in other words, you can ignore this as the first argument. So you can say that this is the first argument. Where do you want to insert and what do you want to insert? So to come back here, we just press Q and then type here names.insert. Let's say I want to insert at index 4 and a new name called, say for example, say Pradeep, and press enter. If you see now, names consist of Pradeep at the 4th index, pushing John, Jane and other names onto the right side. So it has inserted, it did not overwrite the element at index 4. Pop is another function that can be used for removing the last element. So the element is over here. So again, if you want to get help on this, you can say help and then say names.pop. Notice when I'm getting the help, I'm just giving the name of the function and I'm not calling the function. So if you press enter, it says here pop. You can say if you don't give an index, then it will take -1, and we know that the index -1 corresponds to the last element. That means you don't have to supply any value at all, but if you supply, it has to be a number and the number will represent the index. Once again, if you give a wrong index, for example, I know that there are these many names, like so since there are 10 names, the valid index will be from 0 to 9. So you can say names.pop 0 to 9, or if I simply say pop, Bhuvan will be removed from this. So I can say for example names.pop, and then you'll see that Bhuvan is returned as well as has been removed from the collection. You can see names will now have no Bhuvan here. But let's say if I want to remove this John, so we know that it is 0, 1, 2, 3, 4 and 5. You can say names.pop and then say 5. That is going to be removing John and it doesn't exist anymore in the list here. The other two functions, as you can see, reverse and sort, are self-explanatory. So this is names right now. If you say names.reverse, it's going to reverse the content of this particular names, and the content gets changed within itself. So if you want to get original values again, you may have to say names dot reverse again to get the names back. And sort also does the similar job. So I can say here names dot sort, and the data gets sorted based on the alphabetical arrangement. So if I press enter, now you see there is no return value, but the names would have been changed internally. I say names, now you can see Anu, Jane, Karishma, Kushi, etc. Now once you have sorted out, you will not be able to get the original values back. Many occasions we don't want to sort the original list. So if I bring this back again, I'll type here names equals to and add this. So now I have a names in a random order. So if you don't want to sort the content within the names themselves, but you want a copy of that, you can say sorted names and then press enter. This is going to give you a copy of that. So that's what is going to be printed. You'll see that it's printing the sorted names, but the names themselves do not have the sorting done within itself. So these are the member functions in the list class. In order to access the content of the collection one by one sequentially, you can always use a for loop. For loops are meant to be used with collections. So I can say here for some variable that I'm defining, let's say n, in names, and then I can use a colon, and then of course if it's only one line, I can just print it out here itself. So I'll say print en, and then of course I have to press enter, and you'll see that I'm able to access each of the names from the list. A list also offers something called slice operator. So it's very powerful. Let's go and have a look at that. So here is my names, and if I want to access a particular element, we know that we can say names of and then give an index which is from 0 to length minus 1. I'll say for example names of 4, which happens to be, I believe, Pradeep. So typo. So I'm going to go here, change this to a square bracket like this and press enter, and that's going to give me Pradeep. But I can supply here names, and then in square bracket I can give a starting and ending position. For example, I can say here 2 colon and then say here I want up to Jane. So you have to give the index of Rahul, which happens to be 0, 1, 2, 3, 4, 5, 6. So I have to give 6 here. So it includes the element at index 2, but it excludes the element at index 6. But in between all the elements, it would return. So you can see that we got Kushi, Karishma, Pradeep, Jane. So we got the elements. If you omit any one of these two parameters but include a colon there, so the behavior will be a little bit different. For example, I say here names of 4 colon and then not give the upper limit. It'll assume that you want from the 4th till the last one. So if I press enter here, you can see Pradeep, Jane, Rahul, Kishore, because starting from the index 4, you're actually getting the values till the end. Whereas if I say here names of colon 5, now see that I missed the starting index, so it will assume that the starting index is 0 and it will go till the index 4 because it does not include the element at index 5. So obviously Vinod, Anu, Kushi, Karishma, Pradeep are the values that I'm supposed to get. The slice operator can also take a third element. So we can type here names of, let's say for example, I want from the first one to, let's say, up to Jane. So the index of Jane is 5, so I'll have to give 6 here, so 0 colon 6. But I want the alternate name, so I want Vinod, Kushi, Pradeep. So to do that, you can simply say here 2, which is called step value. That means it's going to skip this element and goes over here. By default, the step value is 1. So you can see that now we got Vinod, Kushi, and Pradeep. So if I had given 1, then there is no change because 1 is the default step, like increment or skip the index by 1. So that is going to give me all the values. However, I can also simply say here that I don't want to mention the upper limit, I don't want to mention the starting limit. So this is going to give you every alternate names from the collection starting from the first one, but it goes till the end because I didn't mention the upper limit here. So if I press enter, Of course, I should have given here a 2 instead of 1. So let's go and make this as 2 and press enter, and you will see that every alternate name is given starting from the first one. So you can give either 3 also here. That means that every 2 names are skipped. So I should get Vinod, Karishma and Rahul. So that's what we're going to get here. So this is what we have names right now, and assume that we want to replace a particular name by another name. So I can say here names of the index of Pradeep is 4. So I can say here equals to, for example, Rohit, and then press enter. Now you can see Pradeep is replaced with Rohit. It has not been inserted, it's been overwritten. Likewise, I can overwrite a multiple values with a single value. If I want to remove Rohit, Jane and Rahul and in its place I want Pradeep back, I can always say here names of, and I can say 4 colon minus 1 because I know that this is the last one. I don't want to include that. I want to include only these 3. So this is what I'm going to get now. But I can also say assign here a new value, and the new value should be a list. Whatever the new names that I want to give here, let's put Pradeep back, and so close the bracket, and now you see this will be the replacing value for these 3. So I press enter and then I type here names, and you can see now Rohit, Jane, Rahul have been replaced with Pradeep here. Now one strange behavior you may also see that, for example, if I want to replace these 2 names with, say for example, Vinay, so I'll say names of 4 colon and not mention the ending part. So that means these 2 should be included now. Equals to, if I simply type here the word Vinay and press enter, remember I didn't use a bracket here. When I don't use a bracket, it's a string. String is a collection of characters, and this is the behavior you will see, that all the characters have been placed over here instead of Pradeep and Kishore. So this is how lists can be used, and different types of operators on the list can be applied on. In this video, let's go and have an understanding of tuple collection, which is a read-only collection. And you can create a tuple by typing something like names equals to, in a round bracket, you can give some values. Let's say I give here Vinod and say Anu, and then I press enter. Now type of names is tuple. So you can access the values back by typing names of 0 and names of 1. Now notice that even though while we create the tuple we used a round bracket, we're going to use the square bracket for accessing the values at a given index. And like in case of list, if I type here names of 2, which is an invalid index, we're going to get an index error. And if I say names of -1, I'm going to get the last name there, which is Anu. Same thing, my bad. I should have said here names of -1 to get the last element. So we got it. Names of -2, we get the first element or the last but one element. But again, if I say names of -3, because at this time -3 is an invalid index, you're going to get an index error anyways. But unlike the list, if you try to say names of 0 equals to something else, say for example Robert, and then I press enter, you'll see get an error, type error, tuple object does not support item assignment. So my names are intact. However, if you want to use the plus equals to operator, that is allowed mainly because it's going to be a new object. Let me show you with an example. So I'll type here names. It contains a tuple of 2 names. If I say here names plus equals to and then use another tuple like this and one more name like this, this is going to create a new tuple consisting of the original 2 names plus these 2 names, and that new name will be assigned to names. So for example, if I press enter now, you'll see that names consist of 4 names. But it doesn't mean that it allows us to write. For example, if I type here ID of names, you'll see that there is a number. If I say here names plus equals to, and then let's say I want to add say Rahul and Rohit, as two more names. I press enter. Now if I say ID of names, it's going to be a different object because tuple doesn't allow a mutation or changing of the value. So it has constructed a new tuple altogether. So unlike the list, tuple doesn't have much functions. If I type here dir names now or dir tuple, you'll see that there are only two functions. One is called count and one is called index. Count gives the number of elements or number of occurrences a given text exists. In our case, we have a collection of unique names here. So if I type here names, you can see that there is no duplication. So if I add one more time, say for example these two values Rohit and Rahul, now names Rohit and Rahul exist twice, whereas the rest of them exist only once. So if I type here names.count of, say for example Rahul, it says that the count of Rahul is 2, whereas if I type here say Vinod, it's only one time. So count is not the number of elements, but count is the number of times an element occurs within a list or a tuple. So index will give you the index of an element if it exists. For example, if I type here what is the index of Karishma, so I can say here names.index and then type the word Karishma or whatever that you're looking for. And if that exists, it's going to give you. If it doesn't exist, like in the previous case, it's going to give an value error. Tuple.index of x is not in tuple. So you can always check whether an element exists in the tuple or a list by using the in operator. For example, I can always check here Vinay, which is a text, in the names, and this is going to give me true or false. Since names doesn't contain Vinay, you will see that it says false. However, you can say here Vinod in names, it says true. And it is case sensitive, so if you try here with a capital V, you will see that it says false again. Now this is also true in case of list as well. So tuple is used when you want to have a read-only collection of values where you don't want to manipulate the values. Now these are immutable, whereas list is a mutable collection. A tuple also can be constructed by using the tuple constructor. So for example, I can say here names equals to tuple like this. So this is an empty tuple. So now I'll have to add values, which I cannot because tuple is a read-only collection. So the way you might probably want to use tuple constructor is by passing something like a list or other kind of collections. For example, I can say here names equals to tuple of a square bracket for list or even a round bracket for a collection. So if I already have a collection like this, for example, let's say Vinod and say Anu. Now this is a tuple made out of a list here. So now I can say here type names, this is tuple. Most of the times if you have a list variable, like let's say for example I have here names equals to say Vinod or say Anu, and I have here a list. So type of names is a list. I can say here t names equals to tuple of names. So now we are constructing a tuple using a list here. This is one of the practical uses of the constructor. If you want to create a tuple with a single value, for example, let me clear the screen here. And let's say I want to type cities equals to a bracket, a round bracket. And if I type here Bangalore, which is a city. So if I press enter, notice that the data type here of cities is not a tuple. It says str because you have a single value here. The bracket was just assumed as it's a grouping operator, not as a tuple operator. Now, if you want to create a tuple in this fashion, you just have to add a comma here so that it is now assumed to be a collection of values inside the round bracket, not just one value. And now, of course, if you say type of cities, you'll see that it says it's a tuple. Of course, if you want to create a tuple with no elements at all using the round bracket, you can always say cities equals to like this, and then if you see type of cities, it is a tuple. You don't have to give a comma in this particular case. A set is a collection of unique values, so without any repetition. And in this video, we're going to see how to use sets and what are the different operations that are allowed within a set. So to create a set, you have to use curly bracket. Of course, if I type here, let's say names equals to an empty curly bracket, this will now be considered as a dict, not a set, because there are only limited number of brackets in your keyboard. So the curly brackets are reserved for dict by default. A dict is a short form for dictionary, but we will see that in the next video. But if I type here, type names, you'll see that it says dict, not a set. So one other way you can do is you can say here names equals to set, and now of course if you see type of names, it's a set. But if you have some initial values, you can always use the curly bracket, then it is going to be considered as a set. For example, if I say here in curly bracket, if I say Vinod and let's say Anu and press enter, now you're going to say the type of names is a set, not a dict. So we will see dictionaries in details in the next videos, but for this video we're going to look into only the set. So if you type names and press enter, it's going to show you the values in curly bracket. But unlike the list, if you try to access names of 0, you'll see that it gives me an error. Set object is not subscriptable. That means you can't access the elements using an index. Another strange behavior you may also see is if I have here names equals to a bunch of more names here. Let's start with Vinod, Anu. Let's add a couple of more. Let's say John and Jane. And let's say Robert, say Rohit and Rahul. So I have multiple names over here. If I type names and press enter, you can see straight away that the order in which I entered the values is not the same as the order in which it has been stored. Now, this is primarily because of some internal structure where in order to ensure that there is no duplicates, it uses some concept of hashing. So let's not go too deep in the concepts of hashing, but again, you can see that the order in which we have added is not the same in which it has been stored. So because of which, I cannot say, hey, I added the first one as Vinod, give me the first one, we would have got Kushi. So this is why it says that the subscript or index is not meant for set over here. So the only way you can access these elements would be using a loop like a for loop. So I can say here for n in names, and then probably you say here print name or n. Now this is the way you can access a set. Unlike the tuple, set is not immutable. You can add values, you may be able to delete the values and so on and so forth. For example, let me clear this and I'll type names to see what is the content of this. If I want to add more names to that, there is a function called add. There are other functions also. Let's have a quick look into the functions or the members of this particular names. I'll say dir set or dir names. You will see that there are many functions like this. Now the add function is equivalent of append in case of the list, but append gives a notion that you are adding to the end. Add does not guarantee that it will be added to the end. So if I type here names.add and let's say mark and press enter, now mark is added somewhere in between, not at the end. Similarly, you can use a clear function where you would lose out all these values and it becomes an empty set. Copy will give you a shallow copy. Of course, if you want to make some changes to this, for example, we saw earlier names1 equals to names.copy. Now you have two sets, names and names1. But if I go and say names1.add, let's say for example, say Roger and press enter, names does not contain Roger, but names1 contain Roger here now, right? So it's a shallow copy here. Similarly, you have a couple of other functions. These we're going to see in a couple of minutes. There is a pop function similar to that of a list, but if you go and take the help on names.pop, the pop function takes no argument. It says that remove and return an arbitrary set element. So that means there is no guarantee of which element got removed. but it gives you the element that is being removed. So obviously you don't want to call this. So the dot 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 indicates here that there is no arguments to be supplied. So if I type here names, that these names exist, names.pop will give you an arbitrary element. Again, you say names.pop, another pop, but now you see that those names have been removed and you are left with the remaining names. Which value being removed is totally controlled by the set itself. Now internally, set maintains an array of values where Kushi was the last value in the array and Mark was the previous to last and Rohit was previous to Mark, and that's how it got removed. So we don't have much control on this, so I suggest not to use this at all. So let's go have a look at a couple of other functions. So dir names or set. So remove is the one that you might want to use if you want to remove an element. For example, if you take the help on set.remove and press enter, you can see remove an element from a set. It must be a member. So you should supply the value that you want to remove. So if I type here names, let's say I want to remove John, I can say names.remove and then you supply John as the parameter. And you can see it has been removed. If I say names, you'll see that John doesn't exist in the collection now. Now the other functions, difference update, intersection update, is disjoint, is subset, is a superset. Then you have few other functions like union, update. All these things are mathematical set operations provided by the set object here. To understand the same, let's take two different sets. Let's say n1 is a set of some numbers. Let's take 1, 2, 3, 4, 5. And then I want to take n2 equals to, let's take 4, 5, 6, 7. So there are two sets over here. The function difference, for example, I can say n1 difference of n2 will now give me an equivalent of n1 minus n2. So basically we say the elements in n1 which are not there in n2, so which happens to be 1, 2, 3. So this is what is going to be output. Similarly, if I say n2 dot difference of n1, you will see the same result. So this time you're going to get the elements in n2 which do not exist in n1. Now the same thing you can also do using a simple n1 minus n2, and you will see that you get the same n2 minus n1 will give the previous result. So the difference is nothing but the minus operator in the set theory. Similarly, if you say n1 dot union of n2, this is going to give you the collection of all the values in n1 and n2 without repetition. You will see that you get 1, 2, 3, 4, 5, 6, 7. And the same thing happens with n2 dot union of n1. This is same thing. You're going to get the same result as well. Now you can do the same thing by typing n1 pipe n2. This is to give the union. So n2 pipe n1 gives the same result as well. So instead of calling the function, you can use the operator over here. Now, if you want to give the intersection, that means what are the common elements between n1 and n2? So you can say n1 intersection of n2. You'll see that you got 4, 5, which is exactly same as n2 dot intersection of n1. You can perform the intersection operation using an operator also. So you can say n1 ampersand n2, which is 4, 5, and n2 intersection n1, which is the exact same thing. So your original values are still the same. There is no change in the original values. However, if you are doing a difference update, so if I take here, for example, n1 minus n2, so this is the difference actually. So if I say here n1 dot difference update and then say n2, now what it's going to do is it's going to find the n1 difference n2, which is 1, 2, 3, and will be updated to n1. So right now the values of n1 is this, but after this the 1, 2, 3 becomes the new values of n1. So if you type here n1, you'll see that original values have been updated. So it has removed the duplicate values which existed in n1. The same thing would have been done using n2, But now, since n1 is this and n2 is this, there is no duplicate values or there is no common values. The intersection will not be there. So the difference update of n1 or n2, they don't matter anymore. For example, if you do a n1 dot difference update n2, there is no change. n2 dot difference update n1, there will be no change as well. Now the same thing I would have done using, for example, a minus equals to operator. Let me reassign this value to n1 to check the same thing. So n1 is this and n2 is this. 4, 5 is the common factor. So I can always say n1 minus equals to n2, and this is the same as difference update. It's going to say n1 minus n2 and then reassign that to n1. So you can see n1 now contains only 1, 2, 3. The same thing is applicable for other operators also. For example, let me clear the screen here and reassign n1 with this value. So we have n1 and n2. Now something like if I want an intersection update, that means the common factor between n1 and n2 is 4, 5. So I can always say here n1 ampersand equals to n2. So what it does is it's going to find the intersection between n1 and n2, which is 4 and 5, and will be reassigned to n1. So if I press this and say n1, you'll see that the 4, 5 has been assigned to n1. The same thing also can happen for union. So union update, for example, right now n1 is this, n2 is this. I can always say n1 pipe equals to n2. This should actually create a new set that contains both the values of n1 and n2 without repetition, which happens to be 4, 5, 6, 7. And that should be assigned to n1. And you can see it has been updated over there. So one thing that set always ensures is that there is no duplicate. For example, let's go back to our names set here, which contains these values. If I say here names.add and then type here say Vinod and press enter, you can see that len of names, which is exactly 6. Even priorly also there was 3 plus 3, 6 values were there. So even if you use a loop here for I in range of say 0 to 100, names.add, and let's type Vinod and then press enter. And if you type here len of names, you'll see that it still is 6. However, if names were to be a list, for example, let me copy these names and type here names equals to a square bracket and then enter. So now names is a list here, right? So names, type of names is list. And if I use the same for loop now here, but of course I don't have an add function, it is supposed to be an append function. Press enter. You'll see that len of names is now going to be 106 because I added 100 names to an existing 6 names. So it's going to be 106. So list will allow duplicate values, whereas a set ensures that there is no duplicate values at all. Python has a data type called dict, which is a short form for dictionary, which allows us to store data in key value pairs. For example, if I want to store information about a person, then I can create a dict in this way. So I can say p1 equals to, in curly bracket, I can give a key such as name and then a value of the person, let's say Vinod, and then I can specify here city as another key, and then I can give here value Bangalore as another value here. I press enter. Now p1 is a dictionary. Notice we have used the curly bracket just like the set, but if I say here type p1, it's going to say that it's a dict instead of a set. The difference between set and dict in terms of its usage is the set is a collection of comma separated values inside the curly bracket, whereas a dict is a collection of comma separated value where each value here is a key value pair by itself. And unlike the set, dict is something that you can maintain the order. For example, if I say here name and city has been stored, if I type here p1, you will see that we get the same order in which we have added. In order to add a new element to p1, I have to supply a key value again, and the way you can do is you can say here p1 of, for example, a new key here equals to say Vinod at vinod.co, press enter. Now you see P1 has 3 key value pairs here. To retrieve a value for a given key, I can again say here P1 of city like this, and then I get the value. So the key here, I have used strings, but key can be any immutable data type, such as even a number. For example, I can say P2 equals to a curly bracket 1 colon something else. Let's say, for example, I can say Vinod, and 2 is nothing but, say, for example, Shyam, like this. And P2 is an object or a dict that represents two keys, which is 1 and 22. So I cannot say P2 of 0, but I can always say P2 of 1, which gives me Vinod, P2 of 22, and you can see that I get the value Sham. So generally, the keys here would be strings, but not necessarily. Once you have a dict, there are a lot of functions a dict allows us to use. So if you want to check, you say dir dict, and then you can see that we have a bunch of functions that says clear, copy. These are same as the list and set. Clear removes all elements of the dict if you want to empty, or if you want a shallow copy of the dict, so we can say copy. And then there are other functions. For example, get is the way you say give me a value. So if I say here p1, this is the p1, I can say p1.get, and I can say the key is name. I want to get the name of p1. I get this, which is same as what we did earlier, p1 of, and then say here name. But the main difference between these two is get is a function, and in case of an absence of a key, for example, let's say I don't have a key here called phone. If I type here p1 of phone like this using a subscript, it is going to give me a key error, like in case of a list where we accessed a wrong index and we got this error. Here also phone is like an index here, but that doesn't exist, so it gives you an error. Whereas if I say here p1.get and then say phone, since phone doesn't exist, it returns none. So to understand, let's go to the help of p1.get, press enter, and it says that get, you supply a key and also an optional a default value in case the key is missing, what is the value you want. So we'll see them in practical examples in the forthcoming videos. But at this time, I didn't supply anything. Now the value that you get is none because that key doesn't exist. So it says here, return the value for the key if the key is in the dictionary. Otherwise, the default value will be returned, and right now the default value happens to be none. So it is always better to use get instead of square bracket notation, because if you're writing a square bracket notation, you must be ready to handle these kind of errors. Whereas here there is no error in case if the key is not found. So which is a good thing in many places. If you type here p1.items, it's going to give you collection. You can see that it's giving you a list of tuples. So the first tuple in the list is going to be a name value pair of the first one, then another name value pair, another name value pair. Usually this is used when you want to iterate or loop over the dictionary. For example, let's say this is P1 and I want to loop over each of them and then get name is Vinod, city is Bangalore, email is so and so. So what I can do is I can use a for loop here, for item in p1.items, and then I press enter, press couple of space, print. The first thing that I want to do here is, let's say percentage s is percentage s, and then I use a percentage symbol, and then I can say here item of 0, which happens to be the key, and then item of 1, because if you remember, item is a tuple. So if I press enter now, you should see, of course I should have one more bracket here and another bracket here. So if I press enter, you will see that it's supposed to give name is Vinod, city is Bangalore, email is vinod@vinod.co. Now, if you want to find out what is the data type of each of the items, so I can use the same loop once again and then say here print type of item. It's supposed to be a tuple, and you can see that all the three of them are tuple. So since the tuple had two values exactly, so the first one is the key, second one is the value there. So similarly, let's go and see what other functions we have. So dict dot, simply say dir dict. So we saw items. So keys will give you only the keys, and values gives you only values. For example, this is P1. P1 dot keys will give you only the keys as a list. As you can see that there is a list here, name, city, email, and P1 dot values will give you the values. So you got Vinod Bangalore and Vinod at vinod.co. So that's to get individual values or individual keys. So pop is an example of removing a particular element. So if I say here help on p1.pop, it will remove the specified key. That means you have to supply a key and return the corresponding value. If the key is not found, the D is written where D is the default value in case if the key is not found. So for example, let's say I have here P1, which is this value, and I want to remove the city. So you can say P1.pop and then supply city, press enter, and P1 is now not containing the city Bangalore at all. Another way of creating a dictionary object is by typing, let's say this time I want to say P3 equals to, I can use a dict constructor. Unlike the list, set or tuple constructors where you are not able to supply multiple values, here we can pass dynamic parameters. For example, I can say here P3 name equals to and then supply a name, let's say for example Shyam, and then I'll say city equals to say Bangalore, email equals to sham at example.com, and then I can say age equals to 45 and press enter. You can see that we got P3, which is a new dictionary. Notice here that we did not use a quotation mark for name, but for values we have given wherever it is applicable. For numerics it is not applicable. But when the dictionary is returned, it is giving me key value pairs in the form of strings here everywhere. Of course, age is a number, you get a 45 directly. When you want to loop over a particular dictionary, you can directly say for something like say K in P3. K will take only the keys of this P3. So I don't have to literally say P3.keys, but this is automatically implied. So if I print here what is K, you will see that K is nothing but the key, right? Name, city, email, age. So what I can do is I can say for K in P3, print, and then I can say percentage S is percentage S, percentage, and then I supply here K, and then P3 of K. So where K is the key, like name. So P3 of name, P3 of city, P3 of email. This is what we are actually trying to get from here. And let me press enter, and you'll see that we get name is Sham, city is Bangalore, and so on and so forth. So if you want to loop over a dictionary, what you get is a key, and then using the key you will be able to access its values. You can also check if a key exists in a dictionary. For example, name in P3, and it says that true, but if I type say state in P3, it says false because state is an invalid key. Whenever you're trying to access a particular value of a key, you can always check if name in P3, and then only you say P3 of name, and that's a better way of accessing the dictionary values. In this lesson, let's see some of the very useful tricks that can be applied on list. Number one to start with is called list comprehension. Consider you have a list of numbers, which is a bunch of random numbers. I'm going to type here. Suppose I want to get a list of all these numbers, but in its a square format. For example, I want square of 10, square of 40, square of 5, and so on in another list. How would you do that? So generally in any other programming language, you would probably use say squares equals to a new list, and then you say for n in nums. Then you may say here squares dot append n into n. So press enter, and now of course if I say squares, you will see that we have a square of each of the numbers present in the nums. But here literally we are using a loop that runs over each element and then doing some work. So this might be a little time consuming because Python is an interpreted language. Alternately, Python provides a very simple mechanism of creating a new list and asking the new list operator itself to do the square. And the way you can do is squares equals to, you create a new list by starting with a square bracket operator, and then you say here for n in nums. Now this actually gets all the values as is and then constructs a new list. But all you have to do is to go behind this particular for and then write n star n. So you can read it like create a new list where you have the n star n for n in nums. So we can say that for every n in nums, return n into n over here. If I press enter now, we have the exact same results like the previous one, but without using the actual for loop. So we didn't have to do an iteration here. Let's take another example. Let me clear the screen. Names equals to a bunch of names. I'm going to type here Vinod, Anu, Kushi, and Karishma. Now suppose if I want to convert this list into a list of uppercase versions. So you can use names equals to, and then in square bracket you can say here name or some variable which is going to be representing one element of names at a time, and then say here upper for name in names. Press enter. Now you can see names contain the uppercase version of the same. Couple of things you can observe here is that name is a new variable that you are declaring here for the for loop, and which actually picks up one element from these names, and then the converted value here is the name.upper. The entire list here is reassigned to names, so we didn't have to create a different variable at all. Here is another example. Let's consider data is an array of few numbers and a couple of non-numeric values. Let's say I have here some non-numeric value and some ASDF. Maybe I have here say 45 and say PQRS. Suppose if I want this to be containing only numerical values, then how can we do that? So we can simply say here data equals to D for D in data, and we can add an if condition, and only if the if condition is satisfied then collect the D. So I can say here if type of D in probably int or float. If you carefully observe here, the condition says type of D, where D is some variable. Is it in the list of one of these two? So is it in this collection? So if the answer is yes, then D will be collected. So if I press enter now, you can see that data contains only 10, 4, 56, 45, omitting anything other than int and float variables. Let's extend this example to add one more condition. Let's say data is equals to this with few more values. Let's say 1, 2, 3, 4, 5, 6, 7. So there are some even values and odd values. Suppose if I want to create a new collection that contains only the even numbers in this particular collection, what I can do is I can say here even nums, a new variable, equals to a new list of D, where D is a single element of this data. For D in data, I can say if type of D in either int or float, as well as D modulus 2 equals to 0, so that it is an even number. And now of course if I say even underscore nums, we would get the even numbers from that, excluding non-numeric values. Sometimes we want to use the function sum. So if I take this value and then say sum of this list, you'll see that we get 82, which is the actual sum of this list. So sum is a global function which calculates the sum of elements. But if I say here sum of data, you're going to get an error because type error, unsupported operand for int and str, because somewhere it has calculated the sum of all these values, but then when the result is being added to Vinod, so there's an int and there's a str, and it says plus is not applicable for that combination. So this is where we may want to say that give me only if that is an int or a float, then we want to calculate the sum. So what I can do is I can just copy this section and then say here sum of this entire expression. Now I get the sum of numbers in that particular group. So use the list comprehension when you want to convert a data of one type into data of another type. Let's take one more example. This time I want to say people is equals to a list, but a list of few dictionaries where I have here name and is Vinod, city is Bangalore. I put a comma to add another dictionary. I'll say name Robert, city Dallas, one more date of name equals to John and city equals to New York. Now I close the square bracket to say that this list is ended. Now you have people, which is a list of dictionaries. Let's check it out. People, press enter. We got a list of 3 dictionaries. Now sometimes if I want only the names from this particular collection, I can simply say here names equals to a new list, and I can say p.name for p in people. So we know that people is a list and I take one element from the list, and that one element happens to be one dictionary, and from the dictionary we want the name. Now unlike other languages, the key values cannot be accessed using the dot operator, so that's my mistake. So I have to use here a square bracket and the key in this fashion. So now of course p of name is retrieved for every p, where every p is every dictionary. So from every dictionary I'm collecting the names, and now you see I have here names, which is only the names of these people. So whenever you think of converting a list of something into a list of something else or filtering that list, think of list comprehension. Now let's see some of the other cool stuffs that you can work with in a list. So whenever you have a list, you want to do a reverse. Let's take this example of nums. I have these nums and I want to reverse this. You can do it easily by typing rev nums, which is a new variable, equals to nums, and then you say here -1 is the step. Now when you give the step as negative, it will automatically start from the first element from the reverse side and then starts decrementing and then starts going to give you this. So if I type here rev nums, you will see that the entire list has been reversed. Since list and strings are more or less equivalent, you can also apply the same thing for list. For example, if I type here name equals to say Vinod Kumar, and then I can say here name of colon colon -1 will give you the same name in reverse order as well. Let me clear the screen. This is what we have people, which is a list of dictionaries. Let me assign the first one to a variable called p1. So I can say p1 equals to people of 0, and that's going to be Vinod and Bangalore. If I want to print the value of this, we generally use print and then use a %s is from %s, and then another percentage, and then we say p1 of name, comma p1 of probably city. If I close the bracket, press enter, we get Vinod is from Bangalore. Now for 2 of these fields it is okay. So if I have say 10 keys and I have a formatted string that prints 10 of these values, then obviously printing like this would be probably a time consuming task or sometimes complex as well. There's an easy way of doing, and what I do is I just use the same statement, but instead of this entire stuff I just type here p1. Of course, from P1, I want name to be printed over here and city to be printed over here. So all I have to do is to add a bracket in between the percentage and S, and then say what is the key I'm interested in. So I'm interested in name here, and then I'm interested in city here. So now you can see percentage name as, Name is the attribute or property that is going to be picked up from this dictionary, and city is the attribute or property taken from P1 for this particular expression. So if I press enter, you'll see the exact same thing. One last example on list comprehension. Have a look at this dir and str or any class that you give. You will see that there are a lot of dunder functions that are being displayed, which practically are useless for us because they are meant for internal usage. If I have to get a list of only the non-dunder functions, I can create a function called ddir or dirr, something like that. When I say str, I want that to display only the non-dunder function. So to create such a function, it's very simple. I'll say here def dir, and then it takes a parameter. For example, the parameter should be a data type. So I'll call it as dt. And then I can return a new list, and I can say here 80 for 80 in dir of the dt, which is the data type, but only if the first letter of that 80 happens to be one of the attribute at this point in time. I'll say 80 of 0 not equals to an underscore. So there are some attributes which may have a single underscore and some of them may have double underscore. I'm only saying that if the first letter is not an underscore, then we want to return this. So now I have this function called dirr. I can call it as dirr str, and you'll see that I get only a list of functions that are non-dunder. Let's check it out again. dirr of int, and I get only the functions which are not starting with an underscore here as well. In Python, we have a class called zip that can be used for grouping data from multiple lists. To understand this better, first let's create a list called header, whose values are, for example, name, email, and let's say city. And another list called values, where I'm going to give some data here for corresponding keys that we gave in headers, like Vinod, Vinod.co, and Bangalore. Now that we have these two lists, we can ask the zip object to group an nth element of header with nth element of values. For example, the value at index 0 of both of these lists can be grouped as one single tuple. Similarly, email and Vinod.co can be grouped together. City and Bangalore can be grouped together. To do that, we simply have to call the zip constructor by supplying two or more lists. Since we have two lists, so I'm going to supply header and values, and when I press enter, you simply get a zip object. But if I pass this zip object to a list, then I get a list of bunch of tuples. If I pass that to a dict, then we get a dictionary. Importantly, the zip object is an iterable, so I can iterate over this zip object that we got and then find out what each of those data structures consist of. For example, I can say for some loop variable called data in zip of header and values, and if I simply print here data, it's nothing but a tuple which contains data from both of these lists. So the first one here, the index 0 of the zip object, consists of element at index 0 of header and element at index 0 of values. And the same thing goes for email and city as well. So if you supply this to the list constructor like this with header and values, you'll see that it's a list of tuples. But if you supply this to the dict constructor, you will see that you're going to get a data structure that consists of key value pairs from both headers and values. So I gave here header, values. We got name colon Vinod, email colon Vinod@vinod.co, and city colon Bangalore. JSON, which is an acronym for JavaScript Object Notation, is a method of encoding text data so that two applications can exchange data in an understandable format. This is very widely used in RESTful web services. Since Python is a very powerful language that can be used for creating such web services, At times, we may want to convert Python data into a JSON format. A JSON object is a very simple representation of unordered set of name value pairs. An object in JSON always begins with a curly bracket and ends with a curly bracket. And the keys are always supposed to be string values. And the value themselves can be of different types. For example, they can be a string, number, object, array, true or false. Notice the true or false are in lowercase. It can also be a null value representing that the value is missing. In this video, let's go and have a look at how we can convert a Python data structure into a JSON data. For that, consider this variable called P1, which is a dictionary that contains a bunch of keys. Note that the keys are here represented in single quotes, whereas in JSON, it is always expected that the keys are in double quoted text. The values themselves can be of different types. Here we have a string. Email is again a key, and there is a value here which is again a string. If you see here, there's a key called married, and the value for that is true, but Python true false start with a capital letter. Languages, here is another key that has a list of strings. So this can go as complex as possible, but for this demonstration, let's see how to convert this P1 into a JSON string. In order to convert a Python data into JSON strings, you need to import the module JSON. So first thing is import JSON. Now that we have JSON, we can check what are the members of this. To list the non-dunder functions of JSON, let's make use of the custom function that we have written earlier called dirr, and then type JSON, and you'll see that it has these many non-dunder functions, out of which these two can be used for converting a Python data into a JSON string, and these two functions, load and loads, can be used for converting a JSON string into a Python object. Now the difference between dump and dumps is dump actually converts the JSON and then stores that into a file, whereas dumps is a function that converts the Python data into a JSON string and returns the same. Let's give it a try. JSON.dumps and then type here P1, and if I press enter, you can see that we get the same data in JSON format. Now one thing that you can notice straight away here is that all the str values of this P1 have been converted into strings in double quotes here, and that's one of the key requirement of JSON. But you can also do certain things like formatting while representing that as a string. So where this function takes a couple of additional parameters. So I can say here help on JSON.dumps. And you can see that there is an object that we have to supply, which gets serialized into a JSON formatted string. But the one that you can try using for indentation is this indent. So I can specify a number of characters that it has to use for indenting the key value pairs. So we can use the same thing. So I can say here JSON.dumps P1 indent equals to, for example, 3. And you'll see now that we got indentation in 3 characters. But since this is an str, we are not able to see the indentation. So we're going to say here print and then say JSON.dumps. P1 is the object, indent equals to 3. And then now you'll see that the actual data is nicely formatted over here. At times you want to save this into a file. Instead of using the JSON.dumps, you have to use the JSON.dump function. If you want to know how do I save it, let's go give it a try. So first I'll say help on JSON.dump. You can see that I have to supply 2 mandatory parameters. The first one is an object, which is the data that you want to convert. The second one is the file pointer, which represents a file that can be used for writing. Of course, other parameters like indent can also be supplied. So for doing this, first let's create a file by using fp equals to open some file name. Let's say, for example, I can say person.json, some file name. But importantly, mode equals to w is required because otherwise you will not be able to open the file if the file doesn't exist. Let's use json.dump and then supply our p1, which is the data that I want to write. And then fp is the file pointer, which represents a new file called person.json. And then indent equals to, for example, 4. I press enter. Now the file gets opened and closed, and in between the content would have been written. So I'm going to just exit from here and then check if the file exists. You can see that there is a file called person.json, and if I see what is the content of that, so you should see that it's the same content that we wrote from Python shell. In Python, it is possible to define functions with variable number of arguments. So there are three forms, and all of them can be independent of each other, or you can use them together as well. So the number one type of arguments is called the default arguments. Then there is something called arbitrary arguments, and then keyword arguments. Let's take examples of each one of them with some script. So this time I have opened my text editor here, so which contains the previously coded Python scripts. I'm going to create a new one called ex15.py. Here I can write different functions which take different types of arguments. First, let's start with a simple function called hello, which takes a couple of parameters. I'll say name and then city as two parameters, and it is supposed to print hello name, how is weather in your city. So I'm going to type here print, I'll say hello %s, how is weather in %s. And the first one is name and second one is city. So it's going to say whatever the name entered by the user here will be printed here, and then whatever the city supplied is going to be printed over here. Let's put a question mark because we are asking a question. So to call this, I'm going to use a main function. I'll call it as def main, which simply calls hello and supplies, I'll supply my name and then my city. And then in order to call the main, I'll type here if dunder name equals to dunder main, if that is the name of your module. So we're going to call the main function. So I'll save this, go back to a command prompt, and I've opened a command prompt or terminal where I'm already in my work folder. I can simply type here Python3 ex15.py. I press enter. It says hello Vinod, how is weather in Bangalore? Suppose if I go here and comment this line and then simply type hello and say Vinod. If I run this code right now, you will get an error because the hello function expects two arguments and it's missing a value for city. So we are defining two variables, but we are supplying only one value here. Now this is an error. But what you can do is you can say that, hey, if the city is not being supplied when it is called, we can take it as a default value, say, for example, your city. So now I have given a default value here. It is okay if the user doesn't pass. So let me uncomment the first one. So you can see that I can pass it with two variables or I can pass it with a single value here. So I can go back and try this now. Let me clear the screen and then use Python3 ex15.py. I press enter and you can see both of them are being output. So hello Vinod, how is weather? There's a typo here, so let's go and fix that. So now both of these are supposed to be executed. So I'm going to now go back and type here Python3 ex15.py, and if you see here, it says hello Vinod, how is weather in Bangalore for the first time. Then it says hello Vinod, how is weather in your city. So it's taking this as the default value. So I can also supply here a default value, say for example, say friend, and now I can even say here hello without passing a parameter. So if I go back to the command prompt and run the same thing, you'll see now, hello friend, how is weather in your city? So this is called default parameter, where if at all there's a default parameter, you don't have to supply, or you can override that by supplying explicit values. The second type of arguments to a function is called arbitrary arguments, and this is when if I don't know how many parameters I can supply, I can declare an arbitrary argument. Let's define a function called average, which is supposed to take a bunch of numbers and then I should be able to calculate the average of all those numbers. So for the timing, I'm going to just say pass because I will implement the logic in a minute, but I should be able to supply multiple arguments. So let me comment out these things and then say here AVG equals to average of 20, 30, 12, 45. In order to find the average of this, I supplied 4, and then let me print that. So print AVG equals to plus icon 2. So I'll have to say here percentage %D or percentage %F, and then I say percentage AVG. So I'm printing the average. Now let's say I want to supply more values this time by giving 2 more values. Now, this is possible if you define here an arbitrary argument, something like a list. So, to do that, you just have to declare one variable, not multiple, because if you declare multiple, then how many you will declare? For example, for this, you might have declared 4 variables. For this, you might have declared 6 variables. But what if I supply 100 numbers? So obviously you can't declare here 100 variables or hundreds of variables. So this is where we simply say here star args. You can use any name you want here, but general practice is we use star args. Now that we got star args, there is no problem, but I'm not returning any value from here, so hence I will not be getting the average. But all these things will now be received as a tuple here. So if I come down here and print the data type of args, say print type of args is, and then I'll type here type args. So you should actually see that it's a tuple. So let's go and try this once. Python3 ex15.py. So the error is because I'm trying to print using %f and avg is not returning anything. It's returning none actually speaking. So I'm going to comment this one and this one temporarily. I come back and then try it again. You can see that the args here is a tuple. So we got a tuple here, and now I have to calculate the average and then return. So I'm going to comment this line, remove this pass. I have to calculate the average. To calculate the average, I will take sum and the count. So first thing I want to do is to get only the numerical value from this particular collection. For example, if I type here ASD in a string, maybe I have written here false to say some boolean. So I want to take only the numerical values from here and then calculate the average. So to do that, we have seen what's called list comprehension in the previous lesson. So we can use the same thing. So I'm going to type here nums equals to args is a tuple. So I can say here, give me a list of n for n in args if type of n is one of the int or float. So only if that is the case, give me the nums. Now that I got the nums, I can say here sum of nums, because that is the built-in function that can calculate the sum. And then I can say divided by len of nums, which is another built-in function which gives you the count. And this is going to be my return value from this function. So obviously now I can collect that into average and then print it back. So I'm going to uncomment these two, save it, go back to the command prompt, and then run this, and you should see that we have 2 averages being printed. So even if I have supplied some non-numerical values, because of the list comprehension, it's only going to take up numerical values, and then it is going to calculate the sum and the length, divides one by another, and then I get the return value here. Let's comment out all this and then try one more. Now sometimes you may declare a function with multiple key value pairs of arguments. Now this can be done by creating a parameter with double star, and we call it as kwargs for keyword arguments. Let's write a function called printinfo which takes 2 stars kwargs. This is a convention. Again, you can use a different name if you feel like. And this time if I say print type of kwargs is, and then I'll type here type kwargs, you should see now that it's going to say it's a dict. But how do I call this? In order to call, I can simply say here print underscore info. I'll say name equals to Vinod, city equals to Bangalore, and state equals to KA. None of these variables have been defined over here. Like in the first example, we had declared as name and city. So whatever that we supplied in the first cases, they were all going to these two variables. But this time the name, city and state are totally arbitrary variable names which are created as keys of this particular dictionary, and then these will be the values of the dictionary. So you can also print what is the value in that kw args and check it out. So let's go and try this, and you will see that the type of kw args is a class dict, and whatever the values I supplied is in that particular dictionary. In this case I gave a name and a city. Let's say for example I'm going to give here print info and supply something. Let's say type equals to PC, and then I can say make equals to, let's say, Apple, and then run this, and you can see that I can supply totally a different set of parameters. It doesn't matter what it is, it's all user defined. So this can be used for dynamically receiving named parameters. We will see some practical use cases of this in the mini project that we're going to work on. Python is a functional programming language. What it means is that a function is an object in Python, and just like any other objects that you can pass to a function. So functions themselves can also be passed as arguments to functions, as well as they can be written from other functions also. Python also provides a very simple representation of a function called lambda expressions. So let's have an overview of the same. Now I'm in a Python shell where I can define a function called hello, which takes a name of a person and then should return a string that says hello that person. So I'm going to give a couple of spaces here and then say return probably a hello message plus name. So if I say here type hello, you will see that it says it's a function. And in order to call the same, I can say here hello and then supply a name, and I should see hello Vinod as the return value. Now since the function has just a bunch of one or more arguments, there's just a single line of statement which is a return value here. Now in case if there is a requirement of me supplying this function as an argument to another function, then I can create a lambda expressions instead of a function hello. To do the same thing, you have to create a variable. Let's say for example this time let's call it as welcome. I'll say welcome equals to lambda and then the argument of the function, in this case it's the name, and then colon what is the return value of this particular lambda expression or lambda function. So I'll have to say here hello plus name. Now notice that because of the keyword lambda, this becomes the function argument just like how we have here, and whatever is followed after the colon, this is the return value from this particular lambda function. Unlike regular functions where I can have hundreds of lines of code and then optionally I can return a value, lambda expressions have 0 or more parameters and exactly one expression which is considered as a return statement. So if I go and say type welcome, you will still see that it's a function just like the hello, and then I can call here as welcome and then probably a name, and I get exactly same output, hello Vinod. The practical uses of lambda expressions are in specific functions where they are actually going to take other functions. As an example, let's have a look at the function called sort of the list class. So I can say here help list.sort, and if I press enter, you'll see that it takes here a second argument called key, which is nothing but a function. It is not showing me additional details about this, but this is a function that we can supply. Similarly, the sorted global function also has key as the parameter. As you can see that there is a key here. Apart from the collection itself, you can supply a key which happens to be a function. There are few more functions which take functions as arguments. Here is one more. So there is a function called map, which is actually going to take a function as an argument and then a collection of values that it does map. Another example is filter. Again, you can see that there is a function or none as the argument to the filter, and then a collection of values that we can supply over here. And there's another function called reduce, which we will see in the next few videos. In this video, let's understand lambda expressions with the help of sorted and list.sort functions. For that, let's first create a list of few names. So I'm going to say here names equals to, in quotes, a string values. I give a bunch of them. Let's say Vinod, Anu, Kushi, Karishma, John. Let's say, for example, Jacob. Let's give one more. Let's give a bigger name this time. Say Harish Kumar. Close the bracket. If I use names.sort and then press enter, you'll see that the names themselves got rearranged and I lost the original values. So I don't want to use it this way. So I'm going to reassign the names. So it is in random order. Now I can use a sorted function and then say names, and it is going to return a new list consisting of the sorted names. So you can see that alphabetically it is ordered. So A, H, J and J, but JA comes before JO here, and then you have a K and K, so KA comes before KH, and then of course V is the last one in this case. So by default, the sorted function is taking each of the strings and then comparing one string with another string based on the ASCII values of the letters. It is actually sorting each one of them. What if I wanted to sort the data based on the length of each of the text? So in which case, the sorted function takes a second argument. So you can say here help on sorted to see more. You see that there is a named parameter called as a key here. Iterable is your collection. Key happens to be a custom function that can be supplied to customize the sort order. So by default, it is actually taking the what we call as lexicographical order. Now instead I can supply a function. Now we know that there is a function called len. For example, I can say len of Anu and it's going to give me 3. Len of Harish Kumar, for example, will give you 11. So I can ask sorted to take the result of this length and then compare and then find out which one happens to be a smaller name between these two, instead of arranging them based on the alphabetical order. So to do this, I can say sorted and then I can say iterable equals to names, or simply give names because that will be the first argument. Then to say that the key is our len function, I have to say key equals to len. Now notice that I'm not calling the len function, I'm just supplying the name. Now this is where len is considered as just another object, like names is an object of list, len is an object of function type. So I'm supplying two objects over here to this function. Now sorted will ignore the lexicographical order, but instead it will order them based on the length. And now we'll see that I got 3 letters, 4 letters, 5 letters, again 5, and then Kushi and Karishma and Harish Kumar. So if you wanted in the reverse order, you can also add one more parameter, reverse equals to true. You can see that the same list is sorted in the reverse order. While len is a built-in function, we can also supply our own functions here. For example, imagine I want to sort the names based on the second character onwards, like INOD, NU, HU, SHI, and so on and so forth. How can I do that? So what I can do is I can create a function, a custom function, which returns the second character onwards of this particular string, so that I can pass that function and then the sorted can do its job. For that, I'm going to write a function called, say, partial text. I can supply a name here, and from this particular name, I'm supposed to return the second character onwards. Now the slice operator comes very handy here, so I can simply say name and then say index 1 onwards, everything else I want to supply. So for example, now I say partial text of Vinod, and it should simply say INOD. Similarly, I supply any other name, say John, So it's going to give you OHN. So now I can use this function called partial text, which is a totally user-defined function, to the sorted function. I can say here sorted of names, and then I can say key equals to partial text. So this, if I press enter now, you can see that it sorts. Now, at first, it might be confusing as what is the order, but if you carefully observe, ACOB is compared with ARI, etc. So AC comes before AR, and you can see that between this ARIS, we have exact same match ARI, but you can see that ARISHM. So the M is the differential factor between this, and here is the K. So K comes before M, so that is sorted out. Obviously, A comes before H, H comes before I comes before N, and N comes before O. So everything is sorted based on the second character onwards. Now the whole purpose of this function is only for the sorted. So I don't need this to be created like a global function anymore, because I can supply a lambda expressions instead of the actual function. Because for lambda expressions, what we require here is a name of the function, an argument of the function, and a single return statement in the function, so which is a perfect qualifier for a lambda expression. So what I can do is I can simply use here sorted names and then key equals to, instead of partial text, I can simply type here lambda, and then the argument, which is any variable here, I can say n, and its return value is nothing but n of 1 colon, just like this one. So we had here name as a parameter, here n is the parameter, name of 1 colon is the return value, and we have here n of 1 colon as the return value of the lambda, and I should see exactly same result as the previous one. Let's take another example. So here is our names, and if I want to sort the names based on the last letters like D, U, I, A, N, B, and R, all of them are different. So I can say here sorted of names, and then key equals to lambda of name, where the return value from this lambda expression is name of -1. If you remember, name of 0 would have given the first letter, name of 1, etc. Similarly, name of -1 will give the last letter. That's what actually I'm using here. I press enter, and you can see this time it is sorted based on the last letter. So A comes before B, D comes before I, N comes before R, and R comes before U here. So that's how lambda expressions can be passed whenever you're calling a function. So literally, I'm creating a function on the fly here and then passing it as an argument. The same thing can also be used on the sort. So if I say here names, this is the names, and I can say names.sort key equals to whatever the key you want. Let's say the previous one I gave lambda of n, where n second letter onwards. I can supply like this, and then I see that there is no result, but names themselves have been modified in this case. In this video, let's have a look at 3 more functions: filter, map, and reduce. All these functions take additional function as a parameter, and we can supply lambda expressions instead of actual functions. And for this demonstration, let's declare a nums as a list here of some numbers. I'm going to supply some random few numbers, say 1, 2, 3, 4, 56, 78, 31, 58, 33, and 48 or 483. Now let's say I want a list of only even numbers from this particular list, or odd numbers. Earlier, we learned how to do the same thing using a list comprehension. And now we will see how to use the built-in filter object to do the same thing. So you can simply use filter and then supply a function, and then the iterable is the nums. The filter function needs a logic as whether to include this number in the result or not, and the logic is something that we have to supply. So the filter function will call my lambda expressions by supplying an element, And I just have to say, hey, do you include this or don't you include this? We have to return a true or false. So let's say I give here lambda of n, where n is one of the element of these nums, and then return true or false based on some logic. If I simply say true here, then all of them will be included. Now the return value from the filter here is a filter object. In fact, filter is a class and this is a constructor. So we just constructed this, but we can pass this to a list and then check it out. So I type here list and list constructor passing this entire expression. You'll see now that all the values have been included, but had I given here false, then none of the values would be included. So we have to give a condition here that is dynamically generated based on the value n. Now since we wanted a list of even numbers, it's pretty straightforward. I just have to say if n modulus 2 is it equals to 0, that means it is an even number, then this will be collected in the result. If it is odd number, this will be omitted. And now you see you have a list of only even numbers. So literally, we supplied a function that tells the filter whether to include this individual element in the result or not. Of course, the same thing we could have done using a list comprehension like even nums equals to a square bracket to say that we need a new list, and then I'll say n for n in nums if n percentage 2 equals to 0, and we would have got the same result as the previous ones. Of course, the choice is up to you. Do you want to use a list comprehension or do you want to use the filter function, which is a built-in class? And it's purely a question of convenience. You should decide which one is right for you. Let's take another example, which is called map. Given a iterable like this, can convert each of these elements into something else. For example, if I want the square of each of these numbers, we could have done using something like n into n, that's n squared, for n in nums, and then if I press enter, you can see that I got the square of each of those numbers. And this is using a list comprehension. But there is a built-in class called as map. So if you say here help map, you see that it's a class called map. So you are able to call that using a constructor. It returns a map object. And then you can take that map object and pass it to a list constructor, and you should be able to get the list of those things. What is important here is that it takes an iterable as a second parameter. That's our list nums. And then a function that decides what to do with each of the elements of this iterable. So let's take an example of this. So we have nums here, and then I want the square of each one of them. So I can simply add here list of, so we are creating a new list object based on a map's return value. So I'll say map, and the function here is lambda of n. I'll say n into n. So you give me n, I will give you n squared. That's what actually this lambda says. And then I can supply here nums to get the square of each of these numbers. Again, the question is, do you want to use map function or do you want to use list comprehension? Totally up to you. Similarly, I have here names and I want the uppercase version of each of these names. I can simply use here list of map, and given a name here, I will return n dot upper, which is a function. And then I'll say here the names is the collection that I want to supply. And you can see I got the uppercase version of all the names here. Now one more function that we want to use here is called as a reduce. But if you type here help on reduce, you'll see that it says reduce is not defined. This is there in Python 2 directly as a global object. So in Python 2, you could go and straight away use this reduce. However, here we have to import this reduce from a module called functools. So I can say here from functools import reduce. And now if I type here help on reduce, we get the help. Again, you can see that reduce is a function. It's a built-in function. Move to a different module this time. And it takes another function as an argument and then a sequence of values. And then you can supply some optional initial values. What actually this does is it is going to take a collection of values like a bunch of numbers and then applies this function's logic and then eventually gives me one single value of all of them. This can be used to, for example, find out the min value in a collection or a max value of a collection, sum of the values in the collection, and so on and so forth. Of course, we already have a built-in function called sum and len. We don't need to use any additional function for this. However, if I want to find out the smallest or the largest, etc., so we can actually use this reduce function. So how do we do this? So we say here reduce and supply a logic. The logic is given in the form of lambda. Lambda takes here two parameters, a and b. I'll explain that in a minute. What are these two? But we have to return what is the summarized value in this case. Now I want to return a or b depending on which is small, and I can simply say return a if a is smaller than b, else b. So this is my logic. I am actually returning the smallest of a, b. So if a is smaller than b, then a is the return value. Otherwise, b is smaller than or equals to a, that will be the return value here. What actually happens is the second parameter is nums, which is the actual collection. So the reduce function will call this lambda by supplying these two numbers at first. Obviously, 1 and 2 are received over here. And then we are returning which is small among that, which is 1. Next time, 1 and 3 will be supplied as a and b. And then 1 and 4, 1 and 56, etc. As you can see that 1 is the smallest in this case. So we're going to get 1 as the return value. Similarly, if I go and change the condition to a greater than b, basically between these two numbers we are returning the largest of the two. The same logic is applied. So it's going to take here 1 and 2. So 2 is the largest, 2 and 3, 3 is the largest, 3 and 4, so 4 and 56, and so on and so forth, and 483 is the largest, and we see that the 483 is the one that is written from the reduce function. Let's take the example on names. So names is a collection of names like this. Now obviously here you can see the largest of that over here and the smallest name is here. I can use the same logic to get the smallest or the largest. So in this case I'm going to say reduce of, I need to supply a lambda, and I receive n1 and n2, where n1 would be Jacob and Harish Kumar will be n2. So those are the first two parameters I always get. And then I'm going to return n1 or n2 depending on whose length is smaller or bigger. So let's say I give here n1 should be the return value if len of n1 is less than len of n2, else n2 is the one that I'm going to return. Same as the previous one, but this time using the len function. So I will get two names. I'm returning the first name or the second name depending on whichever is smaller. And the names themselves is the second parameter for the reduce. So the first parameter is a function, second parameter is the iterable. And now if I press enter, you can see you'll get it as Anu. If I say greater here instead of smaller, then obviously between the two names as an input, the lengthiest name will be returned. And you can see that between Jacob and Harish Kumar is the one that is returned. Between Harish Kumar and Karishma, again Harish Kumar. Between Harish Kumar and Kushi, Harish Kumar Vinod, Harish Kumar Anu, Harish Kumar John. Now all of them, so this will be the largest value, and automatically that will be considered as the return value from the reduce. So this is how we can use lambda expressions instead of writing an actual function and keeping it in the global scope forever. We can supply lambda expressions to map, reduce, and filter functions. A lot of times in Python, you may come across with errors that happen at the runtime, and these are called exceptions. Now, there are two types of exceptions that you will come across. One is called a syntax error, and there are a bunch of other errors such as value error, name error, index error. Some of them we have already seen, but in this video, we're going to see them in detail. So for that, let's take an example. I am going to create a new file called ex16.py, where I want to accept a number from the user and then print the square of the same. So I'll type here num equals to int of, then I'll type input, enter a number, and then I type here sqr equals to num times num, and then I will print out the result. So I'll say print square of this is another curly bracket, and then I'll type here dot format num and then sqr. So let's go to the command prompt. I go to the command prompt where I am already in my work folder, and then I just type here Python3 ex16.py. I press enter, enter a number. I'll type here say 23, and I get the result of 23, which is 529. Notice when I executed, number of lines here are 3, and all of them got executed without any problem. But let's assume that I just missed one bracket at line number 3. When I execute this script, technically speaking, this is the first output that I should see on the screen that says input, enter a number. And then it should convert that into integer, assign that to num. And then it's going to calculate the num times num and then store it in square. And then when I'm actually generating this format, so there is no error within this block. As you can see that the format function is called, num and sqr is supplied, and then there is a resultant string, and that resultant string is being printed using the print where there is a closing bracket missing. So technically speaking, the print function should give an error at that point in time. That's the last line being interpreted. Let's go and give it a try here. When I try this, you can see that even before it could execute the very first statement, I got an error called syntax error, unexpected EOF while parsing, and it is as much as possible it is telling me that it's line number 4, and you can also see that there is a caret symbol, an up arrow symbol here that says that somewhere there is an error here. What it did is, even before the interpretation can begin, it has parsed the entire file, and during the parse time it figured out that there is a problem here. So you get a syntax error even before the actual script can be run. Only when there is no syntax error, then the script begins the execution. Now let's make one more mistake by typing here another curly bracket, maybe accidental or intentional. In this case it is intentional, just to show you that we are going to have an error in the format function because we have 3 format specifiers here, but we have only supplied 2 of them. Let's see what is the outcome of this. When I execute this, let me clear the screen and then run the program again. It says enter a number, I'll type 34, and when I press enter, you can see now only during the execution of the code, when it is encountering this function format, and that is where it is giving an error, index error, tuple index out of range. So we are supplying here a tuple. All the parameters of a function is considered as tuple, and that tuple doesn't match this because here we have 3 index requirements, whereas there are only 2 indexes available over here. So it's giving an error at the runtime, and this time it's called index error. So there is a syntax error, there's an index error. Similarly, if I type here some ASDF kind of stuff and press enter, you'll see that the int constructor is giving me an error called value error. So as you see, the index error, value error, syntax error, all these are actual classes. So if I go here and into Python shell and then type here type of index error, you'll see that it says it's a type, means it's a data type. In other words, it's a class. So if I type here help on index error, you will see that it says it's a class index error. So these are all some of the built-in error classes that are available in Python. You can see that there is also index error, lookup error, there's an exception, there's a base exception. So there's a hierarchy of all these classes that exist. Let's see some of the prominent exception classes that are available in Python. So here is a bunch of exception classes. As you can see, all of them are grouped under some other classes. Here is the base exception. We call this as the root of all exceptions. And there are subtypes here like system exit, keyboard interrupt, generator exit, exception. Now exception is the one that we are interested in. And under the exception, you can see that there is something called lookup error, and under the lookup error, you see an index error. In object-oriented programming, we say index error is a subclass of lookup error. Lookup error is a subclass of exception. Exception is a subclass of base exception. Similarly, you can see that there is an arithmetic error which contains a zero division error. So we will see that in the next video. There are EOF errors. Sometimes you got the syntax error. So the syntax error is also part of this. As you can see here, there's a syntax error. In case if you are using a wrong indentation when you're writing the if conditions of for loop, so you're going to get an indentation error, but they're all syntax errors over here. And lots of errors as you can see, but we are more interested in some of the built-in errors like name error, value error, or index error, and few other types. Whenever a function or a constructor gives error, we call it as raising of exceptions. So whenever an exception is raised, if there is no handler for that exception, then the interpreter typically breaks the execution of the program and then gives you the error details. But programmatically, we can also handle those exceptions and then take alternative steps. In the next video, we're going to see how to handle exceptions in Python. To learn how to handle exceptions, we will delete all these lines of code and write a more appropriate example. Let's write a function called test, which takes an iterable like nums as a list of values, and I expect two numbers in this. I'm going to assign the nums of 0 to n. So I'll say n equals to nums of 0, and then I'll say d equals to nums of 1, like numerator and denominator, and I'm supposed to calculate the quotient of n divided by d, and I wanted an integer division this time, so I'm going to say here n divided by d, and I want to print percentage d divided by percentage d equals to %d, where the values are nothing but n, d, and q. Let's write a function called main to call the above function, where I have to supply a list of two numbers at least. So it may contain more numbers, but I'm interested in two numbers. And then I'll say here something like data equals to, let's say, 123 and say 34, and then I'll supply here test of data. So data being a list, the list is received over here. The list has the first number as 123, second number as 34. So now you got the 123, 34 in n and d. So and we are doing an integer division. We get the quotient and we are trying to print the quotient. One last thing is to call the main. If this is the main module, we say if dunder name equals to dunder main, then call the main function. So I go back to the command prompt and I'll type here Python3 ex16.py. I press enter and you'll see that it says 123 divided by 34. The quotient is 3. Now let's go and make some mistakes. What I do is I'm going to supply here only one number instead of two numbers. So nums of 0 is 123, that's assigned to n, and at the time when the line number 3 is being executed, we don't have index 1. The operator square bracket here, where I'm trying to access the value at a given index, this fails and it raises an exception called index error. Since we did not handle that here, the function raises that exception. So we are now calling the function over here, and this is now going to be raising the exception. Because we did not handle the exception here, the statements after this, if at all it was there, for example, I'll say print, say end of main, this statement will be skipped because there is an exception or an unhandled exception that will be raised from here main, and the main is called over here, and the main is also not being called from an exception standpoint. So because there is no exception handler over here, now this entire script is going to raise an exception. Unhandled exceptions are handled by the Python interpreter itself, and Python interpreter simply gives you what's called as a stack trace, and the stack trace will give you from where the actual origin of exception took place. That happened over here, and that was propagated to the main function, that was propagated to this if block, and that was propagated to the interpreter. So all this will be given in the stack trace. So let's go and try the same thing now. So I press enter after typing Python3 ex16.py, and you'll see it says trace back, most recent call last, and it says here file ex16.py line number 13 because it's going like this. So in line number 13, we called a function that threw an exception. And if you see the next line, it says that it is the test function, so not the main function. So in the main function, there is a call here that caused a problem. And again, in the test function, there's a line here that caused the problem. So if you see here, it says again in the test, so this is the main function, this is the test. In test, we are trying to say d equals to nums of 1, and that is the reason why you're getting an error. So you see that index error, list index out of range. Now we know that there is an index error. Can we handle that? So this is a place where some user defined, somebody has defined this function and I'm trying to call, but I don't want this to break the execution of the program. I want this program to give me this line all the times. Let's give it a second try. So I'm going to go supply here a value which is say Vinod. So the first here is nums 123, no problem. And then I have here a string that is not a problem now because we do have an index, index 1 in our nums, which is nothing but this data. But that is a string Vinod. And then when I'm trying to execute this set, the division operator, an integer division with a string is not allowed. So I'm going to get another error. So if I select the same line and then execute, you see that we got this time something called type error, unsupported operand type or types for / int and str. So there's an int, there's an str. This operation is not supported. Let's try one more. I give 0 here instead of string. So obviously the division has no problem in terms of the data types, but in Python and like in many other languages, division by 0 is not allowed. So once again, if I run this code now, you will see that we got a 0 division error, integer division or modulo by 0. So it's not a modulo, it's a division. So this is the one, integer division is the reason why we got a 0 division error. Again, you can see that my line 13 where I'm calling the main is the reason why it failed, but main function itself did not cause a problem. It called a function called test that caused a problem. The test itself did not cause a problem. So inside the test function, q is equal to n/d. That is the reason why you got an error. So how do we handle this now? So we know that at none of these scenarios end of main came. End of main will be printed only if there is no exceptions from this particular function. For example, if I go and run this now, you will see that there is no error and I got end of main. So we want to see end of main all the times, even if there is an error, just to ensure that the program doesn't break by itself. The way you can handle the exception is you use what's called as a try block, and then of course this has to be indented. Now we have a try block which says try this code, and whenever there is an exception, so we say except, and then we say here there is an error. So I'm going to just type here a print message saying that oops, there's an error, and we also would like to know what is the error. So we do have now a block. The block tries to execute this code. If there is no problem, then it skips this except block and then prints the end of the main. But if there is an error, it gets into this except block, prints this message, and then continue the program as if nothing happened. So let's go give it a try. Now this is a valid input. So if I'm going to run this, I'll still see the end of main, no problem. But if I say here 0 instead of a valid integer, so if I give here now, you can see that it says, oops, there is an error. More importantly, we saw that end of main is printed. So I'm going to go type here some wrong values like Vinod. And now if I execute this, you'll see that, oops, there is an error. And then I can type here nothing at all. There's no second parameter, or I can even get rid of this first parameter. So nums of 0 itself is an error. So if I run this now, you'll see that oops, there is an error, but more importantly, in all circumstances, we got the end of main. So if you know what is the reason why this is breaking, like what kind of exception was that? For example, if you're not supplying any values, you got an index error. So you can say here except index error, and then you can say here invalid or something like I can say not enough values. So I can also write another except block for example, value error, and then say that, hey, if there's a error because of a value error, which happened like when I supplied Vinod as the second parameter. So I can say here print only numbers are allowed. And in case if it was a zero division error, I can say except zero division error. And then I can say print cannot divide by 0. And now, of course, if I run the code in different cases, for example, I didn't supply a value, I should get not enough values as the error. So let's go give it a try. I can execute the code and it says not enough values. I'll supply here, say 100, 0. So 0, because of the 0 division, that error raised is not an index error. So this except block is skipped. It's not a value error because it did not have any problem with the value here. So this is skipped, but 0 division error is the reason why it is failing. So it should say cannot divide by 0. So that's the error message I'm getting. So you can also try here with, say, some ASDF. This is supposed to be a value error. I guess it's not a value error, it is a type error. So let's go and give it a type error. So we give type error, and now of course if I run the code, you should see that it says only numbers are allowed. So end of main is reached, all the cases. Whenever there's an error being raised, we are able to handle that based on what kind of error is that. Opening, reading and closing files in Python is very simple. To understand the same, let's get into a Python shell, and I type here help on open, which is a function provided by Python. So it says it's a built-in function in module IO. So this is for input output. Open is a function. The first argument and the mandatory argument is the name of the file. And then you have a bunch of parameters which have default values, which means they're all optional. So there's a mode, which means you want to open the file in either a read mode, write mode, or append mode. It says there's a buffering, there's encoding. In case if you're reading some internationalized text, you can supply an encoding. How do you handle errors? Is there a new line characters that you want to specify? And some other optional parameters. So in order to open a file, you have to supply the file name as an argument. Now you can give either a relative path or absolute path. Now I have already switched to the directory where I have my Python examples, all the scripts that I have written. I can simply say file name equals to, say for example, ex16.py, that's the last one that I wrote. And now I can open this file name by typing f equals to open file name. Now the function open takes this file name as an argument. If it is successfully able to open the file, it returns an object. We call it as a file descriptor object. The file descriptor object is returned, and I'm using a variable f to represent the same. Now I can perform some operations on that f. So to understand what is there, let's first type f. You can see that it says it is something called text IO wrapper. That's the class of which you got an object. And if you want to know what are the members of that, you can simply type either dirf or you can say help f. So when I say dirf, you will see that I get lots and lots of functions. Now here are some of the functions that you can check. For example, closed is a Boolean attribute that says is it closed or not. Right now the file hasn't been closed, so if I say f.closed, it says false because it's not closed. You can see more importantly there are functions here called read, readable, readline and readlines. So read reads the entire content of the file. So if I type here f.read and assign this to a variable, for example, I assign this to say data. If you press enter, and now you see data contains all the lines of that particular text file. Of course, it is not showing me properly because it's being displayed here as a string. But if I type here print data, you can see that the entire file content is there in that particular variable data. So I can close it by typing f.close. And now if I say f closed, it says it is true because it's not open anymore. Of course, if it is not open, you will not be able to read again. So you have to reopen the file. Now this time I want to give the file name completely from the root of my folder, that is called absolute path. I'll type here file name equals to slash users slash Vinod Kumar slash desktop slash Python examples, and inside that I have ex16.py, and that's the file name. I can again say f equals to open file name. I can also say that mode equals to read, which is default here, so I don't have to give it, but I can always mention that. The file is ready. I can now start reading one by one. But before that, let's have a look at what are the other functions we have. You can see that there is a function here called seek. The seek function takes the cursor to a particular position. For example, before doing the read, I can always say f.seek 100. Now what happens is that when the file is open for reading, there will be an internal cursor that actually points to the very first character. Now I'm moving that to the 100. So that means if I do an f.read, you will see that the first 100 bytes or characters have been skipped and the rest of the content will be printed. So if I type here now print f.read, it's going to read the content and going to print, but only from def main. You can see that the previous output included everything. It included def test, but up to 100 characters have been skipped. So these include probably 100 characters, and then it is including the def main onwards here. So that's how it is the seek. Now you can always say f.seek to 0 and you can start reading again. I can say here print f.read and I should be able to see the full content again. So instead of reading the entire data at one shot, you can read one line at a time. So for that, I'm going to say f.seek of 0. So making sure that I'm bringing the cursor back to the beginning. And then I'll say here f.read line, a singular here, and I press enter. You can see that it prints the very first line of the file, and it also includes the new line character that is part of the line. And I call this again, you'll see that there's a second line, third line, fourth line, fifth line. So I can actually use a loop to print the same thing. For example, I'll clear this here, f.seek of 0. So I'm bringing the cursor back to the beginning. I'll assign line equals to f.readline one time, and then I can say here while line not equals to an empty string, you keep repeating the same thing. So first I'll do a print line, and then I'll say here line equals to f.readline, and then I press enter, and you can see that I'm able to read all the lines one by one. Of course, it's also printing a line here. That's because the print function itself adds a new line character, and the actual line I'm printing also has a /n. If you didn't want that, you could have probably said end equals to empty string. So this is one way of reading. In the next video, we will write some Python scripts to read the data from the file as well as write the content to a file. In this video, let's go and understand a better way of opening, reading, and writing into files. So I'm going to create a new file here, ex17.py, where I'm going to write a function def main, and for the time being pass, I'll say if _name equals to _main. We're going to call the main function. The first thing that we want to do is to ask the user to enter a file where we can read the content of the file. So I'll say file name equals to input, enter a file name. The user enters the file, and then we can say here open and then the file name. So the file name is the variable file name. By default, it is the read mode, so I don't have to mention. And then I can assign this to a variable called f, and somewhere at the end I should say f.close, so the open file is closed. Now in between, I want to do reading of the content. And to read the content, we have three functions. We have a read, which reads the entire content of the file. The second is the read line, which reads one line at a time. And the third is read lines, where I read the entire file, but I get a list of lines in the file. So we're going to say here first, line equals to f.read line. I read one line at a time. And then I'm going to say here while line not equals to an empty string, we want to proceed further. The bracket here is optional. It's just to group multiple conditions if you have. I don't have multiple conditions. So I say while line is not an empty string, you can say here print line, and then I say end equals to an empty string, because the line itself contains the new line character which is part of the file. Once the printing is done, I'll have to say again line equals to f dot read line, and then we are going to read the second line here. If there is no second line, then of course this condition fails and then come out, and then I say close here. But otherwise I'm going to repeat the same thing again and again until I reach the end of the file. Let's go and try executing this file. So this is ex17.py. I'll say Python3 ex17.py. It's going to ask me the name of the file. Now since I'm in my current project folder or workspace, all the files I have here, I can just type the file name. I'm going to type here ex10.py. I press enter. It's going to read the content of ex10.py and then it's coming out. As you can see, the last line somewhere, I believe I should have given a new line character. It did not print, so there's some special character here. You can just come out here and then say here print, and then that should take care of the output. So I can also type the absolute path when I'm typing here. So let's clear the screen and try running the same thing again. And this time I'll type here /users /Vinod Kumar /desktop /Python examples /ex15.py. Now you can see when I press enter, it's giving me the complete content of the file without any extra new lines except the last line, because there's a new line I explicitly printed. So let's go and try another example where I can read using the read lines without having to use the loop. And to do that, I'm going to create a new file here. So I'll say ex18.py, and I would like to copy the content of 17 completely, paste here, but I will get rid of this part because I want to do it in a different way this time. So I still want to accept the file name from the user. I have to open the file, I have to close it, and the way I would be interested to read that is I can say lines equals to f.read lines plural. Previously we used a singular. This time the reading happens one time, but I get all the lines in a list here. So the data type of lines is a list. Since the data type of lines is a list, instead of using a while loop, I'm going to use a for loop. So I'll say here for line, a new variable in lines, and then I can say here print line. Now notice that again the line contains the new line characters. I don't want to print an additional new line character, so I'm using this end equals to an empty string so that the print itself doesn't add a new line character. At the end, when the file is being closed, I'm also giving a new line character over here. Let's go try this 18th one. I clear the screen. Once again, like the previous ones, I can give either the relative path or the absolute path. Let me give the ex18.py itself. So I'm trying to run the program, and the program reads itself and prints the same. So when I press enter, you can see we got it. But only thing is that the reading happened only one time, not inside the loop. We still have to open the file and then close the file. So importantly, closing of the file is of some concern at some point in time. Let's see another or an improvised version of the same. So I'm going to do one more thing this time. So I'm going to copy this file and then paste it. It comes as ex18 copy. I'm going to change it to ex19 and remove all these lines once again. I have a function that reads the file name from the user, opens the file, closes the same thing. But instead of doing like previously, I can simply supply here for line in, and then I can say f, where f itself is the file object. As you can see, file object is not an iterable, but in this context, it looks like we are looping over that f. So the internal mechanism is where when you say line in f, there'll be something called generators where it's going to give you one line at a time as you proceed further. So we're going to just print here, print line, and then end equals to an empty string. exactly the same thing. So without having to call the read line or read lines, I'm able to access the content as if f itself is an iterable. So let's go and try this. I type here ex19.py and I'll type here ex19 itself so that we can see the content once again. And you see it is able to read the file one line at a time from the file object itself. Let's go and see one last way of reading the file, and the better method to read the file is where the opened file should get automatically closed. So for this, Python provides a block called as a with block. So the with block automatically closes whatever is opened inside the with block. So to do that, let's go and save this file. So this time I'm going to go and say file save as, and then I'll type ex20 and enter. Now there is a new file, exact same content, ex20, but I'm going to remove these things completely. I have accepted the file name from the user. I haven't opened the file, I haven't read the file at all. So this is where we say with and then type here open file name as some variable called f, or I can name it as file. So what it does is it's going to execute this function, and the return value of this function will be assigned into this variable called file. Now that file is the return value of the open. This is same as f in our previous examples. I can simply type here for line in file, and then I can print the line without new line character. So now you can see when I exit the with block, the file gets automatically closed. So this is called auto closing. So let's go and give it a try. Note that the variable file has no scope outside that. So if I come here and then say, hey, is file closed? It says file is not defined because file would have been defined only inside this particular with block. So many occasions developer forget to use the file.close, or sometimes intentionally they wouldn't have given not knowing where to close. So this would be a better choice because the file gets closed once it is out of the scope. So let's go and try this once more. So I'm going to clear the screen and I'll say Python3 ex20.py, and you'll see that it's asking me the name. I'll type the same name once again, reading the same content, and you'll see I'm able to read the file without any problem. Now let's take examples to create new files. Let me close all these files and create a new file called ex21.py, and where I want to accept a bunch of names from the user and then write the content into the file. So I'll type here def main. I'll ask the file name from the user. What is the file name that the user wants to create? So I'll say here input, enter the file name. So I'm going to use a while true, which happens to be an endless loop. And then I say here name equals to input, enter a name, or I can say quit to stop. So if the user doesn't want to continue, so he or she can say quit. And whatever that is entered, if name equals to quit, then I want to break the loop here by typing the break statement. I can exit the loop because otherwise it is an endless loop. Now if name is not equal to quit, I want to write this name into the file, and this is where I should have opened the file here, and like the previous case I can still say here with open of file name as file. And now I should indent this with one more tab because now it's all inside this with block. So we have the file object here, and the file object provides a function called write, and then I simply say name. Of course, write doesn't add a new line character, so I might want to add either a new line character or I can call it as write line. Now to see if this function exists or not, you can go to the Python shell by typing Python3, something like f equals to open a file name. Let's say, for example, ex01.py. It doesn't matter whether the file exists or not. I type here dirf, and you can see that there is a function called write, and there's a write through and write lines. Lines is in plural. So we don't have a function called write line, a singular. We have a function called write. So let's go and use here write instead of write line. And because there's no new line character, you'll have to type here write and a new line character like this. So one name is written and a new line character is added to that. So this continues as long as the user doesn't type quit, But if the user types quit, then the loop is broken. You're outside the loop. You will be outside the with block and the file gets automatically closed. So we'll give a feedback message to a user saying that the file is now created. Now the file name is of course entered by the user, so we can even print what is the name of the file, but that's okay. And I'm going to type here now, if dunder name equals to dunder main, we'll say here call the main function. So I'm going to go back to the command prompt, exit the Python shell. So I'll type here Python3 ex21.py. It says enter file name. I'll type here names.txt. So we got an error. It says that the file not found error, no such file or directory. Now I believe the problem here is when I say open file name, I did not mention the mode, and by default the mode is the read mode. So I'll have to say here now mode equals to W to say that hey, we are opening in the write mode. Otherwise it will assume that you want to open the file for the read, and for reading the file should exist. For the write, if the file doesn't exist, it gets created at this point in time. So let me go back to the command prompt, run the command again, and this time I'll say names.txt. The file doesn't exist, but it gets created this time, and it says enter a name. So I'm going to type here name Vinod, Anu, Khushi, Karishma, and say quit. When I say quit, it says the file is created. Now if I go and check what is the file name, you can see that there is one file called names.txt. If I go back to the VS Code, and if you see that there is a names.txt, click on that, you'll see that all the names exist along with the new line character. The new line character is because after writing the name, I'm actually passing a new line character over here. So this is how the file gets created. But if I go back and then run the script again, let's try that once again. I'm going to supply the same names.txt again, and I type here John and Jane, and then I say quit. Now you see the file is created. If I go back over here, to our surprise, you'll see that the previous names have been deleted and the new names have been appended over here. So the reason for that is the write mode also erases everything whatever exists. If you don't want, you can always supply here mode as A to say that I want to append instead of overwrite. So if you see currently names.txt contains John and Jane. So let's run this once again, and I'm going to type here names.txt, which is an existing file. But since we use the mode as A, it is not supposed to be overwritten but to be appended. So I'm going to type here Vinod. I'll say Anu, Khushi, and Karishma. Press enter and then I type quit. So if I go back here and then check names.txt, along with the previous two names, the new names have been appended. So by default, the mode for file opening is read, but if you want, you can use mode equals to W for writing or overwriting, and mode equals to A for appending. Here is a file that we have called people.csv, which is a comma separated values. And you can see that the first line here is a header, which contains ID, name, email, phone, city. And the second line onwards contain a bunch of comma separated values which correspond to the respective headers. If you are on Microsoft Windows, if you double click this people.csv, you should open the same thing in Excel. On Mac, I have this LibreOffice, which is a similar tool for working with these kind of comma separated values. Let's put all the thing that we have learned together and try to convert this CSV file into a JSON file. To do the same thing, let's create a new file here called myutils.py. I'm going to write more functions as we go forward, and we're going to use this myutils.py in other projects as well. The first thing that you might want to do here is to write a code comment or document string. And that you can do by typing 3 single quotes or 3 double quotes and then end the same thing like this. And then you can mention here what is the purpose of this particular file, which is considered as a document string. So if at all you import this myutils into some Python shell and then say help on myutils, you should see this one. So let's go and try the same thing. We're going to say here my utils. This is basically the file name. And you can say a set of utility custom functions that can be used by other functions. You can also type here created by, and you can give your name and probably email so that this acts as a documentation. So just to show you how this is going to work, so if I go back over to my command prompt, make sure that you're in the working directory, which is the correct one right now for me, and I'll say Python3. Now I can say here import my utils, and I believe the file naming convention is wrong. Let's go and rename this as my utils without the hyphen. So I'm going to go back and press enter here. On Windows you may say F2. And then I'm going to remove that hyphen, making it as my utils. Here also I'll remove that. And come back here, and now I can say import my utils. What it does is it's going to look in the current folder where you have launched the Python 3. And then if that exists, it's loaded. Now if I type here help on my utils and press enter, you will see that we got name my utils. I believe this is coming because of the very first line. Then there is a bunch of description, which is the second line onwards. All these are considered as description. What is the actual file? So we have the file in this location currently. And if in case there are multiple members of this, it would have listed. So right now I don't have anything here. So when we write more functions, we'll come and have a look at this once again. So I'm going to exit from here and come back to the code. So since this is not required because it's automatically taking this, let's get rid of this. We just give a description. Let's write a function here called CSV to JSON, which takes a file name as an argument, reads the file, converts the content into a JSON content and stores with the similar name. So I'm going to go right here def CSV to JSON, and it takes file name as a parameter. Now what if the parameter is missing? Then I may want to inform the user that file name is mandatory. So I can check here if file name equals to, you can say, is it none? Or if the user has supplied something other than a string. So I can say here type of file name not equals to str. Then I can cause an error by using the keyword called raise, and then an error object. So you may have to create an error object like exception, and then say here file name must be a string. So that's the error that I want to give. So the raise keyword is equivalent of causing a problem. That means that because there is no try except block here, this function will be raising an exception to the caller of this particular function, which could be a main function in our case. And eventually your application is going to be broken. Let's come back. So if the file name is proper, then we want to open the file for reading. So I can say here with open file name. By default, the mode is read as f, which is the file. Now I have the file. I want to read the very first line and then keep it as a header. So I can say here header equals to f dot read line. Now this read line reads everything in the first line, including the new line character. And you can simply call the strip function here to remove the leading and trailing spaces. And that actually is now my header. But you can also convert this entire string into a list by simply passing the split function and then say that the comma is the delimiter. So at this time, if I want to know what is there in the header, so I can simply print header just to know what is there in that. Let's write a function called def main where I'm going to supply a file name. So I'll say CSV to JSON, and the file name here happens to be people.csv. This has to be called somewhere. So I'm going to say if dunder name equals to dunder main, then we're going to call the main method. So let's go to the command prompt and see if things are in place. I'm going to go run this file. So Python3 myutils.py. You can see that there is an error. It says that the file name must be a str. So let's see what happened here. So when we are comparing, we are not supposed to compare it like this. We have to compare this with a data type just like none here without the quotes. So I have to simply type here str. So let's go here and then clear the screen, run this program again. And now you can see we got the header as a list here. So ID, name, email, phone, city, etc. Now that we know that the header contains the first line in the list format, I have the header, I need the values now. So I can take one line from the file again, and for that I can use a for loop. I can say for line in f. If you remember, the file object itself is an iterable. You can take one line at a time from there, which is line. Now I need to convert each of these lines, one line at a time, into another list, which is again a very similar concept here. We read the line, we have the line here, we need to strip it, and then we need to take the comma separated values into a list. And that I'm going to call it as values equals to line dot strip dot split and a comma. So now this is basically values. And in the previous video, we have learned how to actually zip them together and convert that into a dict. So I can simply say here, data equals to dict of zip of header and values. Now we have the data, which is one single dictionary. Let's print that and see how it's going to go. So let's say print of data. Come back to the command prompt, run the code again. You will see that I'm now getting the dictionary for each one of them. Each of these dictionaries are inside the loop. So if I come out of this particular loop, the dictionary is gone. So to preserve the same, so let's go and create here an array of data. So I'm going to call it as ARR data equals to an empty list. And then I'm going to simply append this data to this particular ARR data. So I'm going to come out here and say ARR data dot append of data, or I could say plus equals to, and then in square bracket I can give the data. So if I come out of the loop and then print ARR of data, you'll see that it's the same thing but in a list format now. One last thing that I have to do here is to convert this entire list into a JSON, which can be done by using the module JSON. So the first thing that I have to do is to say here import JSON, and then come down. Instead of printing that right here, I can simply say here print json.dumps and then supply the ARR data. I can also supply indent equals to, for example, 3, so that it nicely formats the output. So I'm going to go and run this once more. Let's clear the screen first. And you'll see that we have a perfect JSON data output consisting of all the key value pairs from the CSV file. Let's say if you want to save this content into a file, and let's also supply the second parameter, which is the output file name. Let's say people.json. And let's also receive that as probably a out file name, two variables. File name is the input file, out file name is the output file. We can also check if the output file name must be a string by making a copy of the same thing. I'll leave that as it is right now. In order for me to write this now, I have to simply say here, remove this print and the corresponding bracket. I have to remove this s to make this as dump, but the second argument is a file object. So again, I can say here something like with open of out file name as, let's say, for example, out. And then I'll say json.dump ARR underscore data. Out is the second parameter, which is the file pointer. Indent equals to 3 will be optional because in the file you really don't want the indentation. So I can as well get rid of that. But for now, I'm going to keep it as it is. Now if I run the code, it's actually going to start the main function. Main function is going to call this by supplying two file names. This file name is opened for read, whereas this file should be opened for the output mode or the write mode. So I'll say mode equals to W. So the file name is checked, only the input file is checked. The output file will be created anyway, so there's no need to check that. We open the input file name. We converted the first line into a list of headers, and then we read each line one line at a time, convert them into a list of values, and then we use the zip to convert them into a group of tuples, pass it to a dict constructor, we get a dictionary. we append them to the list that we created over here, which is an empty list. So by the end of this for loop, we would have gone through all the lines of CSV file and then converted them into a list of dictionaries. Now that we have the list of dictionaries, we open the file in the write mode here, and then we write this or dump this in the JSON format into this file with an optional indent of 3. Let's go and check if we have the people.csv and JSON. You can see that I only have people.csv and no JSON file. Let's run our code by typing Python3 myutils.py. It simply comes out to the command prompt without giving any output. But if I check the directory now for people star, you can see that I have a people.json. If I go back to VS Code and look at what is there in people.json, it consists of the exact same content here. Now, since we are using a for loop over here, we can as well use a list comprehension. For example, let's comment out these lines. Let's create a new variable, ARR underscore data equals to a new list. I'm going to make some space by pressing enter here. Now, since this is open and closed here, the indentation is not a problem. So it's considered as a single statement right now. Because a list comprehension depends on a loop, so I'm going to use this for line in F. So that's my actual loop variable called line, which is a single line, complete line with comma separated values and a new line character. And I have to use this function called strip and split together to convert that into a list. And then this is going to be my output value. So I'm going to copy this and paste over here. But I don't have anything called values, but values is nothing but line.strip.split. So I'm going to copy this, replace over here. Now, as you can see, I am not using a for loop here, but I'm using a list comprehension where this is the output value from each of the iteration, where each line is picked up from the file. Let's go and check it out in the command prompt by running the Python3 myutils.py. There is no error. If I go back to people.json, you will see that it still exists. Let's do a double check by deleting the file. So I'm going to say rm people.json and press enter. So now you see that there is no such file here. So there's only people.csv. If I go and run my code here, myutils.py, and if you check the directory, you will see that there is a people.json. And if I come back here, people.json contains the same data again. So this way you can convert a very complex for loop into a simple list comprehension. In Python, a class represents an abstraction. And what you do by creating a class is creating a data type. For example, I can say here class person and then simply say pass at this time, not having any code inside that. All we have done is creating a data type called person, using which you can create variables called as objects. For example, if I say type person, you'll see that you get the class type. This is just like another data type. So for example, if I say type int, you will see that it says it is also a data type. And what have we done using int? We create variables of int, str, etc. Now we can create variables of person. Now to create a variable of person, you may simply say p1 equals to person and then call its constructor, just like how you would have probably done with str or int. If I press enter now and then say type p1, you'll see that p1 is an object or an instance of person. What we see here as double underscore main double underscore is because it's the name of what's called as the module. Had I created a file called person.py, then I would have probably got it in a different way. Since we have created an object now, and I can also go and see dir of p1 to see what additional attributes there are there for p1, and you'll see that without even having to write anything in the person class, we already have got a lot of dunder methods, and all these dunder methods come from another class called object, which this person class supposedly inherit from. We can also write our own additional attributes or members of the class person. For example, I can go and say class person And in the block, I can write some variables. For example, I can say ID equals to something like 1, name equals to, let's say, Vinod, probably city equals to Bangalore. And I can write my own functions like, for example, def print details, for the time being pass again. Now when I come out of this, now you'll see that we have a class person. I may have to say either dir person, where I'll say all the attributes, city, ID, name, print details. They are just attributes. You can't make out whether that's a function or a variable. Or you can also say here p1 equals to a person, and you call the constructor, and then I can say dir of person. We should see a similar result as well. Although I created variables in this fashion, this is not the way you create variables that belong to an object. So typically, if the variables are declared over here, they are all shared across all objects of this particular class. These are equivalent of static variables of Java or C Sharp. Another point to mention here is that the function print details, what we have written, has no arguments. This function can only be called using the person class and not by person object. Just to clarify, let's go and check this out. If I say here person.print details, you'll see that there is no error. But if I say p1.print details, you get one error saying that it takes 0 positional arguments, but 1 was given. So it says that, hey, you passed an argument over here. So as if I passed an argument over here, but I haven't. But then why am I getting this error? We'll have a look into this in detail in the next video. In this video, let's go and have a look at what's called constructor. To do that, first let's go and check what we have in person class. So I'm going to go type here dir person. If you have a look at this, there are a lot of double underscore attributes or so-called dunder methods or dunder attributes. One of them you can see is called double underscore init and double underscore or dunder init. Now this is a very special function because this is the one that is actually executed whenever you create an object. To understand this clearly, let's redefine our person class in a little bit different way. I will say class person, press enter to get into the class. Let's add some indentation and then write a function here called double underscore init double underscore. And if you simply write a bracket without any variables like this, and let's put some print statement saying that person instantiated, and then come out of this class definition. If you type here p1 equals to person like this, you may run into a problem. It says that init takes 0 positional arguments, but 1 was given. What we did was by writing here a function called init, we're actually rewriting the init function which this person has by default. So this is the default function that person class has. We are rewriting. In the earlier examples, when I typed p1 equals to person, this is the one that was called. So, and the definition of that had 1 argument. So we don't have any arguments or parameters here, so 0 parameters. And it says here, you don't have any parameters, but you have supplied here 1. But the question is, where is that one object? We never passed a parameter, so we did not pass a parameter over here. So first, the person class is treated as a function and is being called. Only if that is successful, then something is assigned to p1. So let's not worry about p1 at this point in time. For example, if I simply type here person like this, still I get the same error because when I call a class like a function, Python allocates a memory required for an object, and then it takes the reference of the object and passes to the init function automatically. So the init is not called by me. I'm only treating a class as a function and I'm calling it. Python allocates a memory for a new object, gets the reference of the newly created object and passes to the init function implicitly. Hence, we are getting an error saying that, hey, there are 0 positional parameters. So we didn't define a positional parameter, but Python is trying to pass that. So it is not called by me, it is called by Python. So Python is passing that argument. So if you want to know what exactly is there in that, let's redefine this class a bit differently. I'll say class person, give a couple of space. I'll say def dunder init dunder. But in the argument, I'm going to just type here some variable. It doesn't matter what it is, but general practice is you write variable called self, so that we know that this is a reference to the newly created object or itself. And then I come here, print self is, and then I'll type here self. Self will be an object of person. We can also try printing the ID of that. So print ID of self is, and then I'll type here ID of self. Let's go and give it a try this time. So when I type here person, note that I'm trying to use the class name as a function and I'm calling it. When I do that, like I mentioned earlier, Python allocates a memory for an object, or rather it creates a new object, takes the reference of that object, passes as an argument over here, and then we are trying to print what is that argument all about. So you'll see that now it says self is an object of main.person at this particular address. So we're not really interested in the address, but it says so. And then it says ID of self is this particular reference number. And then of course the call itself returns the object. As you can see that whatever the object we had here self has been returned when we called the person class as a function. So which then can be assigned to, say for example, P1. So if I type here P1 equals to person, you'll see that we got these two lines, but since we are collecting the return value of this statement, it's going to be assigned to P1 and not being printed. But if you see what is P1, P1 is an object at the same address, whatever you see here, and ID of P1 is nothing but the ID what we received in the self here. So which means a self is automatically returned from this init, which is also been given back to you at the end of this particular function like call. When you define a constructor, you can also write your own additional parameters, but those parameters you have to supply from here. So which means when you pass parameters to person constructor call like this here, you're passing, let's say for example, 4 parameters. Those parameters are collected by Python. Python creates a new object. It has the reference and the 4 parameters you have supplied. So Python will supply 5 parameters to this. The first one being always the reference to the object itself. For example, let's clear the screen and try one more. I'm going to say here class person, and then I type here a couple of space for indentation, def double underscore init double underscore. I write a parameter typically named as self, so to avoid confusion. And then additional parameters, for example, I can say name equals to none, city equals to, for example, Bangalore. So I have declared here 3 variables. Self is always going to receive the reference of the newly created object. Name is having a default of none, that means user doesn't have to supply this name. And city also has a default of Bangalore, so city also doesn't have to be passed by the user. Let's print what is the value of each of those variables. So I'm going to type here print self equals to self. Again, another print statement to say name is nothing but name, whatever that user has supplied. And then one last is city is equals to city. Now if I say person, just like that, you will see that it is going to print these 3 plus the return value from the person, which is the reference of that object itself. So I did not supply anything, but I also can supply a parameter like, for example, Vinod. And now when I press enter, you can see the name that I supplied here, the first parameter is received into the second parameter. And in case if I supply 2 parameters, let's say for example, I type Bengaluru, and now I press enter, you can see that the second parameter is received into city, which is the third parameter. So whatever the number of parameters you supply here, now there has to be one additional parameter, because init is not called by me, but init is called by Python, and Python always supplies the reference of the newly constructed object as the first parameter. Now let's explore what is the purpose of using this init. General practice is the constructor or the init function in Python is used for initializing the member variables of an object. For example, if I have P1 and P2 as 2 objects of person, While P1 got created, we could have initialized some values that is part of P1, and when we created P2, we could pass some initialization or initial values of P2. To understand the same, let's take another example. Let's redefine the class person. We are going to write a function which is called init, and that takes self as a parameter. Let's create name equals to none and city equals to, let's say, none as two parameters. But in case if the user supplies those two parameters, we don't want to just print them, but instead we want to preserve them in the memory. And notice self here is a reference of the newly constructed object. So in the memory there is a space and this self refers to that. We can store these two variables inside that. And the way you do is simply type self dot and then give whatever the attribute you want. Now, for example, I can say name equals to name, meaning we are creating a new property or attribute inside this object called name, and we are assigning the parameter that is received over here to that. So the right hand side here is the local variable or the parameter. The left hand side is a new property called name in the variable called self. Now if you wanted, you could give different names. We will see them later. This is how you create new member variables in the person object. So I'm going to type here again self.city equals to city, and then I can come out of this. Now if I type here p1 equals to person, you will see that p1 has a couple of other variables. Apart from the default dunder attributes, you also have city and name for p1. Now we can also see what is p1.name by typing p1.name. It's giving none because we did not supply anything here. So automatically both of them took none as the default value. But if I wanted, I could have said p1 equals to person of, say for example, Vinod, Bangalore. And now if I type p1.name, it says Vinod p1.city equals to Bangalore. You can also reassign p1.name equals to, for example, Kumar. And then of course, if you say what is p1.name, you see that the name Vinod is lost and you have here Kumar. Generally, we don't want to do this kind of direct assignments to member variables. And this concept is called encapsulation. We want to shield the member variables by not allowing the user to modify the same thing. Now in Python, you don't have any keywords called private or protected or public like in other languages. For example, in Java, C++, C Sharp, you have a keyword called private, public, protected, etc. for the sake of encapsulation. We don't have any of those. Now this is where the convention of underscores come into picture. You could probably rename this. Instead of name, you could give underscore name. It's equivalent of what's called protected. We will discuss that when we go to inheritance. But you can also give a double underscore name to make sure that it's a private member variable, which means you will not be able to access them or make changes. Let's give it a try and redefine the class person. We'll have a def init which takes self, name equals to none and city equals to none. But this time while storing, we're going to say self dot underscore underscore name equals to name. So this is a new attribute I'm creating or adding to the object, but its value comes from this parameter, whatever is supplied by the user. Then I'm going to give here self dot double underscore city equals to city. Now if I type here dir of person, you will see that double underscore name and double underscore city may not be available here. But if I type here p1 equals to person and then I type here Vinod and Bangalore, press enter. If I type dir of p1, the person class themselves don't have those variables, but the p1 will have those two variables. But you can see that it is not over here, but it's been given some other prefix underscore person underscore underscore city. So obviously if I type here what is the p1 dot underscore underscore name, it will simply say person object doesn't have an attribute called underscore underscore name. We do have, but we are not able to access that. It got stored also when we created the object here p1 equals to person. It got created, but we are not able to see them. So the only way you can see them is now by adding additional functions. For example, let's redefine this to access the details of the same. So I'm going to type here class person. Alongside, we'll also write one more function this time called anything you want. We'll call it as print underscore details, where we have to write self. We'll come to this in a minute. And then we can now go and type here print name equals to, and then probably I can type name, which is nothing but self dot double underscore name. And then I'll say print city equals to self dot double underscore city. And I come out of this. Let's see here, P1 equals to person by supplying a couple of details like Vinod and Bangalore. And then I'll type here P1. It simply says it's an object. Dir of P1, you can see that it doesn't have the name and city with double underscores anywhere. But if I type here P1 dot print underscore details, you'll see that it shows that name is Vinod, city is Bangalore. Even if I do P1 dot double underscore name equals to Kumar, for example, what it does is it's going to add a new member called as double underscore name. So if I go here and type dir P1, you will see that there is going to be a new member variable called double underscore name, but that doesn't conflict with the internal variable underscore person underscore underscore name. So when you call the print details function here, self dot double underscore name always would refer to this, not to this newly constructed one. So if I type p1 dot double underscore name and I want to know what is that, it still says Kumar. So if I try calling p1 dot print details, you'll still see that name equals to Vinod, city equals to Bangalore, which means you will not be able to access that double underscore name directly. Of course, if I still want, I can say p1 dot underscore person underscore underscore name equals to, for example, say Sham, and press enter. Now if I say p1 dot print underscore details, there's a typo here, so I'll say p1 dot print underscore details. You'll see that the name has been changed. So while there is no concept of private, public, protected in Python, you could still hide the visibility of certain member variables by prefixing the member variables or member functions using double underscore, but it is still not completely hidden because I can always go and make the changes over here. So the Python philosophy is developers are more matured and say that if that is not meant for public access, developers won't access. For example, the purpose of having double underscore name as a member variable is to say that this is meant for an internal use and not for public to access. So we shouldn't be accessing that, as simple as that. So we don't have to restrict the developers not to access that. Developers themselves feel that, okay, member variables which are private or which are prefixed with underscore underscore are not supposed to be used in their code. And this is purely for internal purposes. So this is the philosophy behind why there is no private, public, or protected in Python. So in the next video, we will discuss more about the member functions that we saw here, like print details. Since the class person is growing, now let's try all these examples using some Python scripts. So first I'm going to create a new file called ex22.py. And let's create the person class inside this. I'll say class person colon, and now I can type here def double underscore init double underscore and take here self as the first parameter. And then you can supply additional parameters if you want. We can also define the special parameters here like star args or double star kw args and use the same thing. For example, I can use here double star kw args, and then I can assign to self dot double underscore name equals to kw args dot get, and then say here name. So if name is an attribute of this keyword argument, pass it on to this. In case if it was not defined, then it is automatically going to be none. So I can copy this and paste it and make the change here for this. I'll say city. I'll copy paste this and then I'm going to change the city to email. 3 parameters for this. So now the user may supply 0 or more named parameters. So not the arbitrary parameters but the named parameters. For example, let's write a function called main where I want to create a person object. I can say here p1 equals to person, and then I can say name equals to Vinod, email equals to, for example, vinod@vinod.co. And if I don't supply city, then that's going to be none. However, I can also supply any other parameters, but I'm not using them inside this. So there will be a waste of parameters. So for example, if I type here country equals to India, the country is there in the KWR, but it is never stored in self. So we will not be doing that. But let's keep this as it is. And I want to print the details of P1. Let's add another function here, def, and then say print underscore details. If I don't receive any parameter, it is okay while defining, but it will not be possible for us to print the details. For the time being, let's just say here print underscore details called. If I type here p1.print underscore details, and if I try to call the main function now by typing if dunder name equals to dunder main, let's call the main method. If I now run this script, the script execution as usual begins at this line and the main function is called here. In the main function, we are calling the class as a function. So basically we are constructing an object. Name and email go as part of the keyword argument. Now self was automatically supplied by Python, which is the reference to the newly constructed object. And in the newly constructed object, we are creating 3 private like member variables using the double underscore prefix, retrieving the values from the KWArgs parameter. And in case if it is not found, it's going to be assigned with none and comes out. And the reference of the newly constructed object is assigned to P1. Had I printed what is P1, it would simply say P1 is an object of, this time it will say ex22.person. But when I call this P1 dot print details, what Python does is Python takes this particular reference and passes that as a first argument over here. But I haven't defined any variables, so it is going to be an error. So let's give it a try. We go back to command prompt. Note that I'm already in my work folder. I simply have to say Python3 ex22.py. When I press enter, you can see that it starts giving an error. Print details takes 0 positional arguments, but 1 was given, and that is at p1.print details. It says that you have supplied 1 argument. Now what I have done is that I have not supplied an argument, but I called this function using an object. So what Python does is Python is going to look into the data type of P1, which is person, and it now knows that person class has print details. Python is going to call the print details on your behalf, and it supplies this P1 as the first argument. Now since I'm not calling this print details, but Python is calling by supplying P1 as the first argument, we are getting this error. So to avoid this, I'll have to go here, receive this P1 as some variable. So in order to receive this P1, let's define a new variable here. Let's call it as ref, just as an example. But a general practice is you use the word self, although it is not a keyword, it is a special type of variable name for Python. That's why this editor also is highlighting self as if it's a keyword, but it's not a keyword. So I'm giving here ref, and now I have no problem. You can see that when I run this script, it simply says print details called. But we know that ref is nothing but P1, and inside this particular function, because this is a member function of the class person, you have access to the private like variables, and I can print that. For example, I can say here, instead of printing this dummy message, I can say here name equals to, and then I can say ref dot double underscore name, and the same thing I can do for city. I'll type here ref dot city, whatever the variable we have given. And then one more is email, which is ref dot double underscore email. Now, if you write some other variable here, and if that variable doesn't exist, you may get an error saying that such an attribute doesn't exist. So right now this is okay. So let's go here and then try once more. Let me clear the screen and then access this once again. You'll see that it says name equals to Vinod, city equals to none, email equals to Vinod@vinod.co. Let's go back to our code. We have a way of printing the details, but we don't have a way of changing this name. For example, if I type here p1 dot double underscore name equals to Kumar and then copy paste the same thing, you will see that it's going to give the exact same details. Just to differentiate between the two outputs, let's give a blank print line. So we go back and then try this now. You will see that both the occasions it's still giving the same thing. Now I'm not able to change the name of the person in this fashion. But let's say I really want to change the name of the person and I don't have a way of doing this. In languages like Java and C++, we go and write a function here. For each of these, we're going to write 3 functions to change the values. For example, I'm going to write a function here called def. I'll probably call it as set underscore name, where I receive self as the parameter because it's a member function, and then name as a parameter. We'll pass it on to self dot double underscore name like this, so that whenever we want to pass on some value, we can call this function. And if you want, you can also supply default value, but the whole purpose of calling this function is that you want to set some name. So obviously there's no need of writing a default value here. But now I can come here and then say p1 dot set underscore name of, let's say for example, Kumar. So I can go here and then try the same thing. You can see that the name has been changed. This means if you want to make the changes to city or email, you have to write those corresponding functions as well. So def set email, which receive the self and email, and then I'll say here self dot double underscore email equals to email, and the same thing I may have to repeat for the city as well. So I'm going to copy paste, make the changes of all email here with city. So we have now set email, set city. If you have n number of private variables for this object, you may have to write n number of setters like this. But the name of the function themselves can be anything. It's just a convention that we just write like this. So let's change the city and email as well. So we're going to say p1.setCity of, let's say for example, Chennai, and let's say p1.setEmail is kumar@example.com. Now that we have changed the values of p1 is the same object, but its values have been changed. So let's go and try this. Let's clear the screen and try once more. You'll see that the first time we have Vinod none and Vinod@vinod.co, but it has been changed to Kumar Chennai and Kumar@example.com. In this video, let's have a quick look at how a person object can be printed directly without having to call the print details function. Or in other words, how we can represent a person object in a text format. To do that, let's go to a command prompt. In fact, let's go into a Python shell. And then let's say we want to use the person class here, but we know that it's part of ex22. So I can say here from ex22, I can say import person. And now we got the person, and if I type here dir of person, you'll see that it has got all these members, and these are the 4 members that I added. Before that, it has inherited all these members from a class called object. More about inheritance we will learn in a lecture called inheritance. But importantly, you can see that there is one special function here, or an attribute called $_str$. This can be used for textual representation. For example, I say here p1 equals to person, name equals to Vinod, city equals to, let's say, Bangalore, and email equals to Vinod@vinod.co. Since these are keyword arguments, you can pass them in any order, doesn't matter. But if I simply type p1, you see that it says p1 is an instance of ex22.person, and it says that the address, it's giving in a specific format. Now it is actually coming from this str dunder function. For example, I say p1._str_. Notice the double underscore attributes or functions, they are not meant for me to call. It's used internally, but I just want to prove a point that p1 is same as p1.dunderstr. You can see exactly same thing. So if I can override this function, and return a string that makes sense, then whenever I say P1 or print P1, it might actually give me a valid information. So for this, I'm going to go back to my code and override a function called str, just like this one. So I'm going to write right below this. I'll say here def double underscore str double underscore self is required because P1 is passed as an argument when you're trying to print P1. And all I have to do is to return a string here. I can use the formatted string, like for example, I can say name equals to a curly bracket, email equals to another curly bracket, and then city equals to another curly bracket, dot format. It needs three parameters. I'll say self dot double underscore name, self dot double underscore email, self dot double underscore city. So I'm actually returning a formatted string using the self member variables. But if I go back to the Python shell and try to reprint that, it will still show me this because the person class was loaded when we did this import here. So even if you do an import again, it says that the class has already been imported. It will not be importing again. So let's exit the shell and then get back again. And now if I say here from ex22 import person, it has imported the new version. And now if I assign P1 with some values and then if I type P1, you'll see that it shows like this. But if I say print P1, you should see that name equals to Vinod, email equals to Vinod at vinod.co, city equals to Bangalore has been printed. So this is how you can represent an object of a class in a text format by overriding str dunder function in that particular class. In the previous lecture on member functions, we learned that private-like variables can be modified by using functions like set name, set city, set email. Now, the primary reason why you want to do that is because if you let the user assign directly, then user may assign wrong type of values. Whereas because this being a function, before I can assign the value, I can actually verify whether the name is a str or is it an integer and so on and so forth. So we can do some basic validation before we can assign. And of course, if you have the functions defined here, you are supposed to call something like this. However, Python also provides something called setter and getter properties, using which you can use them as if they're variables, but the definition is behind the scene like a function. In this video, let's see how to create such properties. So I'm going to remove these function calls and we also delete the function definitions, but we want to see what is the name of the person, city or email of the person. Let's also get rid of these two and then say here print p1.name is, and then I'm going to type here p1.name. I'll also copy paste the same thing for the email city. So I'll change this to email, I'll change this to city. Of course, if I go and run the code, we're going to get an error because name, email, city are not valid attributes of P1. The internal attributes are dunder name, dunder city, dunder email. We have removed the functions also. So let's give it a try and see what's the error we're going to get. Notice that I'm in my work directory and I'm going to say Python3 ex22.py and it's going to come back with an error saying that person object has no attribute called name. Of course, if I'm going to comment this out, then there will be an error for this. If I comment that, there will be an error for this. Now, in order to access the underscore name, city, email in this format, we're going to write some function called name, email, city. So let's say def name. We have to pass the self as the parameter. And I'm going to say here return self.dunder name. Now, since this is a one-liner, you can always bring this in the same line as this. No problem. But notice that if you now actually run the code, p1.name is a function. So instead of calling the function, it will simply say that it's a function. So if I go here, run this, you'll see that p1.name, if you look at this carefully, it says it's a bound method of person. So it says that p1.name is a function and you're not called it, of course. So in order to get the name, we actually have to call it. We don't want to do that. We want to still use it like a variable itself. All you have to do is to say here @ property. Now, at the rate property is called as a decorator, and in Python 3, decorators can be used for having some metadata about functions. In this case, we simply say, hey, even though this is a function, user is allowed to use it like a variable. So that's what we're going to do here. And the same thing, I'm going to copy this and paste here a couple of times, one for email and one for city. So I'm going to change this to email and this one to city. Now you'll see that when I actually run this script, we are actually accessing p1.name, which is actually a function, but we have defined it as a property. So we are allowed to access it as if it's a variable. So let's go give it a try. And this time you can see that we are able to access the internal private like variables as public variables, p1.name, p1.email, p1.city. But this doesn't mean that we can change the values. For example, if I type here from p1.city equals to, for example, from Bangalore to say Bengaluru, and if I try to run the same, you're going to get another error, and the error says attribute error, can't set attribute. It says that while you are able to access the value, there's no problem, but when you're trying to assign the value, there is an issue. So for this, we have to create another function which can take this right hand side value and assign that to the internal property like this. So the way you can do is for each of the property, you write one more function. This time it's a function to take a parameter. So we have to say you are supplying a name, because whatever the right hand side of this assignment, it is considered as a parameter. So we're going to get that here. And then we'll say self dot dunder name equals to name. And the same thing we're going to do for other two. But we also have to say that this is a setter for this particular property. The way you do is you say here at name.setter, name being the property we defined over here. Likewise, I'm going to write here one more. I'll say at the rate email.setter, but that's a function called email which receives self and another parameter. But what it's going to do is it's going to say self dot double underscore email equals to email. So we receive that email as a right hand side of the assignment, and then we assign it to this member variable. Likewise, we're going to do the same thing for city. We say at the rate city dot setter and a function city where self is the invoking object. On the left hand side you say p1.city, you may say that is going to be the self here, p1, and then city is the parameter. All I'm going to do is to say self dot double underscore city equals to city. Now that we have got all these three, we should be able to change all the values of this p1. Let's say p1 dot name equals to say Vinod Kumar, and then p1 dot email equals to, for example, say kayataya.vinod@gmail.com. Now that we changed it, we can actually print the values using the print details. I can say p1 dot print underscore details. Let's give it a try. Clear the screen and then try this again, and you will see that we change the values using the assignment operator using these properties now. Operator overloading means giving extended meaning beyond their predefined operational meaning. For example, the operator plus is used for adding two integers as well as join two strings or merge two lists. It is possible because the plus operator has been overloaded by the int, str and list classes. You might have noticed that the same built-in operator or function shows different behavior for objects of different classes. This is called operator overloading. To understand the same, let's create a new Python script, create a new class, and check out some scenarios. So I'm going to create ex23.py and then a class called employee. We will define the constructor, which is dunder init, which takes self and kw args so that we can pass on some values. Let's assume that the employee has ID, name and salary. So we can say here self dot double underscore ID equals to kw args dot get ID. so that in case if the ID is not supplied, it's going to be a none. Similarly, I can say self dot double underscore name equals to kw args dot get of name or none. Self dot double underscore salary equals to kw args dot get salary. Let's also define the str function like this, which is a dunder method, which takes self as an argument and returns a string version of this employee information. So we're going to say return, probably I'll say ID equals to a curly bracket, name equals to a curly bracket, and salary equals to a curly bracket, dot format, and we supply three parameters because we have got three curly brackets: self dot double underscore ID, self dot double underscore name, and self dot double underscore salary. Now that we have this, let's also define the setter and getter for all the three private variables. So I can say here def ID, which takes a self as a parameter and returns self dot dunder ID. But in order to make this as a property, I have to say here at property. And to write the setter for the same, you have to say at id dot setter and then say def id self, and it takes an ID. Here is where we may have to assign the value that we receive as the parameter to the private variable that we have. In case if you want to do some validation, such as for example, ID must be passed, ID must be an int, ID must be a number that is greater than 0. You can do all those things here. So I'm going to check here if type of ID is not an int, then I can raise an error. So I can say here raise because you gave a wrong type of ID. So I can say type error, a built-in error class with a message invalid type for ID. Similarly, I can also check if ID happens to be a number but it's less than or equals to 0. Then I can also give another error message saying that value error, because this time it's an invalid value. So I can say, for example, ID must be more than 0. If everything is okay, then I can probably say here self.dunder ID equals to ID. Since these are one-liners, let me just give it in the same line. So we have a setter for ID, which receives an ID and then does a couple of validation, and if validation is okay, then we are passing, otherwise we are raising errors. Now notice that this validation takes place only when you are assigning an ID using an object. However, in the constructor, if ID is given, then there is a problem. So what we can do is the value that we are retrieving from the KW args, instead of assigning directly to the private member variable, we can assign to this property directly. So because these are all properties of the employee class, so the self dot ID also can be directly called like this. So now we are assigning this to a property, and that time the setter is automatically invoked, and whatever the value that I'm supplying over here, that is being received as a parameter, and then we are doing the validation. If everything is okay, then we are assigning self dot double underscore ID, which we were doing it earlier here. Now the same thing I'm going to do it for this. At this time I don't have a property called name and salary. We're going to do the same thing in a minute. So let's come down here and write the property called name. So def name of self return self dot dunder name at name dot setter, and then a function called a name which receives self and a parameter, so that I'll call it as name, and this name is nothing but the one that we are retrieving it from the KW args, which is passed during the construction of the object. Now I can do some validations. For example, I can say here if type of name is not str, then I can say raise type error, probably the same message as earlier, invalid type for name, must be an str, and so on and so forth. Similarly, imagine you have given an empty string or a name which is less than 2 letters or name greater than 25 characters. So you can probably throw an error as well. So I can say if len of name is less than or equals to 2, then I'm not interested in the name. You can also say or if len of name is greater than, say for example 25, then I can say raise probably an error like a value error in this case, and probably I can say that name too large or too big, and that could be one type of error. You can think of any other possible validation errors that you want to give it for name, you can give there. If everything is okay, I'm going to say here self dot double underscore name equals to name. If double underscore name is not there yet, so that gets created over here, but if it's there already, it gets overwritten. Now that we have this, let's do one more. So I'm going to say here at property def salary, and we receive this self, return self dot dunder salary. Now another one is the at salary dot setter, and then we give here def salary, which receives self and salary, and then press enter. We are going to copy paste the same thing here and paste over here. We are going to type here salary. There is a invalid type for salary, but this time I also may have a int as well as float, so I can say not in, then I can say here float or int, and this is because salary may be a floating point number as well. Similarly, I type here if salary is less than, let's say for example 20,000, then I can say that if it is less than or equal to 20,000, so I want to give an error because it has to be more than or equal to 20,000. So I can give the same message over here. And if everything is okay, I'm going to create a new property called salary and pass on the received value from here. Of course, you could also give a default of something like this. If you are not given, let's say for example 25,000 is the default value for salary here. So now that we have a basic class here, let's give it a try regarding the operator overloading. So I'm going to write a def main to test out these things. Let me create two employee objects. So I can say here e1 equals to employee of, let's give a couple of values, name equals to Ramesh, and then ID equals to 1, salary equals to, let's say for example 35,000, and similarly second one E2 Vijay, and ID is say for example 12, salary equals to, in case if I pass less than 20,000, you will see that it will raise an error for this. Let's give it a try, and then I type here if dunder name equals to dunder main, then we want to call the main method. Let's go to the command prompt and check out the same. Notice I'm already in my work folder. I have to say here Python3 and ex23.py, and then when I press enter, I see an error. The error says ID must be more than 20,000. So there's a typo here. It must be salary. Let's go fix that. And here is that. So this is supposed to be salary must be more than 20,000. Let's go try that again. I'm going to clear and run this code again. And now it says salary must be more than 20,000. So because I have passed 5,000, and you'll see a stack trace like this. Let's go fix that. I'm going to go here and type 25,000, or if I don't pass this, the salary will be 25,000 anyways. So if you want to check, so we can always come here and then print both of them. I can say print E1. Remember, we have the dunder str being overloaded, and I can say here print E2. So let's go try, clear the screen and run the same program. You'll see that ID is 1, name is Ramesh, salary is 35,000, but for Vijay, salary is 25,000 because of the default value, and no validation error. Now let's come to the operator overloading. Let's give a try here by typing E1 plus equals to, let's say for example, a space and then say Kumar. What I'm interested in here is that this Kumar should be appended to Ramesh. However, the plus equals to is a built-in operator that will now cause a problem because it doesn't know how to add an employee object and an str object. The plus equals to operator can only work with operands of the similar types like str and str, int and so on, but it doesn't know how to work with an employee and Kumar, which is a string. Similarly, if I say here E1 plus equals to, let's say for example 2500, because this is a number, I want that to be appended to salary. Now these are the definitions that I have to give as a developer. But this would cause a problem. So if I go and try the same thing, you will see that it gives me an error, unsupported operand types for plus equals to an employee and an str. Because this is an exception, this did not go forward. If I comment this out, so the next error you will see, it says that employee and integer, I don't know how to do the plus equals to operator with this. So what we want to do is we want to now provide such that if I use this plus equals to operator with the string as a right hand side operand, then I want to add to name. If the right hand side operand is a number, then I want that to be added to the salary. Python provides few methods called magic methods to do the same thing. Now the magic method corresponding to this plus equals to is called iadd, which is a dunder function. So I can come to my employee class here and then write here a function called dunder iadd and double underscore again, which takes self as the parameter. Now self here would be the invoking object, which happens to be the left hand side of the operator. So that happens to be E1. So E1 is received as self in the first case. If I have E2, then E2 would be received. The right hand side of this operator will now be received as another variable. Let me call it as value, because I'm not sure it's going to be a string or a number. So I'll just generically type this as value. Now that I have these two, I can check if type of value in int or float, is this a number? Then I can say here self, which happens to be E1 at this point in time, dot salary, which is a property that we have defined right here. We are going to assign a value. So we're going to say here plus equals to value. Now notice at this time salary happens to be a number. We have ensured that over here. And value is also a number. We have ensured that over here. Now there is no problem because number plus equals to number is not a problem. So the built-in operator itself knows how to handle these numbers. So this addition takes place. But in case if the type of value is a str, I can check with equals to str. Then I say self.name plus equals to value. We know that this is a str. This is an str property, so we are concatenating now. So this way the value will be either appended to the name or added to the salary. Any other data type that you supply, for example, if you supply Boolean or any other data type, so I can say here else raise probably a type error because I don't know how to handle that over here. So I can supply a similar message invalid type for plus equals to operation. One last thing that we have to do for this iadd function is to return self at the end so that the same thing will be assigned back to this E1 here. So after adding, whatever that we are returning here will be assigned back to this E1 or E2. So let's go back to the command prompt, run the same script once again, and you'll see this time it has been changed to Ramesh Kumar as well as salary has been changed to 37,500. Similarly, we can overload a couple of other operators. For example, if E1 less than E2, then I want to compare employee 1's salary with employee 2's salary. Or if directly if I supply some number like this, then E1's salary is compared with the 50,000 that I passed as a parameter. So if I want to do this, let's give it a try. So I'll check here if E1 less than E2, then I want to say here print, let's say the employee 1's name I'll give here, earns more than employee 2's name. I'll say dot format. Remember we have the property, I can say E1 dot name, E2 dot name. So two of the names are printed over here. In this case, because I used a less than operator, I should check here less than. Similarly, I give another one where if I have here something like 50,000, this should be 50,000 here. It's an amount. Let's go give it a try. Both of these are going to give an error. First, this will raise an exception and stop the execution of the program. If I comment this out, then this should give an error. So let's give it a try. So run the code. You'll see that it says less than operator is not supported between instances of employee and employee. If I comment this line and then run the code, you will see that it says less than is not supported between employee and int. Now this time we are also expecting a boolean as a return value here, not the self. So in order to overload the less than operator, the magic method here is called dunder lt. So there is also LE and GT, GE for less than or equals to, greater than or equals to, etc. Let's come back here. Def double underscore LT. In this case, I'll say self and a value. The value can be an employee object or it could be a number. So I'll say here, if type of value is equals to employee, then we are going to say return self dot salary. Is it less than value dot salary, because value is an employee object. So we checked it out over here. Elif type of value in either int or float. Then I want to say return self dot salary. Is it less than the value given as a parameter, which is the right hand side? In both the cases, it's going to return true or false depending on the expression given over here. In case of any other data type that you have given, I'll say here raise type error, because maybe you can say unsupported type. So I'll say unsupported type for less than operator on employee. So let's give it a try now. So we have given here two expressions already. We know that E1's salary by now is 37,500. E2 salary is 25,000. So this condition is not satisfied. So obviously it is not going to print this message at all. Whereas E1 salary is 37,500, less than 50,000 is true. So this is going to come. So let's go and try this once more. Let me clear the screen and then run the Python script. And you can see this time it says Ramesh Kumar earns less than 50,000, whereas it did not say Ramesh Kumar earns less than Vijay. Now what we can do is we can swap this. So I'll say E2 and E1 here, or I could give a salary which is more than 37,500. Let's give it a try this time. You'll see that it says Ramesh Kumar earns less than Vijay. That's a wrong message though, because I'm giving here E1 name and E2 name. This should be swapped. Alternately, I'll simply do an undo and then supply a salary which is more than Ramesh's salary. Let's say, for example, 40,000. Let's go give it a try again. And this time it says Ramesh Kumar earns less than Vijay, because Ramesh's salary is 37,500, whereas Vijay's salary is 40,000. So in general, all the operator overloaded functions would look like this, where you receive a self, which is the left hand side of the operator, and then you have the value, which is the right hand side of the operator, at least for the binary operators. Perform some operation, return some values. So in case of all the relational operators like less than, greater than, etc., so you must return a Boolean value, which is what we are doing over here. Whereas in case of the I functions, such as I add, I mul, I sub, etc., you should return the self itself. Here are the other operators that you can overload. These are binary operators like plus, minus, star, slash, integer, division, etc. And these are comparison operators or relational operators. All of these must return true or false. And then we have here shorthand assignment operators like plus equals to, which we saw just now, or minus equals to, star equals to. In all these cases, you must return self itself. Suppose I have different types of employee classes, like, for example, salesman, manager, etc. Instead of rewriting all these functions and properties once again for those classes like salesman and manager, we can actually reuse this employee class by inheriting them in the respective classes. So the whole purpose of inheritance is code reusability. Let's consider a new script file, ex24.py, wherein I want to create a new class called salesman that inherits from the employee class. So first I may have to say from ex23 import employee, then I say class salesman, and in bracket here we're going to specify a class name which happens to be employee. We now call salesman is the subclass, employee as the superclass. In other languages, you may consider salesman to be a derived class and employee as the base class. And let's give a colon, and for the time being I'm going to simply say pass. Let's go to a command prompt and then get into Python shell, where I can create an object of salesman. So from ex24 import salesman, and if I say dir of salesman, you'll see that there are already members here called ID name salary. Of course, dunder str and dunder init anyway are there. So if I create an object of salesman, let's say s1 equals to salesman, and then supply named parameter like for example John, salary equals to let's say 40,000, and then I can say ID equals to 2233. I can as well supply a couple of other details, but they will not be of any use. But now if I say print s1, you'll see that the str written in the employee class is being used, although s1 is an instance or object of salesman class. So now I can go back over here and add additional properties, features, operator overloaded functions, and so on and so forth. Hence, we say that the salesman class is an extension of the employee class. So let's do that first by defining a constructor. We'll say init and take self as well as keyword arguments. And then I'll say here new properties of salesman. For example, self dot, let's say salesman has something called commission equals to kwargs.get, let's say commission. And likewise, let's say salesman also has a region where he or she works with. Since I have overridden the init function in the salesman class, now the employee class init will not be called, and because of which the employee class name or salary ID, they will not be assigned to this salesman at all. To test the same thing, let's add a main function over here, and there we'll create a salesman with all the values such as ID, name, salary, commission, and a region. And let's see when we print what is going to happen. So I'm going to say here salesman of name equals to let's say John, ID equals to 2233, salary by default is 25,000. I can leave that as it is, but let's give it as 35,000. Commission percentage, for example, happens to be let's say 12%, and then region equals to let's say north. Now that I have all these values, let's see if I say print s1, what are we going to get? In order to say that the main function should be called when we run the script, so we say here if dunder name equals to dunder main, then we want to call the main function. Let's go back to the command prompt, exit out of the shell, run this ex24.py. So I'll say Python3 ex24.py, press enter. You'll see that it says salesman object has no attribute called employee underscore underscore ID. Now, if you're wondering why I'm getting an error like this, let's go back over here. We are actually creating an object at this line by supplying 5 different named parameters. All of them are received over here, and the received values we are only collecting commission and region and then assigning to, in this case, it's just a variable, not even a property, but it's being used. But the remaining ones like name, ID, and salary, they have never been passed to the employee constructor. Now, in languages like Java or C++ or C#, there is an automatic invocation of the superclass constructor. In Python, it has to be an explicit call. And the way you can do is, you can do anywhere you want inside this constructor, but general practice is you give it in the beginning. And the way you call is, you first call a function called super. This returns a reference of the superclass object, and then you say here dot init like this by supplying all the keyword arguments spread across. Now that I'm supplying this to the superclass constructor here, it goes to the employee constructor, receives the self, so self will be this object, and then there is a keyword arg, so all these will now be received in here. ID, name, salary will be assigned using these properties which we have here, and then comes back and then assigns the commission and region over here. Now, of course, there is no error in this because when S1 is being printed, S1.str is called. I don't have an str over here, but the str is inherited from the employee, and the str in the employee class is actually trying to access the ID, name, salary, for which we got an error earlier. But now that we are passing the keyword arguments to the superclass constructor, this error should not be there. Let's give it a try, and you can see that it says ID is 2233, name is John, salary is 35,000. So the values that we supplied to the salesman constructor have reached the employee member variables. Now let's also define two properties over here called commission and region. I do not want to do any validations over here. I simply say at property, and the name of the property is called commission. It takes a self as an argument, returns self dot double underscore commission, and then I'll say a setter for the same at commission dot setter, and then I'll say def commission, that's the function name, self and some value, it doesn't matter what it is, it's going to be assigned to self dot dunder commission equals to commission. Likewise, I want to create one more property or a pair of functions for region. So I'm going to copy this, paste it, and then make the necessary changes. So this is all going to be called region. So that's done now. So let's go here now and write one more function, which is the str function, because str in the employee was only displaying the ID, name, salary. Now we also want to display the commission as well as region. Let me add it after the init. So I'll say def dunder str self, and then I should return a string, which is let's say a formatted string. So I'll say format that prints the employee object as well as the details of the salesman. So I'm going to say here employee equals to a curly bracket, comma, then I'll say commission equals to a curly bracket, region equals to a curly bracket, like this. Now for the format function, I have to supply three parameters. This is nothing but the return value of the employee str function. I can say here super to refer to the superclass object dot dunder str, and I'm actually calling that. Then I'm typing here self dot commission, which is a property now, and self dot region, another property. Notice the return value of str from the superclass function is a string, and that string is going to be substituted over here. Now if you want, you can surround this result in a round bracket just to group them apart. So let's go and give it a try now. So when I print S1, I expect all the values that I've supplied for S1. So let's give it a try again. And you can see that it says employee details are this. Now you see the round bracket here. ID is 12233, name is John, salary is 35,000. But then you have commission equals to 12, region equals to north. So this is how you will be able to inherit and make use of all the functions and properties available in the superclass. To understand multi-level inheritance, let's take another script. So I'm going to create a new file here called ex25.py. In this script, let's import the person class from the ex22. So I'll type here from ex22 import person. And now I can create a new class out of the same. Let's assume that it's employee. Employee is a class that inherits from person. We denote it like this. Imagine employee class needs the details of name, city, email for every employee. So instead of recreating all these lines of code here in the employee class again, we are simply inherit from the same. Now the employee class itself can define different properties. So I'm going to use here def dunder init and then receive the self and keyword arguments. And then I can say here super, which is actually the person in this case, but I can explicitly mention here as well. Right now I don't need to do that because there's only one single super class. And then I can say here dunder init, pass the keyword arguments just like that. And now I can define different new properties over here. So I can say self dot id equals to kwargs dot get, and then I supply the id. And in case if the ID is not supplied, that's going to be automatically assigned as none. And I'm going to copy paste the same thing. Let's assume that there is also a salary for the employee, and that should be good enough for this particular class. Now, if I just leave like this, then these things will be created automatically as variables in the employee class, rather in the employee object. But I can define properties for ID and salary. The way you do that is by defining something called id as a function which takes self argument and return probably self dot double underscore id. to say that, hey, there is a private variable called ID, return the same, but we have to say that this is a property. Now similarly, I can have here @id.setter. That's the way you say a set property, which is a function called ID. It takes self and probably the new ID that we want to assign, and we'll say self.double_ID. This is where it gets created, equals to the parameter ID. We generally do validations, but in the interest of time, I'm not going to do any validations for this. So I can make a copy of the same and then paste over here, make a new one where everything here changes to salary, and we have now a new property called salary. We can also write a new function here, which is the dunder_str to textually represent this employee. But if you see in the person class, it is already defined over here. We call this concept as overriding of methods. So when you override a method, every time using the employee object, if you're calling the dunder_str, or if you're trying to print the employee object, the str defined in the employee will be called, ignoring the str function defined in the person class. So whenever you override, if you really want to make use of the parent function, you may have to explicitly call. For that, once again, I can make use of super dot. So let's go and do the same thing here. So def dunder_str, which takes self as an argument and supposed to return something. So I'm going to return a formatted text, and the formatted text may include a person equals to a curly bracket, probably inside a round bracket, but the curly bracket is the one that is required by format, and then a comma. Then I can say ID equals to a curly bracket, salary equals to a curly bracket, to say that this whole thing is employee. And to supply the parameters, I may have to say here something like super.dunder_str, and I call the return value of the dunder_str written in the person class will be substituted over here. And then of course I'll say here self dot either dunder ID or simply ID, because ID will call this getter. And then I'll type here self.salary, which will invoke this particular function and gets the salary, which is a private variable here. So now that I have this employee class ready, we can also override the other function that we have here, which is called print details, which is printing name, city, email. Now I can as well add additional details such as ID and salary. Now let's go and try the same thing. So I'm going to copy this and paste here so that the signature remains exactly same. And here I'll say print. I can say, for example, ID of the employee equals to self. Notice I used a variable called ref. Let me call it as self again here. Self.id. Again, it's going to make use of this def here. And then I'll copy paste the same thing. It's going to be salary, and probably I can say here in rupees, or I can ignore that. I'll say salary. And now I can say here super dot print details, and now it should take care of printing the super print details, which is the person print details. So now we have two levels of inheritance, where employee class is the derived class, person class is the super class or base class. So in a multi-level inheritance, now this employee can act as a super class as well. For example, let's define another class here called, let's say, salesman, who also has more details apart from ID, name, salary, email, city, etc. So I can simply say here salesman is an extension of an employee, and then I can redefine all the functions that I've got over here. For example, let's say redefine init, which takes self as well as keyword args. But remember, salesman receives the employee details as well, which may include person details as well. All of them are included in the KW args over here. All I have to do is to say super dot dunder init and then supply the KW args as parameters. And then I can define the properties of salesman, not worrying about what happens with the ID, name, salary, email, etc. So I can simply say here self dot, let's say he has something called commission, equals to kwargs dot get, and then say commission. Let's also assume that the salesman has a region. So I'm going to copy paste the same thing over here and then change this to region. Then I'll define the properties for the same thing, quickly I can copy the same from over here, both getter as well as setter, make the necessary changes, which is all IDs are going to be here commission, and one more, which is the region. Alright, so now I got quickly new properties as well. Let's redefine this dunder str, which takes self as an argument and returns a formatted string. So I'll add the format function. And this time I want to say, hey, the employee details is this. That includes the person details as well. As well as I can say here commission equals to a curly bracket, and then I'll say region equals to curly bracket. So again, I need three parameters over here. So to supply those three parameters, I'll say here super dot dunder str. This time I have to call this function, and then I'll supply here self dot commission and self dot region. Similarly, I'm going to copy paste this signature here so I don't make spell mistakes. So I can override this print details function, and then I print here super, which is the employee here for the salesman, dot print details, and then I will print the details of commission. So I can say commission equals to, and then I say self dot commission, copy paste the same. So this is going to be region, and then I have here region. So notice that when I print super dot print details, it's going to go over here and then print the ID first, then the salary, and then it's going to print super dot print details, which is the person's print details, and that's going to print name, city, email, and then comes and prints a blank line. After that, it's going to come down here and then print the commission and region. So there will be a blank line over here. So to avoid that, I'm going to remove this blank line over here, or the print statement. Now let's go back to the ex25.py and test out this multi-level inheritance where salesman inherit from employee, employee inherit from person. For that, I'm going to define a main function, and inside that I'm going to create a salesman object. To do that, I simply have to say s1 equals to salesman. This is going to call the constructor, and I can supply named parameters in any order here. For example, I can say id equals to 2233, name equals to, let's say, John. Then I can say here salary equals to, let's say, 25,000, and then I can say region equals to, let's say, North, email equals to john@example.com, one last, city equals to Bangalore. Now I have all the details of the salesman. I can either say print s1 to print the details using the dunder str, or I can say s1 dot print underscore details to print the customized results. One last thing is to call the main itself. I can call the main directly like this, but if you want to say only when you run the script you should get this, not while importing, so I can put that if condition dunder name equals to dunder main, then you call the main function. So let's give it a try and check this out. So I'm already in my work folder. This is the ex25 that we want to run. I'm going to say here Python3 ex25.py, press enter. You can see that the first line here is showing the details of the employee. That includes person, where name is John, email is john@example.com, city is Bangalore. That's the person details. But the employee details continue here as ID equals to 2233, salary equals to 25,000, and then commission equals to none. So there must be a typo. Let's figure it out. Or I didn't supply commission as parameter. Region equals to North. And the same thing has been printed in the fashion that we wanted. ID, salary, name, region. Notice that ID is printed in the employee, salary is printed in the employee. Then we call the person print, which prints these three. And then come back to the salesman print, and it's printing all the details. Except that I didn't have a commission here. So that's because I didn't supply a commission. I can give here a commission equals to something like, say, for example, 12%. I clear the screen and try the same thing once again, and you should see that we get the commission as well as other details. So to summarize, a multi-level inheritance is nothing but a class inheriting from another class, and that class inheriting from another class, and that class inherit from another class, and so on and so forth. So in this example, salesman inherit from employee, employee inherits from person, and by default person class inherit from a class called object. If you wanted, you could still go and give it to the person class here as object with O small letter. Now let's talk about something called multiple inheritance, and some of the modern languages like Java, C Sharp have refrained themselves from allowing the users to create multiple inheritance. Now this is probably because there is a very popular problem called as a diamond problem that exists. We'll talk about that some other time. But for now, let's see how Python allows us to leverage this multiple inheritance where a class can have multiple parent classes or superclasses or base classes. For this demo, let's create another script file called ex26.py, and let's create two classes that probably act as base classes. Consider a class called phone, and if you want, you can always say object, but this is by default. You don't have to really mention this. And let's just add here a function which simply says dial number. So I can say here dial, which takes self as a parameter, simply prints here dialing. And let's write one more function just to simulate a phone. Let's call it as accept call and probably print a message call accepted, and one more function called decline call, and we simply say call declined. Let's create another class called camera, which inherits again from object, so there is no relationship between phone and camera here. And this has got functions like take picture, which takes self as a parameter and then print a message saying that taking picture, and probably delete picture, view picture, something like that. Let's say view picture, which we have just taken. We want to see what's the picture. Let's print another message saying that viewing the picture. And you can have additional functions of camera. We just want to see what's the relationship between phone and camera over here. As of now, they're independent of each other. But now I can have a class that can act as a subclass or derived class for both of these classes. One another language that allows these kind of multiple inheritance is C++. There is a big difference between the way that C++ and Python multiple inheritance works. Let's focus on Python here. So I'm going to say class, call it as camera phone, which inherits from phone as well as camera. Let's define probably additional functions here, or for the time being I can simply say camera phone constructed. I can put a constructor over here, or for the time being let me also simply say pass, so that camera phone itself doesn't define any functions or members, but because of multiple inheritance it has got 5 different functions automatically. Now just to check this out, so let's go here and see how this works. So we're going to define the main function and create a camera phone object. So let's call it a CP, and I say camera phone and not pass any parameters because we don't have any constructors at this point in time. But using this CP, I can call any of those functions. For example, in order to leverage the phone features, I can say cp.dial, that's one function, cp.acceptCall, another function. Likewise, I can also say cp.takePicture as well as cp.viewPicture. And let's test the same thing by checking if the name of the script is equals to the main that we are running, then we'll call the main function. And let's test it out by going to the command prompt and then running this Python3 ex26.py command. And you'll see that it is invoking all the functions without any problem. However, let's go and add some constructors and see what happens. So here I'm going to write constructor in all the 3 functions. So I'll say def dunder init takes the self as an argument. I don't want to receive any additional parameters. I just want to say here print camera phone instantiated. And the same kind of functions we're going to define for all of them. Let's say this is going to be camera instantiated as well as phone instantiated over here. So now if I go back to the command prompt and run the same command again, you can see that it only invokes the camera phone constructor and not its parent constructor. So this is a big difference between Python as well as C++, because in C++ in the sequence of inheritance that you have defined, the superclass or base class constructors would be invoked. For example, when you constructed the camera phone object, even before this could be called, it would actually go to the superclass, which is phone, and finishes all its constructor calls as well as its parents constructor call, etc. And then comes back and then goes to the camera constructor and all its superclass constructors, and then comes back and then would finish this particular print statement. But however, in Python, constructor is just another function. For example, in C++, you cannot call the constructor. It would give an error. Here, this init is just a convention. You can call by yourself, but Python also calls this automatically. So, in order to say that we want to call the superclass constructor, we have to decide, should we call this before printing this message or after? A general practice in most of the object-oriented languages, in case if you have a superclass constructor, you call that before you do anything. Most of the cases it happens automatically. So let's follow the same pattern even in Python. Call the constructor of the superclass first and then do any other activities. To do that, let's say here super and then supply whatever the init functions parameters like this. But now the confusion is which constructor is going to call, because there are two constructors here. To understand the same, let's just give it a try and see what happens. So if I'm going to go to the command prompt and run the same script again, you will see that it's going to the phone constructor, not to the camera constructor. In case if I change the sequence over here, so let's say I cut this from here and then put a comma and paste over here. Now camera is the first one in the list. So if I go back and run the same, you will see that it says camera instantiated and not the phone constructor. So as you can see that with this way, now we will be able to invoke only one of the constructor. But if I want to invoke both of them, we can type here camera as if we are invoking this method using the class name. Because there is no object involved here, there is no parameter supplied. If you remember our constructor session, I told you that this is going to be invoked automatically by Python, and Python supplies the newly constructed object as a reference. But in this case, I am the one who is invoking, so it becomes my responsibility to supply something over here. And all I do is I'll supply self. So we are now supplying the self, which is the camera phone object's reference, to the camera init function. And likewise, I can also put here phone. And now since I'm calling, I can control the sequence. Whichever I want, I can call that first or second. So now if I go back to the command prompt, let's clear the screen and run the same thing once again. You'll see this time camera instantiated, phone instantiated, camera phone instantiated. So all the constructors have been called. That's because it's explicitly called by me, not by Python. Let's take one more scenario. Let's assume that both the phone as well as camera phone have a common function. Let's assume that it's called print details, def print details. And I'm going to just print a message. This is from phone class, and I'm going to copy the same thing and paste even for the camera as well. And then I'll say this is from camera class. What happens if I come here and then type cp.printDetails? cp.printDetails is supposed to call the function from here, right? So the print details is not defined here, but it is inherited from camera as well as phone. So both of them have the same function. Now in languages like C++, it would be a confusion as whether to call this from camera or from phone, and that would actually lead to some ambiguity. So let's see what happens in Python. I'm going to run the same. So I got an error here. So let's see what is that. It says print details take 0 positional parameters, but 1 was given. This should be probably because I didn't define self. So I have to write here self, and here as well. Any member function you write should have the self. Incidentally, I did not call this function, and that also missed self. So if you don't have self, it will be considered like a static function in other languages. And so let's go back and try it again. Clear the screen and run the script. And now you can see it says that this is from camera class. Unlike C++, there's no ambiguity here. And straight away it took from this part and not from anywhere else. Now in case if I had removed from there and then put a camera as the second one, so now phone is the first one that comes, So obviously, if I run this now, you will see it says that this is from the phone class instead of the earlier one where it says this is from camera class. So having a similar functions in multiple parents is one of the major problem in multiple inheritance, which is not having a problem here in Python. But in case if I want to invoke, let's say for example, the print details from the camera or phone specifically, then I will not be able to do that over here. If you really want it that way, you can always say here something like camera dot print details and then supply CP as an argument. Let me comment out this one. So this is the by default that's coming, and let's add one more. So phone dot print details, because we know that print details is a function in the phone, but it requires an object, and I can supply CP as an object. So anywhere if you are using self inside this print function, it would take the CP as self and then work with that. So which is okay for us. We'll go back and try this once more, and this time I should see two outputs at the end, which will say this is from camera class and this is from phone class. Of course, if I had uncommented, then it would by default say whatever the super class, that is the first one listed in the bracket here. So let's go try this one last time. We should see three outputs at the end, and this is the one that's coming or picked up by default in when you say cp.printDetails. But if you want explicitly like this, you should call it via the class name by supplying an object. Python has a default support for a database called SQLite, and SQLite is a C library that implements small, fast, self-contained, high reliability, full-featured SQL database engine. When you create a new database, it becomes a file in your operating system, so it's going to be kept in whichever the location you want. But in order to view the contents of your file in a user understandable format, you either require to use a CLI called SQLite CLI. It's a command line interface, or you can use something called DB browser, which is a GUI which simply opens the file and then shows the content such as tables and rows and columns. You can edit them, you can add new rows, you can basically manipulate all of them. You can as well run the SQL commands here itself. However, what we want to do is to use this to view the contents created using our Python scripts. Let's go to our Visual Studio Code and then create a new script file. This time it's called ex27.py. And as I mentioned earlier, Python library includes the SQLite 3 module. So I can say here from SQLite 3 import a function called connect. This can be used for connecting to any databases that you have, like MySQL or SQL Server, by supplying appropriate parameters. In case of SQLite 3, you simply have to say some variable con equals to call the connect function, supply the path to the SQLite 3 DB file. So I'm going to just give a name called mydb.sqlite or SQLite 3. The extension doesn't matter, it's your choice. And let's go and see what happens at this point in time. So if you simply exit here, or if you say con.close and exit, this would have created a file called mydb.sqlite3 in your work folder, because I didn't mention the actual path. So it's as well as / if you feel like. We have a connection object that represents a channel of communication from your Python program to the actual database file. But in order to execute any SQL commands over this connection, we have to create something called as a session, and we generally call here a function called cursor. So you can say con.cursor, and this returns what's called as a session object. We call it as a cursor. Let's call it as cursor itself, like this. The name can be anything you want. And now I can simply say cursor.execute an SQL command. To start with, let's go and create an SQL command which creates a table. I'll say SQL cmd equals to, I can use this multi-line text by using this triple single quotes or triple double quotes, and then write the SQL command create table, and then the name of the table. Let's say for example I want to create a table that represents some details of contacts, so I'm going to say contacts, and that's the open and close bracket of the table. And then I can type here ID is an integer, and then that's also a primary key, and then it's also supposed to be automatically incremented, so I can say auto incremented. Now these commands may have a bit of variations in different database management systems, like In MySQL, it is called auto underscore increment. Here it is called auto increment without any underscore in it. Oracle, for example, doesn't have this concept of auto increment at all. In Microsoft SQL Server, you may call this as identity. So you may have to refer to the syntax of appropriate DB engines that you're working with. Since SQLite 3 is what we are using, the syntax is over here. However, if you want to be familiar with the commands, you can always go back to the SQLite homepage. You can see that there is SQL syntax and there is a bunch of options that you can see here, like create table command. So if you look at the create table commands, they have here few options that you can try, and there are few examples also as you scroll down. Let's come back over here, put a comma, define a second column. So I want to say here name, which is a varchar of 50 character, and if I want that to be not null, I can say not null. Let's add email, which is another varchar. Let's put 255, which is the maximum for varchar. So I'm going to type here unique as well, so that there is no duplicate emails. Let's also type phone, which is another varchar. Maybe around 50 characters is enough. That's also supposed to be unique. Let's also add city, which is a varchar of, let's say, for example, 50. I can also say defaults to, say, Bangalore. In order to execute the command, I simply have to say cursor that we have created dot execute, and then I can type here SQL underscore CMD. In case if there is an error, this would raise an exception. So what we can do is we can say here try executing this, and if it is successful, then let's print a message saying that table created. In case if there is an error, so the raised error, you can handle that using except and type here exception, whatever we got. You can even say exception as EX, and then you can print what went wrong. So you can say there was an error, and the details of the error you can say print EX. So that EX is an object of this exception, whatever was raised by this execute command. And now we are actually trying to print the details of the same. So this is the end of the script here. I should have ideally put everything in the main function and then called it. So what I'll do is I'll just select all this code, indent it, define a main function, and then call that if this is the script that we are running. So we'll say if dunder name equals to dunder main, then we'll say main method. So we're going to call the main function. Let's go to our command prompt and then try running the same thing. So it is ex27.py, and let's say if you check ls-l and then star.sqlite3, you'll see that it says that there is no such file found. But if I'm going to run the script, so Python3 ex27.py, hopefully the file gets created, and you can see it says table got created. But if I check the same command now, you should see that there is one file called mydb.sqlite3, which is around 20 kilobytes. Now that this file exists, we will not be able to see the content of that directly, because if you type the command cat and then check this out, it's going to just display some junk characters. You can also go to the VS Code and see if that can help, but you can see that it says the file is not displayed in the editor because it is either a binary, but basically it says that I can't read this because it's a binary content. Now this is where we will be able to go to DB browser for SQLite and then go to the download section. If you're using Windows, there's a lot of options you have here. For macOS, there is one option. So there are other options for Linux and other operating systems. So I'm going to just quickly download this. Download and installation options will be same in all the operating system, I guess. So let's go click on this DB browser for SQLite. It's downloading some content here, and once the download is over, click on that to open the same thing, and it begins the installation. Let's go through the installation procedure. It has been done. I'm going to just drag and drop on this applications folder for me, and now I have this DB browser for SQLite. So let's go ahead and open the same thing. So I'm going to just say DB browser for SQLite. And when it opens, I'm going to select the file from here. So it says that open database, and I can click on that to choose my DB file, which is there in my desktop. I go to the desktop, Python examples, and the file that I want to open is this mydb.sqlite3. And you can see now it says that there are two tables. I created one, which this was an automatic one because we have a auto increment here. So the auto increment requires a sequence. It has created that. Let's click on this contacts, expand the same thing, and you can see that there is an ID integer and the column definition also you can see here. So there is an ID, you can see name, email, etc. The part associated with this particular field in the actual SQL command is also shown over here. That's a nice one. So we are able to see the actual table here. We also can go to the browse data here, and it says that there is no data, but I think I can click on this new record to add the same thing. But we will write our own Python script such that we can add new records, edit or delete records as well. So in the next video, we'll see how to insert data into this table using a Python script. Now that we have a table in our SQLite3 database file here, mydb.sqlite3, so let's go create a new script file which allows the user to enter details such as name, email, phone, city, and then adds that as a new record to our contacts table. Remember, ID is an auto-generated one, so we don't have to really accept this from the user, at least for adding. So let's go create a new file called ex28.py. And write a couple of functions. So the number one function is supposed to get the details of the contact from the user in a tuple format. So let's type here def get contact, which is going to ask the user like name equals to input, enter a name, and then likewise I'm going to copy paste the same thing for this is going to be email. We have a phone, and one last is the city. City by default would be Bangalore, but we are accepting the details from the user. And simply I'm going to return a new tuple consisting of name, email, phone, and city in that sequence. Now the sequence is important because this is the sequence in which we would be adding to our database as well. The next function is going to be our main, where we're going to call this get contact. Let's call it as contact equals to get underscore contact. We also want to open a connection to our mydb.sqlite3. So for that, I can say from SQLite3 import a method called connect. And now I would say here con or some variable equals to, I can say connect, and the file name happens to be mydb.sqlite3. Now that I have the connection, I have to execute an SQL command over here. And the command itself, you can say SQL or command, whatever the variable you want. I'll type here insert into contacts. The columns that I want to insert is name, email, phone, and city. Now the reason I need to give this is because we don't want ID to be supplied. So in case if I didn't supply this, then it will also expect that you supply an ID. So I'll just say undo, so because I want these values. And now I'll say here values, and then we use what's called parameters. So for SQLite3, it's like question mark, question mark, question mark, and question mark. So we basically say that we don't know these values, so these are unknown. They are called parameters. If you're using MySQL for the same thing, they have to be used as percentages, and %d and etc. So depending on the data type of this. So SQLite3 has a simple syntax that says, hey, I don't know these values. You're going to supply when you execute, and in order for us to execute we need a cursor. So we say here cursor equals to con.cursor. Now that cursor exists, we can try executing this by typing curse.execute. The command is this, and the tuple that contains values for these parameters is our contact object in the same sequence I have here. So I just have to supply the tuple like this, contact. If this is successful, then I can say print data inserted. In case if there is an error, you can say here except exception as ex, some variable, and then we can say print ex. Because there was an error, we can print the error directly like that. One last thing we have to do is to call the main function so that we can run this. So we say here if dunder name equals to dunder main, then call the main function. So one last thing that we have to do is once the command is executed, they all stay in this session object that's in the memory. In order to flush this back to the DB, you have to do a commit. Let's say con.commit. And if in case of an error, you go to this exception block. Because there was some error, Some commands probably were successful, some commands were failed. Then I can say con.rollback to say that all the statements must be inserted or all the statements must be cancelled out. So that's why we say rollback over here. Let's go give it a try. So command prompt. I'm in the work directory. As you can see, I will run my script Python3 ex28.py. Press enter, enter a name. Let me enter my name, email, phone number, and city, which is Bangalore. Enter. Let me enter one more, and this time I'll say Sham at example.com. Let's type some number and then press enter. Let's say Shimoga. Press enter. It says data inserted. Let's go and check if it has inserted successfully using our DB browser, so which is here. It's already pointing to contacts table, and I just have to click the refresh button. And when I click the refresh button, you can see that ID is auto-generated as 1 and 2, name, email, phone, city, everything that I have got. If you want to see if Bangalore, which is the default, gets added or not, you may have to make one small change. So we don't want to accept city from the user because it's going to be default. And I shouldn't be giving this value over here. And because I have only 3 columns, I don't want to really give the 4th one here. And now this also has no city, so it's just 3 parameters here. So there's a tuple that consists of 3 members, and those 3 will be inserted in the same sequence. Let's give it a try and run this. Let's say, for example, I type here Ramesh, email ramesh at example.com. Let's say 9988776543. Press enter. It says data inserted. Let's go back to the DB browser and then click the refresh button. You can see that Ramesh record has not only 3, which is auto-generated, but it also has a city of Bangalore by default. Now that we have few records, let's see how we can retrieve the same using a Python script. So first, let's say we want to accept an ID from the user, which is going to be unique. Either it is found or not found. But if it is found, I want to print the details of the same. So let's go take an example here. So I want to create a new file. Let's say ex29. So I'm going to create a new one, ex29.py. And as usual, you can say from SQLite3 import connect. And let's say we want to write everything in the main function. So let's say def main. And the first thing that we want to do is to accept an ID from the user. So I'll say ID equals to, you can say int because it's a numeric value of input, enter the ID for searching. Now that we have the ID, let's write an SQL command. So let's say cmd equals to select star from contacts where ID equals to question mark, because we don't know what is the value for this. So it is entered by the user. One thing that you could probably do is you can also say plus ID like this if it were to be a string, but we generally don't do that because this is a cause of something called SQL injection. I'm sure if you look in the Google for SQL injection, you'll get a lot of inputs. But for the time being, let's go and say question mark. Now we want to supply the value for this question mark when we execute this. Before executing, we need a cursor object, and a cursor object is created using a connection. So first, let's say connection equals to connect and the name of your file, which is called mydb.sqlite3. And then you say here cursor or session, whatever the name you want. Let's call it as cur equals to con.cursor. We got the cursor, and now we have the command, we have the parameter. All we have to do is to execute this. Once again, I can say try, and then I say cur.execute, the command that I have to supply, and the values for that must be a tuple. So in order for me to create a tuple with a single value, I have to say ID and a comma. If I don't use comma, then it will be assumed as an int, but because I have used an ID with a comma, so this will now be considered as a tuple, and I supplied a tuple here. You could also try sending a list, in which case I don't have to supply the comma. We know that if the command is successfully executed and we got a record, we will be able to get only one record. The cursor has functions called fetch one, fetch many, and fetch all. In this case, I want exactly single record. I can say here fetch one like this, and then assign this to a variable which is going to be a contact variable. The variable is going to contain a tuple consisting of all the values corresponding to this ID. So in case if I had given 2, then I will get a tuple consisting of 2, Sham, his email, his phone number, and city as the value. So that's a tuple here. Let's print the same. So I'm going to type here print name equals to, and since we said star here, all the columns have been retrieved as a tuple. So the tuple's first element, that is at index 0 you have an ID, index 1 is the name, and so on and so forth. So we're going to say here name equals to C1 of 1, and then I copy paste this few times. This is going to be city, I have email and phone number, and the sequence will be 2 for city, 3 for email, and 4 for the phone number. We also want to handle the exception by typing except exception as ex. Print in case of any exception. Come out of that try exit block and then say con.close, and then let's call the main function if this is the script that we are running. So if dunder name equals to dunder main, then we want to call the main function. Let's give it a try by going to the command prompt. Notice that I'm already in my work directory. So I'll type here Python3 ex29.py. It'll ask me the ID. I'll type 2. And now you see I got the details of that person. But in case if I run the same thing by typing 22 where I don't have the ID, you'll see that it says none type object is not subscriptable. Now the reason for that is when we actually called this function, when there was no data, this became none, and this is giving the error saying that C1 is a none and that has no subscript. That's the error. And because that was an error, that error went over here and then we printed that error. But now I know what is the actual problem. I can always do this by typing if C1 is none, then I can type here print no data found for ID, and then I can supply what is the ID that is given by the user. Else I want to print all this, so I'm going to indent this so that they all become part of the else section. Let's give the same thing, clear the screen, run the script. I enter 2, I get the output. I enter 33 and it says no data found for ID 33. Now that we have seen how to handle a query that returns exactly one record at the max, we will see how to handle queries that return multiple rows. For example, I want all the contacts from a particular city or all the contacts in general. So I can go to a new script file here, so ex30.py, and we're going to say from SQLite3 import connect, which is a function. Let's create a def main, and inside the main we want to open the DB connection. So we say connect and then say /mydb.sqlite3. The return value, let's assign this to con, and then we say con.cursor to open that cursor. The SQL command that I'm going to use doesn't have parameters because I simply want to say select star from context. But in case if you have parameters, then use a tuple to supply the values for those parameters. First, let's assign this to a variable called cur, and then I can say cur.execute, and the query is select star from contacts. If you want, you can say order by, but by default, it is the order in which it's been added will be the one in which it is retrieved. So once you execute this, we can access the very first one by using the fetch one, but in this case, there is going to be multiple records. Obviously, because there's a multiple records, we need something that we can iterate over. So cursor has a function called fetch all and fetch many. Fetch many basically allows you to supply how many you want. For example, if there are 100 records, you want only 10 of them. So you can specify for fetch many. Fetch all basically gives me all of them. Anyway, I have only 3 of them. But this being an iterable, I can say here for C in cur.fetchAll. So now we'll be able to access the very first record of this iterable into C. And now I can print the details. Now to print the details of the same, I will copy the print function that I had over here. I'm going to copy this and then colon and paste over here. Of course, I need to indent them properly. Now that I got this, let me also add one print, a blank line, which consists of around say 50 characters. And now when the loop proceeds further, from cur.fetchAll, second record is assigned to C, which is actually a tuple, and you can see that I've used here C1 everywhere. Now either I can change this to C1 or change this to C everywhere. Let's keep it as C1. So C1 now represents the second record, and second record gets printed, prints a new line, goes back, gets the third record, and so on and so forth. Now if you're wondering, will this function be called again and again and again? The answer is no. It returns an iterable, and the iterable is placed in that place, and then C1 iterates over that iterable. Once the for loop is over, I don't have anything else to do here. I can simply say con.close. By that time, all the records have been processed already. So let's go and call this def main again. So I'll say if dunder name equals to dunder main, then I'm going to call the main function. Let's go and try this ex30.py. So I'm going to clear the screen, Python3 ex30.py, press enter. You can see all the three records from the DB have been accessed successfully. Let's write another script to see how we can ask the user to update an email. So let's go back to our editor. Let's clear all this finished code. I'm going to create a ex31.py. And let's say first from SQLite 3 import connect. Let's define the main function. Let's say we want to accept the ID and the email. I'll say ID equals to int of input, enter ID for searching, and then email equals to just an input, enter the new email. Now that we have accepted these, let's open the connection to the DB. I'll say con equals to connect to our current database, which is mydb.sqlite3, and then we say here cur equals to con.cursor. Once the cursor is open, we need to build an SQL command as well as supply those two parameters. In this case, the SQL command is nothing but update contacts, set the email equals to question mark where ID equals to question mark, and then I'll say cur.execute. We need the SQL command and a tuple consisting of values for these two parameters in the same sequence, which happens to be email and ID. There is a possibility that this may raise an error, so we'll always put a try block for the same thing. And then we say that, hey, if any exception is found, we simply print a message. But if you want to know what actually is the error, you can say exception as ex and print that ex so that we know what exactly happened. If there is everything okay, we say here print email updated successfully. At the end of this, we will also do a con.close. Very importantly, if it is successfully executed, we also have to say con.commit. Otherwise, the changes will not be reflected in the actual DB file. In case of an error, it's a good practice to say con.rollback. Let's go and try calling the main function. If this is the script you're running, so if dunder name equals to dunder main, then we're going to call the main function like this. Looks everything fine. Let's go back to the command prompt and clear the screen. Python3 ex31.py, enter ID. So I'm going to select 2. Currently the email is sham@example.com. Let's change that to shamkc@gmail.com. It says that email updated successfully. Let's go back to the DB browser again. Click on the refresh button here and you will see that is changed as shamkc@gmail.com. We can also execute the delete command to delete any unwanted records. Although in practice we never delete the records because we lose out the data. In case if you actually delete the record, it's called hard delete. But what we perform generally is what's called an update of a flag. Somewhere we'll have a column here called is active or something like that, where a true means that the record is active, false means that the record is inactive. It's only kept for backup purposes. For example, if you have an employees table and there are thousands of employees in an office, and if somebody quits the company and if you delete his or her record, then you lost the information forever. In case if you want to get some reports in the future for those quit employees, you will not be able to get them. So what we generally do is we add an additional column to that particular table saying that is active or something like that, which is basically like a true, false or 1, 0 kind of values. And whenever we want to actually access the details, we'll simply say, give me all the records where flag is 1 or is active is 1. But in case if I want to access a particular record who has quit the job, then we can access them based on their ID, so it doesn't matter. In any case, let's see how to do a hard delete this time. So let's go back to our VS Code, create a new script called ex32.py. First, let's say from SQLite3 import connect, and then we say def main, where we want to accept the ID from the user. So I'll say int input enter ID, and then I'll say con equals to connect to ./mydb.sqlite3. Once I have opened this connection successfully, I will create a cursor, which is a session. This is required because all SQL commands will be executed within a given session. So we say here con.cursor. Once we got it, we now have to execute the command, which is the delete command. We'll straight away say try deleting this record. So I'll say cur.execute delete from contacts where ID equals to question mark. That's the command. But then we need to supply a tuple here. We have to say ID and a comma because there's only a single variable in the tuple. If everything is okay, we have to say con.commit. If the commit is successful, we'll say print record deleted successfully. And in case if there is an error, let's get that error as ex and then print the same thing that there was an error. We'll also say con.rollback. At the end, we'll also do a con.close. And then now we have to check if this is the script that you're running and not importing another modules. So we want to run the main function. So we say if dunder name equals to dunder main, let's say call the main function. So everything looks okay. Let's go back to the command prompt and let's see if we can delete that. So Python3 ex32.py, enter ID. Let's say ID number 3 I want to delete. It says deleted successfully. If I go back to the DB browser and do a refresh, you'll see that the record 3 has gone. If I try deleting that again, let's see what happens. And you can see that it says deleted successfully, which is wrong. Whenever you do an update or delete, you can also get the number of rows that got affected. And based on that, we can check. So let's go back over here. After executing, we can check here what is the row count. Let's go and check. If cur.row count equals to 0, that means there was no record. So I can say here something like print no rows deleted. But in case if the row count is not 0, probably 1. So we say else, and then this is where we're going to do print record deleted successfully, and then we do a commit. So let's go and try the same thing once again. Let's try deleting the record number 3. So it gave an error. So it says that the row underscore count doesn't exist. It's actually row count without an underscore. Let's give it a try once more. And then it says here 3, it says that no rows deleted. But if I run this and say 2, you can see that it says record deleted successfully. So if I go back to the DB browser and then refresh, record number 2 also has been deleted successfully. When you install Python on your machine, it also comes with an executable module called pip or PIP, which stands for Package Installer for Python. So typically you should be able to get this using the command called pip --version. But in some cases, due to the setting of path issues, you may not get this kind of output. in which case you can always say Python 3 -m to execute a module called pip, and then you can give the options for the pip command, in this case version, and you can see I get the exact same result. I also have Python 2, so if I type here Python, it corresponds to Python 2, and then I say -m pip -- version. This should give me the version of Python 2.7 pip module. General use of the pip command is to install and uninstall packages, mostly the third-party packages. So to see what are the packages that are currently installed on my computer, I may say here Python-m pip and then give a command called list. That's going to show you the list of all the packages that have been installed on the computer. These are the packages that have been installed on Python 2. So if I run the same command using Python 3 -m pip space list, you should see a smaller list of packages that have been installed on Python 3. We can also install any other third-party packages, but in order to find out where are the packages, let's go to the python.org website, and you can see that there is one small link here called pyp, which is basically Python package index. So if I click on this, it takes me to a different website called pyp.org, where you can find, install, or publish Python packages. So if you want to publish your own packages, which we will do in the subsequent videos, you have to create an account and log in, and then you will be able to see all your packages. As you can see that there are over 200,000 projects, over 1.5 million releases, and so many files and users. You can search for literally anything that you're looking for. For example, if I want to get data from an Excel file in a Python script, so I can just look for Excel and press enter. So maybe the first one I can just check it out here. So by click on this link, it shows that the command is pip install Excel. If you're using Linux or Mac, pip may correspond to Python 2, whereas pip3 refers to Python 3's pip command. The best way to do is to say Python-m pip install Excel or Python 3 -m pip install Excel. But anyway, so you can just read the description documentation of what actually it does, and you can see that it has not given a very good documentation. Let me go back and then select the second one. So again, probably may not be useful for me because I can't understand much of the Chinese language here. So let's go and check the third one, and you can see that there are little documentation over here as well. So the better way to look for these kind of packages would be to go to stackoverflow.com and ask the question. For example, I can say Python read Excel file, and then I say plus Stack Overflow. I should get a good help from this particular community. You can see that there's a recommendation here. I highly recommend XLRD for reading. So let's go back over there and then look for XLRD. You can see you got a list of 115 packages, but the first one should be the good one. Let's go click on this. Not much of a documentation though here, but there might be a link to this home page, so I can probably go to the home page. And then you can see there is probably a bunch of documentation, etc. is available. However, you can go on doing some research on which could be the better one. Like there is a pandas that you can use and so on and so forth. You can see. So a lot of people have helped with XLRD. You can stick with that. So for the sake of demonstration, I would be looking for something called requests. So I'll type here requests, which is a Python package which help us act as a client to any RESTful services. So if I click on these requests, here you can see there's probably a good amount of documentation, some examples. Also the home page, if I take, probably it should give me a good enough information. So this looks a very legitimate module and a package, and I have used this in many occasions and it's really a good one. So let's see how to use this on our computer. So first thing I have to do is to install this. So I go back and I say here Python 3 -m pip install requests. If you are having a specific version, then you can also say @ and the version. By default, it gets the latest version, whatever is available. Now this may require administrative permission on Mac. Let's first give it a try and see if we get an error. We will use the sudo command. As you can see that it gave me an error, could not install packages due to environment error, permission denied. So that means that I have to give a sudo prefix. So let me clear the screen, run the same command using the sudo option, press enter, I give my password, and now we see that it is installing the same thing again. And this time there should not be any error. It said finally successfully installed whatever the requests package and couple of other packages. You can see that the request had dependency on some other packages. Along with that, request is also installed. Now if I go and check pip3 list, you should be able to see that those packages that we saw have been installed. Of course, I can say here Python3-m pip list to do the same thing. Now if you want to uninstall any of these packages, you simply have to say pip3 uninstall and the name of the package. So now that we have these requests, note I am right now in my home directory, not in my working directory. I can go to any directory and I should be able to access this particular requests. So let's take an example. Let me switch to my work directory. So I'll get into a CD, desktop, Python examples, where I have all my files. As you can see that all our examples are there. Let's go to Visual Studio Code and create a new file, ex33.py, make a request to a website which gives me a random user all the times. There's the link randomuser.me/API. If I keep refreshing, each time I refresh, you can see that there is a new set of data. It's just a random dummy data. We want to get this data in our Python code using this request. So let's go and try the same thing. I'm going to open the Visual Studio Code, create a new file called ex33.py. And the first thing that I have to do is to import requests. So I can say import requests. And this is the URL, which is https://randomuser.me/API. That's the URL which gives me the data. So in order to make a request, we'll say here requests.get, because I want to make an HTTP GET request to this URL. The return value of this function is something like a response. Let's give it as resp equals to. The response consists of various properties or attributes, such as, for example, what is the response code or headers, response text, any other additional attachments, and so on and so forth. But we are only interested in the textual representation of what the response came as. So I can simply say here print resp.text. It'll give me the response body. So let's go give it a try. So I go to the command prompt, clear the screen, and then run Python3 ex33.py. I press enter. Hopefully I should be able to see some result on the screen. As you can see, whatever we saw on the browser, we are able to get the response as well. But the whole thing here is a string. If you want to get, for example, the first entry, which is the results, and there is a list that consists of n number of users, I believe by default the random user.me gives you one single result unless you say I want more. But let's say I want the name of the person. So for example, there is a first name. In order to access this, I may want to convert this into a dict, and very easy. You just come down here and then instead of this you can say JSON, which is a function that you call. It returns a dict. Then you can access that individual values. Let's go back and give it a try. And you can see that this time I should be getting all in single quotes because it's the result of a dict. They look alike, but this is a dict. I can navigate to this particular first name of the person by using results of 0, because results is a list, results of 0, and that object has a property called name. So let's give it a try. We'll assign this resp.json to a variable. For example, let's say P1, which is a person, is nothing but this resp.json of results. And then I say here, give me the 0th element, which happens to be the first person. And now I can say print P1, which is a dictionary. And then I can say, give me the name property of the same. So results corresponds to this entire list here. The results of 0 corresponds to the only object that is there inside that. In that, there is a property called name, which is again another dict, but that's okay. So we want to try that. So let's clear the screen and try this once more. and you should now see that there is a title, first name, last name in the form of a dictionary. Now that we have seen how to install a third-party package, we can also see how to uninstall the same thing. Let's go and try the same. So this is pip3 list will give me the list of all the packages that are installed on Python 3, or I can say Python3-m pip list. Now, in order to uninstall a package like requests, so I can say pip3 uninstall and then type the name of the package. In my case, it's the requests. And when I press enter, it says, would you like to remove the packages? So I'll say yes, I want to remove. It is giving an error probably because permission denied. Again, I had to give the sudo command. So let's go retry that with the sudo command. And this time, hopefully it should work without a problem. It says successfully uninstalled requests. On Windows, you don't have this problem. You just have to say pip3 uninstall request. Of course, on Windows, you would as well say pip uninstall instead of pip3 uninstall. So let's go and check what are the packages now currently available. Pip3 list, and you can see that the other packages that came as dependencies are still there. If you want any help on these commands, you can always check here Python-m or Python3-m pip and then say help. You should be able to get some help on this. And if you want help on specific command, you can also say here Python3-m pip uninstall is the command that I want, but just don't type help because then it will assume that you want to uninstall a package called help. So we have to say --help, and this is going to give you information or help on the specific command that you asked for. So you can see it says usage is so and so. There is a description, uninstall packages, and then there are some options that says that uninstall all the packages listed in the given requirements file in case if you have a requirements file, and few other options that might be of some help here.